Look, Python is the most popular programming language in the world, as long as we exclude all those pesky front-end technologies. It's one of the easiest programming languages to learn, and it's also used by millions of developers around the world for things like back-end development, DevOps, data science, and even AI. Now, what if I told you that TrashPuppy could teach you everything that you need to know about Python in the next 7 hours? Well, if I did, I'd actually be lying. It turns out there's a lot to Python. But you can, in the next 7 hours, learn to be very dangerous and learn enough that you can actually go build your own projects. It's important to understand that this course won't just teach you Python, but it will actually teach you coding fundamentals and computer science basics that apply to any programming language, even something like JavaScript or Go. We're not assuming that you have any prior knowledge, so this is really the perfect place to start your coding journey. I've actually developed this course with the help of 6 other professional software engineers. And today you'll be guided through that entire course by TrashPuppy for free here on YouTube. She's an absolutely fantastic developer in her own right, and most importantly, is an entertaining explainer of things. Over the last 3 years, over 10,000 students have actually taken the interactive version of this course over on boot.dev. And we've taken their feedback and rolled it all in with a bunch of improvements into this course. So you're getting a really battle-tested, up-to-date version of this Python course. And one more thing, if you're into passive learning, and what I mean is if you like watching videos of other people coding, but you don't really like coding yourself, well, this course is probably not for you. This course is very hands-on. We'll be doing over 100 challenges and quizzes. If you're not ready to sit down and type at your keyboard and actually write some code, this probably isn't the place to be. So there's basically just 2 different ways to approach this course. The first is to watch TrashPuppy explain a lesson and watch her code the challenge and to follow along on your own machine. While that works, I wouldn't recommend it. Option number 2 is to actually solve the challenges on your own first. You can watch her explanation of the concept, then solve the challenge or do the quiz, but do it on your own first so that you're not building up a reliance on the tutor, right? On TrashPuppy, you're actually able to write code on your own. By the end of this course, you should feel comfortable writing your own Python code. So I'd recommend going ahead, doing it on your own, and then coming back and watching her explanation. Finally, it's important to note that this course is actually just the very first in an entire backend development career path over on boot.dev. So if you like this course, you might want to go check it out. We teach everything that you need to know to go from 0 to hireable as a backend web developer. So you can head to boot.dev and check that out. If those 8 characters are too hard for you to type, the link is down in the description below. Now, this is actually surprising to a lot of people, but all of the content on boot.dev is actually free. So all of the lessons, all of the text, all of the videos, even this video here that we're publishing on YouTube, it's all free to access. A paid membership gets you access to all of the interactive content on the site. So things like the AI chatbot, solution peeking, the ability to track your own progress, run your code. All of that stuff is bundled in the subscription. If you do want a membership, just use code TrashPuppy at checkout. It'll get you 25% off your first payment, and it will also support TrashPuppy directly. A membership is completely optional. You do not need it to watch the rest of this course. So without further ado, thank you to TrashPuppy, and let's jump into the course.
Hi, my name's TrashPuppy, and we're going to be learning some Python together. So for this first assignment, all we have to do is welcome players to our fantasy game, which is called Fantasy Quest. So we're just going to type that message here, make sure that it's typed out correctly, and when we hit submit, this should run. And boom, we get a bunch of confetti. So, are you ready for your first bug? If you don't know what a bug is, it just means that something in your code is causing it to either not run at all, or it runs, but it's not doing what you thought it would do. So for this assignment, all we have to do is find the bug in our code and fix it. Before we just go to the code and start scraping through it, trying to find it ourselves, because theoretically, this could be like hundreds of lines of code, right? You don't want to try to find a bug all by yourself, just, scrolling through a bunch of code. It's better to just run the code as it is because you might get an idea of where the bug's at just by doing that alone. So we're going to run this. And if we read the output, we can see that our player's health is 100. They're hit by a sword for 10 damage. And then their health goes up to 110. So that's where our bug is. Now that we know, we can find the bug real easy. Now this is like I said, this is not a lot of code right now, but if it were hundreds of lines of code, we probably would have a good idea of what the places in it where this bug might be happening. So it just makes it a lot easier to find. All right. So we know that our sword damage is 10. That looks right. Player health is 100. That looks right. Health after attack is probably what we're looking at. And we can see that it's set to the player health plus the sword damage. So that's our bug right there. All we have to do is change this plus sign to a minus sign so that the maths out. So the maths out correctly. All right, let's pull this up because we're gonna run it again before we submit just to be sure. Boom. Looks like their health is now down to 90. So that makes sense. We can submit. Yay, confetti. I love the confetti. All right, so we talked about it a little bit earlier, but we're gonna talk about the console a little more. So the console, like I said before, is where our code is going to be outputted. The only thing that's going to be outputted to it is what we tell Python to output to it. So for example, if I write this code here and it's just setting answer to 2 plus 2, if I run this, it's not going to show up in the console. Python is still doing the math. It's still adding these up and saving the answer of 4 in this variable, which we'll learn about later. But if I don't print this to the console, it's not going to show up. So all we have to do is add our little print statement, which we've already seen. And we'll just print the answer and run that. And now we get 4 down there. So for this assignment, all we have to do is print another message to our player. We just want to tell them how to use their arrow keys to move around in the game. So we're just going to do the same thing with our print statement, but this time we're going to add the message in there. Use the arrow keys to move. Let's run it first. And that looks good, so let's submit it. Yay! Got him. So why are we learning Python? Python is one language out of many, but it's especially good for people who have never coded before because it was designed to be simple to write and simple to read. But that doesn't mean that you shouldn't take Python seriously. Python is well known for things like machine learning, data science, cloud engineering, scripting and automation, and it can even be used in back-end web development. Now, when I'm talking about back-end development, back-end and front-end are terms that you're gonna hear as a programmer. And what they basically mean is code that's done on the back-end is code that doesn't normally or doesn't produce a visual interface for like a user, whereas code on the front end is used to produce visual interfaces like websites or desktop apps, that type of thing. Oh, look, I got a new quest. Python is not usually used on the front end to make visual interfaces, but it can be. It's just not that common. So now that we know a little bit more about Python and what it's all about, let's go through these questions. Python is not often used in front-end apps, like we just talked about. Nice. Python is known for being simple. Simple to read and write, because that's how it was designed. Nice. So now that we've talked about Python and why we're learning it, let's talk about what code is in general. So I drew a little picture for you. Let me pull it up. Boom. When we talk about code and learning how to code, we're actually talking about source code and learning how to write source code. So source code is the code that we write as human beings that we can read and understand, but it actually has to eventually be converted into machine code because a computer can't read source code like this. Computers only understand ones and zeros. That's why they're called binary computers, because all they can read is binary. So we write source code because we can't understand binary, and then that source code is compiled down to machine code. It turns into a bunch of all the instructions that we write in our code turns into a bunch of instructions that the computer can understand. A lot of these instructions are math-based equations. In fact, most of them are going to be math-based, but you can also have the computer do other types of equations. So let me show you an example, because that probably didn't make a lot of sense. Like we've been doing, you can print messages, right? So I can print hi with this print function, and it'll print the text hi down into the console. But in the print function, you can also put other types of data. So if I wanted to put a number in there, it'll print the number for me. If I wanted to do a whole equation in here, it could do that too. And it's not going to print the equation 4 plus 5. It's going to print the answer 4 plus 5 to the console for us. So that's kind of cool. Computers are freaking rad. All right, so now that we've talked about that, what is our assignment? It's common in video games to do basic addition. For example, we may need to calculate the additional damage a sword deals when it's enchanted with a spell. So our player's sword does 250 damage. When they enchant it, it does an additional 75 damage. So we're going to print that enchantment result, the total, to our players so that they can see how much their damage has gone up with the new enchantment. Just like this. Nice, so 325. If we submit this, it should go through. Yay, good job. So just like human language, coding has syntax, and I'm gonna explain syntax before we go into syntax errors. So let's go to my drawing down here. This is an English sentence that is all jumbled where the words and the parts of it are just all over the place. It doesn't make sense right now, right? So even though each word and each punctuation point are technically correct in and of their own right, if we put them into any sort of order that we want, that doesn't mean that it makes sense, right? So they're all, each word is correct, but the order is not correct. This is the idea of syntax. So in language, syntax just means that the structure of the sentence makes sense and is correct. Now, if we change this around to make it a legitimate sentence, boom, the puppy is sleeping. Now we know what it's saying, and now it has correct syntax. So this might seem kind of dumb to you right now, might seem a little too simple, but the reason I'm showing this to you is because coding is the same way. Every coding language has its own rule set for syntax, which just means the rule set that determines how an expression or a statement in that language is correctly put together, if that makes sense. So let's look at this right here. If you look at this print statement and we try to run this code, we're going to get something that's called a syntax error. And all that means is that we didn't put this statement together correctly. We're missing something. Something about the syntax rules have been broken for Python. And Python is nice enough that it's actually going to give us the syntax error and tell us exactly what we need to fix. So in this case, the closing parenthesis, which is a bracket right now, does not match the opening parenthesis, which is a regular parenthesis. So all we have to do to fix this is replace that end bracket with our parenthesis, and now our statement, as far as Python is concerned, is syntactically correct. So if we run this, it'll run, the code will be working, and now if we submit, yay, we got it, because we fixed the syntax error. So we made it to the last section of the first chapter. Congrats. We're going to talk a little bit more about syntax errors, and we're going to go through this quiz. But first, I want to show you something about syntax in other languages. So the syntax in one language is going to be completely different. The rule set, at least, is going to be completely different for another language. So like we've learned already, to print the line hi in Python, it just looks like this, right? That looks so good. There, like this. It's going to look completely different in other languages. So if we were to print this, if we were to do the same type of instruction in Go, which is another language, it's going to look like this. We have to say print line. We need double quotes. So that's what Golang would look like. And then in Fortran, which is an even weirder, crazier language, the syntax is even weirder and crazier. We do print, we have a star, and then a comma, and then we have our string hi. So I just wanted to show you that because the syntax rule set is going to change for each program, each language. And if you tried to write, let's say you're writing a program in Go and you tried to print a line using a Python syntax, you would get a syntax error most likely. So let's go over the quiz questions. We should know them all pretty well. What does syntax mean? Syntax is the rules for valid code in a programming language. Now you could maybe say code that produces the correct output, but that wouldn't be exactly right because there's a lot that goes into code that produces the correct output, and syntax is only one of those things. So let's say this first one. And then the next question, what happens if you try to run code with invalid syntax? you're going to get a syntax error like we saw in the last section with Python. Nice. Good job. Now we can do chapter 2. All right, welcome to chapter 2. The first thing we're going to talk about are variables. So far in the course, all we've been doing is printing straight data to the console like savages. But there's something better we can do, and that is using variables. So if you don't know what a variable is basically just something that will store data for us so that we can use it later throughout the code or refer to it or change it or pass it around. Let me give you a little example through doing the assignment. For this assignment, all we have to do is print the player health and set it equal to 1,000. So when we use a variable, we're basically just taking data and giving it a name. For this example, for this assignment, the data would be 1,000, right? That's our data. Instead of just printing 1,000, let's give it a name. We're gonna call it player health, and we're gonna set that equal to 1,000. Now, anytime we wanna use this value or this data, we have a name to use. So we can, like I said before, change it, pass it around, use it repeatedly throughout the code without having to like hard code the data like we have been doing. So let's run this. Nice, we got it printed down there. If we hit submit, it should work. Yay, nice. We're gonna talk about variables a little bit more in the next section as well. So why are they called variables? Variables are called variables because they can hold any type of data. Their value can change, so it just varies what they are holding, if that makes sense. For this assignment, I'm going to show you what I mean about we can change the variable and what it's holding. All we have to do is update our player on their health while they're in a fight getting attacked by something, right? So their player health, like we had before, starts at 1,000. Under each of these comments, which we will talk about later, but just know for now that these are not executing. These lines here are not code, and the computer knows to skip them and ignore them. So the player's health starts at 1,000. We want to reduce it by 100 here because they've been hit by something or they've taken damage. So we can change the player health variable by just resetting it to a new value. We'll say, yeah, let's just say 1,000 minus 100. So I'm gonna, now that we've changed one part of the code, I want to run it and make sure that this is doing what I think it's doing. Nice. Seems to be. As you can see through these other print statements, player health is still going to be set to 900, which is how we set it here, right? So let's go another here. Instead of just subtracting from 1,000, we can even just say the player health equals 800. That's also going to be legitimate. And here we can do the same thing, 700. And one more time down here. Now when we run the code, you're going to see how the player health variable changes each time. So it starts with, well, it starts with 1,000 when the code starts executing. Then we change it on line 4 and it becomes 900. Whoops, 900. We change it again on line 9 to 800, etc. So you can see that the variable, we can do whatever we want with that data. We can change it, manipulate it, and that's why they're called variables. Let's submit. Yay, nice. So we just learned about variables and how we can change them. Let's bring a little bit of math into this. In Python and in most languages, all of the simple math operators can be used pretty easily. So we're going to do that to do this assignment. In this assignment, our player has a health of 1,000, and they also have an armor multiplier, which is going to increase their health. So we're going to add a new variable, and it's going to do some math. This variable is called, armored health. And we're going to set it to, we can use variables. We can use the other variables that we created in this next line after the equal sign. So we can say player health, times, sorry, I'm so bad at this new keyboard. Armor multiplier. Nice. Let's run it. Let's make sure it works. We're expecting 2,000, right? Nice. So you can see that this new variable, armored health, is holding the product of these two other variables multiplied together. So that's kind of cool, right? Are you starting to understand how cool and powerful variables are? So we're going to submit this. It should be good. Boom. Nice job. All right. We're going to do a little bit more math. In Python, we can have negative numbers. So the assignment for this is super easy. All we have to do is change our poison damage variable so that when it's used in this equation down here with player health, it takes away from the player's health. Because if we run this right now, it's going to give them health. So all we have to do is add a minus sign here and make poison damage set to a negative number 10. Now when we run it, it's taking away from the player's health. All fixed. So if we submit this, it should be good. Okay, so in a few of our lessons, we've already seen some comments. And I just want to reiterate, like I said before, a comment is ignored by the computer. So let me show you an example of that. We're going to put these down here. A comment in Python looks something like this. Hi, I'm a comment. Now, even though this is in our code, the computer knows to ignore this. So why do we use them? Comments are good for explaining the code that goes underneath them, or either to you who are writing the code or to other people who are reading your code. So this is not a lot of code. You could probably easily figure out what's going on here. But imagine we had a big coding project that multiple people were working on, and we've written a piece of code in there. We want to put a comment above where we've written code to explain what the code is doing. This is not only for the other people who have to read the code and are also writing it. You can also use this for yourself. So let's say the project you were working on, you come back to months later and you completely forget what your code does. You would leave comments for yourself so that future you knows what the heck is happening. So it's good to use comments, use a lot of comments. There is debate on whether or not you should use a lot of comments, but I say that you should because they don't hurt anything and it makes other people's code a lot easier to read. Now, what do we have to do for this assignment? For this assignment, there's a line in our code that is not actually code. So if we tried to run this right now, boom, we get a syntax error, right? Because this is clearly not Python. This looks like a comment that somebody made but forgot to comment out. So the computer is trying to execute it, and that's why we're getting the error. So to pass this assignment, all we have to do is add the pound sign for Python to tell it that that's a comment so that it doesn't try to run that line anymore. So if we run this now, it's working. Now if we submit, we should get it right. Yay, we got it. All right, so those are comments. We learned about variables a couple of lessons ago, but let's talk about naming them. So here I've written a couple of ways that we could potentially try to name variables in Python. This first way up here, this is the conventional way of naming a variable in Python. In Python, you can use the alphabet, you can use numbers, and you can use underscores in your variable names, and they'll be correct as far as Python is concerned. So if I were to run this, this would not crash the program, right? But if I were to run this as well, it would not crash the program. Now, if you try to put a number at the beginning of your variable name, that will cause it to break, as well as any special characters. Both of these here are not going to work. Besides those rules, Python will be fine. Now we can talk about the Python convention in naming variables. And all that means is how other Python developers expect your code to look or your variables to be named when they're using or reading your code. Technically, Python itself doesn't care as long as you follow the rules we talked about up here, but you might get in trouble if you don't use the conventional way of naming variables in Python when you're working with other people. So let's say we want variable name. That's going to be our variable. If we were to write it like this, with no sort of delineation between the two words at all, this is toxic. You will not make friends like this. So there's a couple of ways that we can delineate the two words in our variable name. In languages like JavaScript, we do something called camel case. Whoops, let's do it like this. which looks like this. We just uppercase the second or whatever words come after the first one. The first one is always lowercase and the next words are always uppercase. That's camel case. That's used in languages like JavaScript and Golang. Now, if we were in Python, Python uses something called snake case, which is like this. So if I were to make a variable with snake case, it would be variable name. And that would be the convention for Python. Now you also have these other ones. This would be screaming snake case, like this. Not really a good idea to use in Python, especially because in Python and other languages, having a fully uppercased variable name usually means that that's a constant, which is a type of variable, but we're not going to talk about that. We're not going to worry about that right now. So as you're learning more and writing more Python, you can choose how you want to name your variables. As long as you name them in a way that is syntactically correct, Python doesn't care. But like I said before, how you case them, whether it be with camel case or snake case, is going to matter for the people around you who are trying to read and use your code. It is convention in Python to use snake case, just like it's convention in JavaScript to use camel case. But you can use whatever case you want, especially if you want to be a little chaos gremlin and make other people's lives just slightly harder. You could do that. There's nothing wrong with that. So let's go back to the lesson and we're going to go through the quiz questions. All right, which of these is valid camel case? That would be this one. Which of these is valid snake case? That would be this one. And that's it. Now you know about naming variables. Okay, so far we've seen two types of variables. We've seen strings or text, and we've seen numbers and integers. But there are a couple different types of values that a variable can hold. So the string type is, like I said, just text. And the reason it's called string is because back in the earlier programming languages like C, you would have a type called a char for character. So now when we have a string of characters, we just call that a string. And it literally just means text. Now there are a couple different numeric types in Python, but also in other languages. What we've seen so far are integers, and integers are just whole numbers like this, like 5 or -5. Those are both considered integers because they're not fractional. They don't have a decimal with them. When we have a number that has a decimal in it, that's called a float. So 5.2, -5.2, those are both float types. And integers and floats are both numeric types of data in Python and in a lot of other languages as well. So another type that we have in Python is called a Boolean. And actually, Booleans are common in a lot of programming languages. If you remember before when in chapter 1, when we talked about what is code, we talked about how computers only really understand ones and zeros. And this is the idea of a Boolean. A Boolean is a type that will only hold one of two values, either 1 or 0. We also refer to this as either true or false. So a 1 is equal to true and a 0 is equal to false. So in Python, a Boolean looks not like this string here, but like this. Right now, we've just set this variable player has magic equal to the value of true, which is a Boolean. That makes player has magic a Boolean. So now that we know about these basic types, let's do this assignment. If we read down here, we can see that player health should be an integer and player has magic should be a Boolean. Well, we've already changed player has magic to a Boolean. Now, player health right now is a string type because it is holding a bunch of characters, which include characters that denote digits, right? If you have these quotes around your value, then it's a string and it's made up of characters. So we have to change this to an actual integer, and we're just going to do that like this. Now let's run it just to be sure, and we'll submit. Nice. Now we know about the basic data types in Python. Okay, we're going to change it up a little bit and talk about F strings in Python. F strings are going to allow us to use our variables within strings. So let me show you what I mean. There are a couple ways that you can do that. without an F string, if you wanted to print this sentence, my name is name and I am height tall, you would have to concatenate or use plus signs in between parts of the string and your variables to get this printed. So let me show you. This down here is my console, just like in boot dev. I'm going to run this little program, and you can see my name is TrashPuppy and I'm 6 feet tall. But doing it this way is a little tedious, it's a little toxic, so we can use F strings instead. So like I said, F string is just a formatted string, and all that means is that Python is going to be able to take our string and the variables that are in it, and it's going to know how to expand those variables into their values when we print it. So it makes typing out strings like this a lot easier. So with an F string, we just put the F at the start of the quote of the quoted string, and then that allows us to use these squiggly brackets, or squiggle-mabobs is what I like to call them, in the string where we can, and this is where we can place our variables. So now I can say my name, oops, I dropped the is here, is name, and I am height tall. Now when I run this, actually first let's comment out this first print statement so that this one doesn't run. Now when I run this, we should get the exact same output as before. My name is TrashPuppy and I am 6 feet tall. So that's what an F string does. It's just a simple way to allow you to place variables directly into your string instead of having to like paste them one after the other using plus signs, because that's gross and toxic. No one likes that. Let's bring it back. So for this assignment, all we have to do is take this string and create an F string with the values that are in these variables up here. So like we just went over, we just have to put an F in front of our string here. Then we can move over, and where we have name, we're going to put our squiggle-mabobs, and we're just going to put the name variable. Whoops. Hang on. There we go. Same with race. We're going to take that out, put our squiggle-mabobs, and we'll put race. And the same thing with age. Oops, wrong one. Squiggle-mabobs only. Just like that. Now let's run it and make sure that our string is actually making sense. Nice. We should submit it, and boom, we got F strings. So for chapter 2, we're going to talk about one more variable type, and that's called a none type variable. A none type just means that the variable holds literally nothing. And you might wonder, like, how is this useful? Think about it this way. If you have a variable that you set early in your code and use elsewhere, but only in certain situations, you might want to check whether or not that variable was set to an actual value, because none is basically the absence of any value. So a lot of programmers do this. They'll set a variable to none at the beginning of their code, and depending on how their code unfolds, by the end, the variable might not be set to a different value. So then you can check for that. You're basically just giving that variable a default value, just in case it never really gets used the way that you may want to use it throughout the code, if that makes sense. So if that doesn't make sense, let's go through the assignment. It might help a little bit. All we have to do is declare a variable named enemy. So declare as in we're going to make the variable enemy and we're going to set it to the value of none. This will make it a none type. The data is none. So let's do that up here. We're just going to say enemy equals none. Now that's basically just telling Python, hey, I have a variable, it's called enemy, but I don't know what I want to set it to yet. So just make that variable, and right now it's set to nothing at all. Now if we print this down here, if you look at the print statement, you can see that it says enemy is none. So what do you think that's going to print? It's kind of weird to think about. Like we showed before, you can do an expression or a statement or an equation inside the print function, and it will print the result of that. So We just talked about bools or booleans. What this is going to do is tell us whether or not enemy is none. So it's just a true or false statement. When we print this, we should get true printed to our console. Nice. So just to like further demonstrate this, if I say is not none, we should get false, right? Because enemy, the variable, is set to none. So this is a Boolean value in here. Now let's take that out, because for the assignment, all we had to do was set enemy to none. So we should be able to submit this. Yay, nice. Now we know about the none type. All right, so we just went over none type. Let's review what we've learned with this little question on none type. Why might you use a none value? It's not to create bugs, hopefully. It's to set a variable to a default value that you expect to change later. Boom. Nice. Now we can go on to the next section. Okay, so we know a little bit about typing in Python. Let's talk about the difference between dynamic and static typed. Python is dynamically typed, and all that means is that our variables, the type of the value that we store in them, can change. So for example, if we have this variable called speed, and at first we set it to 5, then it's of the integer type. But later we can change that variable, speed, and set it to the string 5, and now its type is string type. So in Python, the reason this is considered dynamically typed is because the type of the variable can change throughout the code. In languages like Golang, you would have to declare the variable with its type. So if I were to have a variable called speed, I would have to say that it was an int. And it looks kind of like this. Ignore these little squigglies right now because it's Python telling us this is wrong. This is how it would look to declare the variable speed as an integer in Golang. And if I tried to later in that same code change the value of speed into the word 5 or the string 5, Golang would get mad at me and it would not run my code. So Golang is a statically typed language, which just means that it enforces the type of each variable. So when you declare a variable as a string, it has to stay as a string. We know that Python is dynamically typed, meaning we can change the types of the variable. But should you change the types of the variable? In general, it's not a good practice to change your variable types because it can cause a lot of bugs and unforeseen problems. It's best practice to keep your variables of the same type throughout the code, because if one piece of your code is expecting a string type, whereas another piece of the code is expecting an int type, you're going to cause some issues, and it's going to be hard to keep track of. So in general, it's better to not change the variable types, even though Python allows you to. All right, so let's go through these questions. Is changing the type of a variable generally a good idea? It's on Tuesdays, huh? No, it's never a good idea. Try to avoid that. What kind of typing does Python employ? Python uses dynamic typing, meaning, like we said, the variable type can change throughout the code. Nice. Got 'em. Okay, so we've learned about strings, we've learned about math. Now we're going to do math with strings, because in Python, you can. There are a couple operators that you can use with strings. The plus sign and the multiplication sign, or the asterisk, are both valid ways to handle strings in Python. I want to show you what both of them do. Before we do the assignment, I'm just going to mess around with these print statements that we have. So down here, let's print, we're going to do sentence start, and then we'll do plus, let's make it player health 1, player 1 health. And then down here, we're just going to do sentence start, but we're going to do that times 6. Okay, ready? What do you think is going to happen? So our first sentence, you have 1200. We just concatenated the two strings, sentence start and player 1 health. And by concatenate, I mean that we just smushed them together with the plus sign. That's all that means right now. So what happened with the multiplication sign? We took the string sentence start, which is you have, and we printed it 6 times in a row, one after the other. So that's the math you can do with strings. Now, for this assignment, we have a second player joining the game, and we need to tell each of the players how much health they have left. So we're going to edit line 9, which is our first print statement, and we're going to edit line 10. Line 9, we should say you have 1200 health. And we're going to use concatenation for that one. In 10, we're going to print you have 1100 health, also using concatenation. All right, so let's make sure we get the right strings in the right places. We want sentence start, and we want player 1. I think I actually did that, huh? Nice. But we also have to add sentence end at the end. So we're going to put sentence end here. Now, I just want to point out real quick, when you're concatenating strings like this, make sure you think about your spaces, because Python will not put the space in for you. Like, let's take this out for a second and just run this. You'll see what I mean. So it's not going to put the space in for us. We have to make sure that we're putting the spaces in our strings that we're smushing together, concatenating. All right, so does that first one look good? You have 1200 health. Nice. Now we have you have 1100 health. That's easy. Let's take this out. It's just going to be player 2 health. Yep. Plus the sentence end. Let's run it just to be sure. Looks good, and now we can submit. Yay! Nice job. Before we finish this chapter and go on to chapter 3, I want to talk about something that's pretty cool about Python. You can do multivariable declarations. So you can have more than one variable on the left-hand side of the equal sign, and as long as the values on the right-hand side have commas between them and line up with the variables on the other side, then you can perform multivariable declaration. So, as a little example, this variable sword name is set to the string Excalibur. Then we have a comma before the next variable, sword damage, which is set to 10. And there is also a comma in between those two values on the other side of the equal sign. Our last one, sword length, is set to 200. Now, if we were to print this, or if we were to print all of these variables out, that's what we would see. So this is basically the same as declaring them and setting them to their values, each on their own line. It's just a little nicer to do it all in one line like this. It's a little cleaner, makes your code look nice and simple and smooth. So how many variables can be declared on the same line? I think it's no limit. Yes. And then what is clean code? Is it code that runs quickly, or is it code that is easy for people to read? It's code that's easy for people to read. The cleaner your code, the easier it is for other people to read it. Nice. Okay, so we've made it to the best part of the course so far. This is where coding is about to become magical, and that's because we're going to learn about functions. So a function basically just allows us to reuse our code and make doing the same work. Like if we have code that needs to do the same type of work multiple times, we don't want to rewrite that work over and over. We want to write a function. And let me just show you what I mean by a function. So we have this code over here in the right panel, and you can see up here that we have this new line that looks kind of weird, right? Compared to what we've learned so far. This is our function. So this function is called area of circle, and that's because when we give it a radius, it will do the equation to find out the area of that with that radius given, and then it will return it to us. And if that doesn't make sense, let me kind of show you what I mean. So in this code, we have a sword and a spear, both of different lengths. If we wanted to get the area of those two before using functions, if we weren't to use any functions, we would have to do this same math to get the area twice. We'd have to do it once for the sword and once for the spear. And that would be a lot of code, right? So instead of doing that, since we're repeating some operations, What we can do instead is put those operations into a function, and then we can call that function. And all that means, when I say call that function, all that means is we can use the function in our code. So let me break down what a function looks like for you a little bit. This is a declaration of a function. Just like this down here is declaring the variable sword length, this up here is declaring the function, which is called area of circle. Now, unlike a regular variable, functions have parameters, which means functions take in items and use them somewhere in their calculation. And that's what this radius is. So when you declare a function, you use the def keyword, you put the name of the function, and then whatever that function needs to get its job done, you put in these parentheses, and you also give that a name. And that is called the parameter. All right, so this might be still, if you're still a little confused, let's work through the assignment a little bit. So the first thing we're gonna do is we're gonna run our code just to see what it's doing, right? So we see that the sword length is 1 meter and the sword attack area is 3.14 meters. And that makes sense, right? If we're using this area of circle function and our sword is only 1 meter, then the radius is going to be, or the area is going to be 3.14 meters, right? So then we have a spear, 2 meters, but we have 0 square meters coming out as the area. So what is going on here? Let's look. Here's our spear area. It's set to 0, but you can see that our sword area is set to area of circle, which is the function, and we're giving that function sword length. So why didn't we do that here with the spear? That's how we're getting the area down here for the sword. Is this function, area of circle, is returning that value back to us right here in this return line. The return keyword is, so let's walk through the function a little bit. We give it, let's walk through the function as if we were doing it for the sword area. So we have sword length of 1. We call area of circle, which means we use it, and we give it the sword length, which is 1, right? We come up here. Here's the radius coming in. We know right now for the sword that that is set to the value of 1. We have pi set to 3.14. Now we make a new variable called area, and we're setting that to pi times the radius we handed in, which is the sword length, times the radius. And then we're returning that. We're returning that area back down here. So you might have noticed that we have an equal sign right here. That means that sword area is going to be set to the area, the value that we returned from this function. Are we following along? So what do we need to do to get the spear area to print correctly to our console? We just do basically the same thing. So right now, spear area is set to 0. That's the bug. We're going to take this 0 out, and instead we're going to call or use our function, which is area of circle. We're going to put some parentheses, and we're going to put in the spear length here. Whoops, if you can spell right. There. Now let's run this and see if it actually is doing what we thought. Nice. That looks right, right? I don't know, I'm not good at math. So let's hit submit and see if we got that right. Yay! Nice, so you used your first function. Now functions are super powerful and we're gonna learn a little bit more why in the next section as well. So after going over functions, if you feel a little confused, that's okay because functions are a little tricky to understand at first, but we have some review questions to make sure, to give you a chance to practice a little bit of the concepts. So thinking about our area of circle function, what happens first? Our options are the result of pi is calculated, or the result of pi times the radius is calculated. That does not happen first. The function is defined, that could be it. The function is called, probably not, because it doesn't get called till down here on this area line. A value is returned from the function. No, none of those happen first. The thing that happens first is the function is defined. Just like this def keyword, you can think of it as defining the function because that's literally what it's doing. Nice. Okay, which step happens last? So same options. What happens last is, a value is returned from the function. So of these options, that's the last thing that's going to happen, is this return of the result. And it's good to note here that when you're writing a function and you put the return line, you're not going to be able to write any more of that function after that. The program will not allow you, because when you return from a function, the computer treats that as the function is done executing. So anything you write under the return within the function body is not going to happen. So we'll say a value is returned. Yay! We got another one here. Why is the variable called radius outside the function, but r inside the function? So we didn't go over that, but that's okay. When you call a function, what you give to it as the argument has to have the name of the variable that you want to hand in. So right now, we're interested in this value of 5, which has the name radius, right? So when we call the function on this line, we're going to give it to the function using that variable. Now up here in the definition, Python is going to know that whatever you're handing in is that. So you can rename it. It's not going to hurt anything because it already knows it's expecting to receive one value. So whatever value you hand in is going to be the same value. So that's why you can call this R up here and not radius. Okay, so let's read these. Because programming is needlessly hard and makes me want to cry. Sometimes that's true, but it's not that one. Because only the value of the variable is passed to the function, it is then assigned to a new variable called r. This is more true. Basically what's happening is a copy is being made of the value here, and so the value 5, right? A copy is being made of that value and being assigned to this r here in the definition line. Because all variables are called r inside functions. That is not true. Because all variables are automatically shortened to one letter inside a function. That is also not true. So it's going to be this second one. Nice. Now that we've learned about functions and parameters, we can talk about having multiple parameters in a function. So the functions that we just saw only took one parameter, the radius, but you can actually give a function multiple parameters. The only thing is you have to make sure that when you hand them into the function, that they're in the same order as where you declare the function. So for example, for this one right here, I'm expecting 5 to be assigned to A, and I'm expecting 3 to be assigned to B. So the order does matter. Let me go to the naming part. Just put naming parameters. Oh yeah, we can go over that. So you might have noticed that in this little example for result that we didn't actually name these parameters when we called the function, right? We just used the hard-coded value of 5 and 3. So that's totally fine. In this example down here, you can see that depending on how you've written your code, if you haven't set the word John to a variable, you can just hand it in as a string like this. Same with all of these, right? It doesn't really matter, as long as the value that you're handing in makes sense. So let me bring it over. Let's see what we got. Okay, cool. So if I bring it over here and we just mess around with this triple attack function, you can see that it's taking /1, /2, /3. And I assume that that means it's going to take these damage values. So let's look down here in our print statements. Now, this might look a little weird at first, but all that's happening is you're printing the value that's returned back from triple attack. So when this line executes, it's just going to call the function, get that return value back, and print that. But let me take that out of there so that I can kind of make it a little easier to see. We're going to say result equals triple attack, which is our function. And here's where we're going to put in our parameters, right? So triple attack takes in 3 numbers. So let's give it just regular values like this. We'll take damage 1, which is a value of 2. And then let's put in damage 2, the variable name. And then we can put some other random number. Let's do, 89. Now these are going to go in like this, each as integer values because they each have an integer type value, right? But we have to actually write this function. So our triple attack function, all it's supposed to do is return the sum of all of the attack damages that is handed to it. So let's say our total damage is equal to /1 plus /2. So bad at this keyboard. There we go. Plus /3. Okay, so total damage is going to have that value in it. Now we need to return it. We just say return total damage. Whoops, like this. Nice. So that's our function. Now, just to get the result away from these print statements, so it's pretty easy for us to see, we're just going to say print, and let's use an F string because I want to make sure I know where, like which line is printing. So I'm going to say result. That way we know we're using the result variable. And we're going to put an equal sign, and then we'll put our squiggle-mabobs, and we'll put result in here. Now we'll be able to tell it apart from the other print statements. So let's run this real quick. Here's our answer right here. So all of that just to show that you can hand in these values as raw data values like the number 2 or as variables that you've already defined. So let's actually do the assignment now. Okay, so for this assignment, we need to calculate the total damage from a triple attack combo. So we've already done part of that in our function. And we need to complete the triple attack function that takes 3 numbers. We've already done that. So what we actually need to do here is just run this. So we're going to run this. That'll take our result printout. And now we can submit it. Yay, freaking got him. I just want to make sure that this part isn't confusing here at all. When we look at our print statements down here, this is where our function is returning. So this one right here, where we call triple attack the function within the print statement. All right, so if that's solid, we can move on. Okay, if you remember back from chapter 1, when we talked about how it matters what order you do things in your code. It's the same way for functions. So if you see here, we're calling main the function, but it's being defined down here before or after we're trying to call it. So if I try to run this, it might make it a little easier to see. You can see that Python gives us a name error and it's saying that main is not defined. That's because when we start executing this Python code, it's trying to execute or call or use the main function right here in line 1. But it hasn't even been defined yet. It doesn't get defined till line 4 down here. So the order that we do these things matters, right? We need to define the function before we call it. So for this assignment, all we have to do is fix this bug. We just have to make sure that when we call main, that Python actually knows what we're talking about. So I'm just going to take this and I'm just going to move it to the top here like this. We'll put a little space in between for some readability. And now when we run, now it knows by the time, so this definition line is not going to run main, right? If we were to go through this line by line, when we get to line 2, we're not calling main, we're just defining it. We're just saying this is what main is. Now, by the time we get to 6, we know what main is, we're calling it, and Python knows exactly what we're talking about, and that's why it's working down here. So let's submit this. Yay, now we know how to declare functions in order. We just learned about how it's important to order your functions in the right way in your code, right? They need to be defined before they're called. So that might seem kind of confusing, like what if you want to use one function before another one? Does that mean you have to order them in the right way? Well, not necessarily. The way that a lot of Python is written is with an entry point, and that entry point is normally called main. So this main function down here. Now, You might notice that we're calling main at the very end of this program, right? And we have all of these functions defined before it. That's because this function main is using these other functions, and by defining them before we call main, that ensures that main knows about all these functions by the time we execute it. So that's just an easy way to make sure that everything is defined before the execution of the program starts, right? Because as long as you're defining, these lines aren't executing until you've called main down here at the bottom. All right, so let's do some of the questions. Functions must be defined before they can be called or used or executed. That's true. Functions must be defined in the same order they call one another. Not necessarily true. As long as they're defined before the entry point, you'll be okay to define them in whatever order you want, as long as it's before the entry point. And boop. All right. Which is best practice to make sure you don't define functions out of order? Is it create an entry point function, usually called main, and call it at the end of the file? Yes. I'm not even going to read the other ones. Nice. All right, so we're going to practice what we've learned about functions by making this function which converts our Fahrenheit degrees to Celsius, which is super easy. All we have to do is within our function here, we have the F argument or parameter coming in. That's our Fahrenheit. That's our degrees in Fahrenheit. So we're just going to make a new value. Let's call it Celsius. And we're going to set it to the classic equation, which I'm totally not cheating on right now and I have written in my notes. 5 divided by 9 times our parameter F, or our argument, our parameter, don't worry about it, F minus 32. Now, Celsius will have our value in it, so we want to make sure that we return that back to whoever is calling our function. And if we look, we can see actually that it's being called right here. So let's run this and see what happens. Something about our float object is not callable. So give me a second, let me think about this. Oh, there it is. I forgot to put the multiplication sign. Now it should work. Nice. Let's submit this and make sure it's right. Nice, okay, cool. We did it. So that brings us to our functions quiz. Which keyword is used to create functions in Python? Is it function, func, fn, or def? It's def, that's right. All right, next. Which is not an alternative term for values that are passed into a function? Okay, so I kind of forgot to talk about this, but we are going to talk about it later as well. So you'll hear two terms used kind of interchangeably when it comes to values being passed into a function or declared and defined with a function. And those two terms are parameter and argument. So they're used interchangeably, but they do have specific meanings, which we'll talk about soon in one of the upcoming sections. So parameters, arguments, or slots. Slots is definitely not an alternative term for those. A function must be defined blank to be called many times with different arguments. So you only have to define a function once, but it can still be used. It can still be used multiple times. Nice. All right, let's go through this hours to seconds assignment. It's just another function, and all we want to do is take hours, the parameter, and return its conversion into seconds. So I'm going to do this the longhand way because, like I said, I don't like math. We're going to start with minutes. We're going to say minutes is equal to hours times 60. Now I'm going to use minutes to create seconds. So we're going to take minutes and we're going to multiply that by 60. And now all we got to do is return seconds. Like that. Okay, let's run it. That looks right, right guys? 1 hour is 3,600 seconds? Yeah. Let's submit. Nice, we got it. Good job. From what we've seen about functions so far, you might be wondering what happens if we mess around with this return. What if we don't put a return line? The function, if you don't return something specifically, then it will always return none, which is what we talked about earlier in chapter 2 about none types. So all of these functions on the side here, they're all returning the same exact thing, just in different ways. So you can either straight up return none, you can just return with nothing appended at the end of that, or you can leave out the return line altogether. All of them will return the same thing, which is just an empty value. Okay, so what happens if there is no return line in a function? It returns none. What's the difference between printing a value and returning it? Print shows a value in the console, return makes a value available to the caller of the function and shows it in the console. That is actually wrong. Print shows a value in the console, return makes a value available to the caller of the function. Now this one is correct. Compared to that last one, a function is not going to return a value and print it to the console at the same time. You have to print the return value using a print function. So it's going to be this one. What if we want our function to return more than one value? Well, in Python and in other languages, it is possible to return more than one value. So we're going to see that with this little assignment. In this assignment, we just have to complete the become a warrior function, which takes 3 parameters or arguments and returns 2 values. One is going to be the warrior's full title, their first and last name with the warrior appended to that. And the second is going to be the power level. So those are the 2 values that are going to be returned. So let's try returning more than one value here. All we have to do is take first and last name. Let's make title, and we're going to set it to, oh, by the way, F strings. We can put F strings, we can use them outside of print. So this is going to format our string with the variables like we talked about before. So let's put first name here. Make sure we're using our squiggle-mabobs. Then we'll put last name. And then the warrior. So that'll be our title variable. Now let's make another one. We'll call it new power. And that's going to be power, the argument that we're getting, plus 1, and that's it. Now, when we return these, we're going to return them on the same line. On the same line. Kind of like when we declared and assigned multiple variables on the same line. We wouldn't do something like this. We wouldn't say return title, return new power. Because like we talked about before, once we return from a function, this code basically just is ignored. It never happens. So we don't do that. We literally just put it in the same line with a comment. We'll put new power. Now, down where we call this function, wherever we're calling it, we want to make sure that there are 2 variables ready to catch the values. And as you can see, and I actually did not plan for that, but, oh, it's not going to let me tab over. That's okay. As you can see here, we got title and new power, and that's set to become warrior, which we're calling with all of our arguments. So let's run this. Frodo Baggins, the warrior, has a power level of 6. That should have gone up from 1, right? Or by 1. Bilbo Baggins, the warrior, has a power level of 11. And Gandalf, of course, has a power level of 9,001. Now let's submit. I think we got this right. Nice. We talked a little bit about parameters versus arguments. I told you that they're used interchangeably a lot, but now we're going to get down to the meat of the issue and figure out what the heck they are. Parameters are the word that you use when you talk about what's being given to the function in the function definition. So over here in the add function, A and B would be called the parameters. Now when you call the function, such as down here, 5 and 6 become arguments. Those are the arguments. Arguments are the actual values that are being handed in. Whereas parameters are just sort of like, that's just in the function definition. They're just being defined as the variables A and B. So does that make sense? Let's check our knowledge. with this little quiz. Blank are the values that are passed into the function by the caller. That would be the arguments. Nice. Blank are the inputs specified by the function definition. That would be parameters. Nice. It took long for a second. I had a little heart attack. Okay, cool. That's it for that one. If you're a big nerd like me, you might be wondering, what if I want my function to be able to take optional parameters? As in, when it's called, what if I'm okay if one of the parameters gets left out? Well, in Python, you can do that by using a default in the function definition. So for this assignment, all we have to do is make armor the default parameter in our function. That means that when get punched or get slashed is called, if it's not given a value for armor at the time that it's being called, then we'll just make sure that it's set to something, and we're making sure that it's going to be set to 0. Okay, for the rest of this assignment, all we have to do is return the new health after our player gets punched or gets slashed. So we're going to make a new variable. We're going to call it new health. And we're going to set it to, we're going to set new health. First, we're going to set it to the health plus the armor. And then we're going to do our damage. So for getting punched, you take, I think it said 50 damage. So let's say our damage equals 50. Now we can say new God, new health minus damage. And I actually want to assign this again here. So we're basically just changing the value of new health to new health minus damage. And that's what we're going to return. Okay, so that was not the most beautiful way to code that function, but that's okay, because it should work. We could try it out. Oh no, I broke something. After function definition on line 8. Oh, that's just because we need to finish this one here. Okay, so for this one, let's maybe do it a little bit better. We're gonna say, you know what? We'll just do the same. So same thing, new health. We're going to set that equal to the health plus their armor. And if they don't have armor, then the armor is going to default to 0 because that's how we set it in the definition up here. Now, when a player gets slashed, the damage is going to be 100. So we'll change new health one more time. We'll set it to the same value, but minus the damage. Move over, let's add a little space in there. And we'll return new health, just like before. I could type. Okay, now let's try to run this. Uh-oh, I spelled something wrong. There we go, right here. Cool. So it's running, everything looks okay. Let's try to submit it. Yay, I can't believe I actually got that after all those mistakes. But if it works, it works. Okay, so we've made it to the last part of chapter 3, and we're gonna be talking about printing versus returning. So we know what printing is, and we know what returning is, but a lot of new developers tend to get the two confused, especially because like in all of our, or in a lot of our examples and lessons, we've been printing returns from functions. So I'm going to go over a little bit how they're different. So print in Python, all that's going to do is put the output, whatever you give it, it's going to print it to the terminal, right? But it's not actually returning any value to anything. You don't call print like you would call an actual function. Now with a function that has a return, it's going to be returning something, but that value that's being returned is not necessarily going to be printed to the console. You have to print that value in order for it to show up on the console. So when you see code like this get title function, and you see this print line at the end of it, what's actually happening here is the function is printing whatever this value is, but it is not returning it to wherever it's getting called. So let's run this how it is, and I'll show you what I mean. All right, so when you run this, you can see that this title down here is set to none. And that's just like before when we talked about functions. If you don't return anything, if you don't have a return line, the function just returns none. So we're catching whatever we return from the getTitle function here and saving it to this variable title. But because we're not returning anything, title doesn't actually get any value set to it. It just gets none. So let me make that a little clearer just by putting those down there. This is where we have the title variable and we're calling getTitle. Since we're not returning anything, title is equal to none. So when we print it right here, that's why we're getting none in the print down here. So all we have to do for this assignment is return title instead of printing it to the console like a barbarian. We're going to pretty this up and make it more professional. So all we gotta do is return title here. Now we're gonna let the main code handle whether or not it gets printed. Nice. So now we have the full title, Frodo Baggins the Warrior, and it's actually getting printed after being returned, right? It's getting printed right here with this variable title. So that's a lot better. We're not just printing a value and being confused on whether or not it's returning. We're actually returning it and printing it later. So let's submit it. Nice. Now we've finished chapter 3 and we know all about functions. Welcome back. We're on chapter 4 now, which is going to be all about scope. So last time we were here in chapter 3, we were learning about functions, and scope is actually going to be really important for functions. So what exactly is scope? The basic idea behind scope is that scope is the context that a variable or a function belongs to, which is not necessarily the same scope as other parts of the program. So everything that you define or create in your program has its own scope, and that's where it exists during execution and is available to be used by other parts of your program. So if that's confusing, don't worry, it's a little confusing, but I do have a drawing for us to go over. So I think that the easiest way to think about scope for now is to think about it in a parent and child relationship. As in, if we have our program here in blue, we're gonna call that the parent, and each of these little functions are gonna be like the parent's child. So for each of these children, they're gonna adopt the same scope as the parent, but anything that's created within each of them is not necessarily going to become part of the parent's scope. So if we look at this over here, functions and variables that are defined within the parent scope are children of the main program, but they don't know about their siblings variables that they're creating. And we're gonna walk through this code so that you can kind of see what I'm saying. All right, so the parent has 5-ish children, right? We have one variable called movie, one called color, and we have 3 functions. Now, if we go into this first function, def start movie, everything within the orange box is this function's scope. So inside start movie, we create a variable called a, and we set it to get actor. Now, get actor is a sibling of start movie. So they both adopted the same scope from the parent. And since the parent knows about get actor and knows about start movie, they both know about each other as well, if that makes sense. So we can call get actor from within this function and its scope. However, the a variable that we're creating here is not going to be able to be used anywhere else because it was created within this function scope, so it will only exist inside of here. Now you see this m variable, that it's going to be the same for the m variable, except that we're returning m. So wherever this function is getting called outside, wherever its return is getting caught, a copy of m is going to be made, and then it will exist in that scope, wherever it's getting called. So within start movie, it's totally okay that we're calling get actor, this function over here, and it's also okay that we're using movie, the variable that's coming from the parent scope. Now, something that's not going to work, we go down here to get codename. You can see that we're using color, that's from the parent scope, right? So that'll be fine. But we're also creating this, variable code name. And then you can see that over in getActor, our green function, we're trying to use codename. This isn't going to work. We're not returning codename anywhere. We're only creating it and defining it within this function, so it doesn't exist outside of this function. So when I try to call this over here or use it, it's not going to work. And I've actually prepared this code for real. So let's look at that and I can show you what I mean. Okay, so here is our scope code. Here's our Reservoir Dogs code. If you don't know Reservoir Dogs, it's a great movie. You should watch it. Our parent is going to be the main code, right? So we have movie and color, and then we have our three functions: start movie, get actor, and get codename. Now, I'm going to take this away real quick, and let's walk through our code a little bit. Once I save it, let's walk through our code a little bit. You can see that once we've defined everything, the first thing that we do is we say get codename. So we open up this function, get codename, and it looks just like our purple function, right? We're using the color variable, and based on whatever the color is, so these are if statements. Don't worry too much about them. We will learn them. But all this is saying is if the color variable is the same as this string blonde, or is equal to blonde, then we're going to set codename to Mr. Blonde. If it's equal to pink, we're going to set the codename to Mr. Pink. Now, I'm going to take this return away, just like, whoops, we had it in our drawing. Once I figure out Vim. So we'll make it just like the drawing, and that's all this function does, right? So we get codename. Codename, the variable inside this function is set to whatever. The color right now is blonde, so it's going to be set to Mr. Blonde. The next thing we do is we make a variable m, and we set it to start movie. So start movie is doing just like in our drawing. It's making a variable a and calling get actor, our other function down here. And then it's going to make a message based on the actor that we get back and the movie that we have up here. So get actor, let me fix these so that they say codename, just like in the picture, the drawing we did. Okay, it's going to return actor, and then we're going to create this little string that's telling us about the movie that's starting and who's playing. So let's try to run this right now. We're going to say Python 3 scope, and you can see that we have an error, right? It says down here at the bottom, if you ignore all of this scary stuff and go straight to the bottom, it'll tell you exactly what's happening. We have a name error. The name code name is not defined. So that's because codename is not in the scope of get actor, because it only exists within get codename. So let's fix that. I'm gonna bring back all the stuff that we got rid of. Let's say we return codename here, and now we're gonna set where we call get codename. We're going to set a new variable. Let's call it CN. We're going to set that equal to our function. And then up here, instead of trying to call codename, let's call CN, because when we set this variable to what codename, get codename is returning, we're creating a variable within the parent scope. So our function should have access to that variable, right? Because it adopted the scope from its parent. Nice. Now if we save this and try to run it, everything should be working. Nice. The movie Reservoir Dogs is starring Michael Madison. Okay, before we do the assignment for this section, I want to talk about something weird about Python. Let's go back to our drawing because I think it'll make it a little easier. All right, so if we look down at get codename and we look specifically at these if statements, which, like I said, we'll learn later, don't let them scare you or anything. In most coding languages, these if statements themselves would have their own scope. So let's choose like a light pink. This little if statement would have its own scope. And you can see that we're creating codename within that scope. Python is weird because even though codename is being created within the scope of this little if block, it still exists in the scope of the function because Python scopes all of its variables to their functions. Whereas if this were something like C or Golang or pretty much any other language, you wouldn't be able to refer to codename outside of these if statements. What you would have to do is define it before the if statement so that it's defined within the function itself, like this. Then you could use it and change it however you wanted. So a lot of what you'll see would look something like this. You would set the codename to like a default value, kind of like how we used none earlier. You would set it to a default value so that codename exists within the scope of the function, and then you could set it within your if statements. Think of the if statement as like a child of the function. Then you can set it in there. The child knows about codename. It'll change it, and then it will actually change in the scope of the function. But Python's not like that. Python does it weird and scopes everything to the function. So even though we didn't create codename outside of these if statements, the function still knows that they exist. So they're still within the scope of the entire function itself. All right, so now that we've got that, now that we understand that about how Python is weird, let's try to do our assignment. So based on our assignment, we have a bug on line 10. So let's look at line 10. If we run this, we might be able to figure out what our bug is. It looks like, again, we have a name error where modifier is not defined. So if we find modifier, we can see that we're using it in this function definition. That's okay because like we learned about functions, where you define them, the parameters can have whatever name you want. Then we have my modifier, and then we're calling max health, or we're creating a variable called max health and calling get max health. Now here, this looks messed up, right? So as far as the parent or the main program is concerned, we don't have a variable called modifier. It doesn't matter that the modifier exists as a parameter in this function definition. That doesn't make it a variable within the parent scope. So we can't call modifier here. What we should be calling is my modifier, which is a variable we made in this scope. So the program knows about it. So if we switch that here, it looks like we're also going to have to change my level. Now if we run this, this should work, but let's run and not submit first. Nice. That looks like it's running okay. So we'll submit. Nice, we got it. Good job. All right, so you know how we were talking about scope in the context of a parent and a child? Well, there are actual terms for these things. So we're going to talk about global scope. Global scope is basically just the parent or the entire program, its scope. Anything that you create or define within the global scope is available everywhere throughout the program. So to demonstrate this, let's go through the assignment. For this assignment, all we have to do, well, actually, let's run it. Let's run it first and see what it's doing and what it might need. So we have a name error again, probably because something is not in scope. Player level is not defined. Now, if we look around here, we can see player level is within the calculate health and even in the second calculate primary stats. So if we just make it available in the global scope, like this, what was it? Player health? Player level? Player level. We make it available and set it to the level 4. Now it'll be available to the whole program and we shouldn't be getting this name error anymore. So let's run it. Nice. Character has 40 max health. Looks good, so we could submit. Nice. So all we did was put player level in the global scope of the whole program so that everything else adopts it and knows what it is and can use it. All right, so we've made it to the quiz portion of chapter 4, and then we're all done with chapter 4. So, can functions access variables declared in the global scope? Yes, because everything in the global scope is accessible throughout the entire program. Let's go next. Can code outside the scope of a function access variables that are defined inside that function? No, right? Because unlike the global scope, a function scope is only scoped to itself. Anything created within a function scope exists and can be used within that scope, but not outside of it. And that's it. Welcome to Chapter 5, where we're going to be talking about unit tests and debugging. So when we've been doing our assignments and writing code for them, only the output has been being tested. But now we're going to be using something called unit tests. So some of our assignments are going to be using the output thing like we have been doing. So only our output will be checked, and some will be using this new unit test type setup. So let me tell you a bit about what a unit test is. In this context, a unit test is going to actually test the functionality of the code we write. So instead of just testing the output, it's going to be sending inputs to the functions that we write and expecting certain outputs. So the tests are going to be a little harder to pass. And let me kind of show you what I mean. So if we press run on this, you can see that our function here, total XP, got some inputs. And these are just sample inputs. It got 1 and 200 and was expecting 300, right? So 1 went in as the level and the value 200 went in as the XP it had. And our unit test, was expecting 300 to come back to be returned from our function. But really all it got was none because we have this pass keyword in here. Now this pass keyword, I'll go over real quick. It just tells Python to continue, because normally if I take this out and just have nothing in here and run it, we would get an error, right? So we just put the pass in there until we're sure of what we want to put in our function. All right, so the way that these unit tests work is, if you see next to our main.py file, we have a main test py. This is the automated script that's going to be doing the testing of our code. So you can see here that we have run cases, and you don't really have to understand all of this code. I'm just kind of giving you an idea of what's going to be happening with these types of assignments now. This is where our test cases are coming from when we hit the run button. And here, this is where our test cases are coming from when we hit the submit button. So what is the point of learning unit tests? Unit tests are something that you're going to be using as an actual developer, because in the real world, when you're coding for an employer, you're not just going to write some code and then just send it to production as is. You want to write code and test it and put it through a lot of testing to make sure that it's doing what you want it to do, and so that you can get rid of as many bugs as possible. So that's kind of the idea. We're going to start getting used to testing our code bit by bit as we write it, instead of just writing something and seeing how it does. We want to be methodical about how we test things so that we can try to find as many bugs as possible. However, bugs will still show up in production. And that's kind of what this submit and run does. So when we do the run test, you can see that there's, only 2. But then when we hit the submit button, we're going to get more tests. And a lot of the time, the tests that are ran against our code when we hit submit are going to be different and more complex, because they're purposefully designed to cause or to trigger bugs that we probably didn't think of when we were running them. So as we go through the rest of the course, the other type of assignment testing that we've been doing, where it just tests your output, is still going to be around. But now every once in a while, we're going to also have this unit testing style. The difference is that when we do the output testing, it's literally just checking our output. So we don't want to leave any print statements in our code, because that might mess up the testing and the checking of our code. Now, when we're doing assignments that have this unit test sort of configuration, we can leave print statements in our code, because the prints to the console are not being checked. The functions we're writing themselves are going to be checked. Okay, so let's talk about this assignment. We have a function here called total XP. All we're supposed to do is find the total XP based on the level of the player coming in and the amount of XP that they're supposed to get. So for each level, a player gets 100 XP. So we'll say something like base XP equals level times 100. And then we can say total. We'll just say total, since total XP already exists as a name of the function. We'll say total equals base XP plus XP to add. Now we'll just return, our total. Now we're going to run this first. And what we want to see is that our actual, so this is the actual output that my function is doing right now with the code that I've written into it, matches our expecting. So we can see on the first one that we've passed because those two match, and on the second one we've passed because those two match. So it's probably safe to run or submit our code now, but let's see what happens because the tests are, like I said, they're going to be a little harder on our code. Wow, we actually passed, so that's great. That will not always happen. The idea is that there are bugs that you're probably not foreseeing, and that's totally fine and normal. But we got that one, so I guess let's continue on. All right, we talked about the two lesson types a little bit, but let's go over it again just in case that was confusing. The lessons that we've been doing up until this point have been the console output type lessons, where whatever code we're putting in the right-hand panel is getting checked based on the output into the console only. Now, what we're going to be seeing more of is this unit test type lesson. So the main difference between the two is that for the unit test lessons, you're going to see those two files. One of them is going to be the main test file, and it's going to be running, it's just an automated script that's going to be running inputs into your code, into your functions, and checking the outputs, and that's how the test is going to be going down. Now in this type, you can put as many print statements as you want because printing to the console is not going to affect how boot dev is testing you. Whereas when we do the output type lessons, which there still will be a couple of, any extra print statements are going to kind of mess with the test because it's testing what's being printed to the console. In these types of assignments, after you do your debugging and you're sure that you want to submit, make sure that you take out all of your print statements that you were using for debugging. Okay, so let's do the questions. You can submit blank lessons with your debugging code. That would be the unit test because it's not testing the output to the console. It's actually testing your functions by giving them inputs and testing the outputs. For the next question, oops, oh, that was it. Cool. We talked a little bit about it when we talked about the unit tests and why we're doing them, but when you become an actual coder, you cannot just write a bunch of code and then push it to production or make it live for users if you don't test it and debug it. Because any code, pretty much every code that's ever written is going to have bugs. Bugs that are obvious and you should have tested for, and bugs with that even after a bunch of testing by, a ton of people are still not going to be obvious and will show up later when the code is live. So because you know that your code is going to have bugs, it's best practice to debug the crap out of it before it goes live, because that will lower the amount of bugs, right? You're assuming that your code is going to have bugs because coding is hard. No one's perfect. Anyway, let's talk about debugging. Debugging is an important skill. We've already been doing a little bit of debugging. When we have been using the run to check what our code is doing and fixing it based on that, that is debugging. So since run is kind of like debugging, you can think of submit as kind of like pushing your code to production or going live. You're basically putting your stamp of approval on it, like, yes, this is good code, I trust it, and I want it to go do its thing live for users and whatnot. So you can think of submit kind of like that. That's why there's more test cases when we hit submit, because once your code goes live, you'll be very surprised what type of bugs your users can find. Even when they're not trying. Most of them are not trying, but a lot of bugs tend to pop up once code goes to production. So having this run versus submit system is a little bit more realistic because it's just teaching you that your code is going to have bugs. You're going to be able to think about some of them and catch some of them, but in all likelihood, a lot of those bugs are going to be harder to anticipate. So let's talk about the assignment. For this assignment, we want to complete the take magic damage function. It should return the new health after calculating how much magic type damage the player takes. Health is going to be the player's starting health, so that's coming in. Resist is the player's magic resistance to the attack. This reduces the damage they take by a static amount. Amp is going to be the attacking magic's amplification, which increases the damage that it deals. And then spell power is going to be the base damage of the spell. So let's try to code this. I like to be very verbose when I code so that I can easily track what's happening. All right, so the first thing is let's figure out how much actual damage is coming in. So I'm going to call it total damage. And that's going to be set to the spell power. I believe it was, yeah, which is the base, and then the amplification. So I think we're going to multiply that, right? Now we know exactly how much damage is coming in. Now, the player themselves, they have their health, but they also have resistance. So we'll actually take, we'll say actual damage. Say actual damage dealt is going to be equal to the total damage minus our player's resistance. Whoops. Now we can say, I'll call it new health. That's going to be equal to, if I could type, our player's health minus the actual damage dealt. And we're going to return the new health. If I can type. Nice. So let's run it and make sure this makes sense. Okay, expecting 65, got 35, so I failed. That sucks. So let me go over my actual code here. Spell power, time, damage, minus resistance, health minus action. Oh, it's because I reset. It's because I suck at typing and I set new health equal to health, which is equal to the actual damage dealt. So let's actually fix that right there. That's a big bug. Boom. Now we're passing. Hopefully we pass all the submitted tests. Yay! Looks like we got it. So great. Okay, we're just gonna have a little section about learning effectively because like I just said, coding is pretty hard. So you wanna give yourself the best chance at learning all these new complex subjects because things are gonna get a little harder from here on out. So here are some tips. First, you're going to want to read through every lesson. Read through the whole lesson, make sure you understand it. And if you don't, you always have Boots down here. And if Boots isn't enough to help you understand the lesson, you also have the Discord. Okay, next, for each assignment, same thing. Make sure you're reading through the entire assignment and you're understanding it to the best of your abilities. But like I said, you also have Boots and the Discord. Now, third, this one's going to be big. Add print statements to your code to help you debug. And I'll kind of show you what that looks like as we go through more lessons. But basically, when you're writing your code and as the code gets more complex with the assignments, you're going to want to put print statements that print certain variables or values that you're not sure of the value for. So if you have variables in your code that you think are doing one thing, but the output seems to be like they're doing something else, you can always print them and it'll kind of give you an idea of what they actually are when the code is running. That's a good way to find bugs. Okay, now for the next couple, well, from here on out, there's going to be solutions to each assignment. You can always look at the solution, but if you look at a solution before you've correctly submitted for your assignment, you will be penalized. Usually it's by you'll earn less experience on the boot dev platform for you'll earn 50% less experience or something like that. It's nothing crazy, but you will be penalized a bit if you look at solutions before you submit your own code. Now let's go through these questions. That's all there is for the assignment for this part. So you'll be penalized for peeking at the solution after you've successfully completed an assignment. This is false. Once your assignment is successfully completed, you can look at the solutions all you want. In fact, it's a good idea so that you can kind of see how you coded your solution versus how our instructor coded their solution. All right, that's false. Next, temporarily adding print statements is a good way to submit your code to the grader. That's not true. Quickly test and debug small pieces of code. That's true. Lose some XP, false. Get carpal tunnel syndrome. That's kind of true, but this second one's going to be more true than that. All right, when you're stuck, which should you do first? Whine on Twitter about how hard coding is. That's what I like to do. Peek at the solution or ask Boots a question about your code. Asking Boots questions is never going to be a penalty towards you, but peeking at the solution will. So I would ask Boots a question. Well, first I might post on Twitter, but then I'm going to ask Boots a question. So let's put that one first. All right. Okay, for this section, we're gonna do some practice debugging. While we go through the assignment and practice our debugging, what I want you to think about is instead of coding the entire assignment and then just sending it to see if it works, code little pieces of it at a time and then test those little pieces by doing print statements or debugging however you want. So we're going to go through this one together. Let's complete the unlock achievement function. It accepts 3 arguments: before XP, ACK-XP, and ACK-name. Our function should return 2 values. The player's XP after the achievement is unlocked, which is going to be the sum of before XP and achievement XP. An alert message that says achievement unlocked, achievement name, where achievement name is the name of the achievement. So we're going to start by running the code in its current state. You should see an error like this. So we have an indentation error. We talked about that earlier when we talked about pass. This just means that, the function is empty, and even though we're getting an indentation error, think of that as the first error in a string of a bunch of errors right now, because there's literally no code here, nothing is happening, but that's the first thing that Python is going to complain about. So this is where we're going to put our code. We can take that out. Now, there are 2 things that we can do. We can either put a pass here, and it will run, or we can return 2 values, and for now just set them to none, because our function, like we talked about, is supposed to return, an int and a string. So we'll put 2 nuns here in our return. Nice, that's also working. So let's start working on our function. It says, let's start by calculating the new amount, update the function body. So we're not gonna do it right, just so I can show you how we're going to debug as we go. Let's say we're setting this after XP, and we're setting it to before XP minus achievement XP, just accidentally. The way that we could use print statements to help us debug is, now that we have this little piece of code written, let's put a print statement to check and make sure that it's doing what we think. So we want to use an F string for this, because since we already have a lot of output in our code, marking exactly what we're printing is going to make it easier to see. So I'm going to say something like after XP equals, and then we'll put our variable. Okay, so let's run this and see what it's doing. It looks like after XP is 80, even though our inputs were 120, or 120. So it looks like our bug right now is that we're not actually adding the experience, right? Yeah. So let's change this and make it a plus sign. Now when we run it, we should get 120, right? Sweet. And that is what the tests are expecting. Okay, so now that we've fixed up this little piece of the code, let's go to the next piece. The other thing that we're going to be returning is the string, the achievement string. So I'm going to go under our print statement, and let's say, we'll say alert, equals, let's do another F string because I feel like it, and we'll say, jeez. Achievement unlocked. Wow, look at that typing, so good. I'm super sure that this code is gonna work, right? We'll put the ACK name in there. And like I said, let's put another print statement just to make sure that our alert is doing what we think. Because I am super positive that we have no bugs, right? This is usually how these things happen. Oh, and let's make it an F string so we can see it really easily. We're going to say alert string equals, then put our squiggle mabobs around alert. Oops, and I forgot a quotey. There. Okay, here's our alert string. Achievement unlocked equals speedster. That looks horrible. It's supposed to look like this. Okay, so now we know, since we're printing and debugging after each little piece of code, we know exactly what's going on, right? So let's fix that. Hopefully I know how to spell achievement. We want to make this uppercase and spell it correctly. And instead of an equal sign, let's put colon. Boom. That looks better. Hopefully this works. Achievement unlocked. Speedster. That looks right. Cool. Now we want to return both of these since we're done debugging and we're pretty sure everything is working how it should be. Let's put after XP and we'll put our alert. Okay. Make sure that actual is matching our expecting. Ooh, my print statements are kind of in the way. So for now, because I'm not sure I'm done yet, I'm just going to comment them out because I might find that I need to fix them. Fix things in my code again. Okay. There we go. Expecting 250, achievement unlocked, killer. That looks good. I think we can submit this. Hey, got him. So that's some debugging practice, and I hopefully now you understand what I mean by printing to the console to debug. All right, congrats. We've made it to the end of chapter 5. We're going to talk about stack trace, which is an error that you'll see in Python, and it's one that we can use to help us debug sometimes. Before I tell you what a stack trace is, I just want to show you what it looks like. We're going to run this code, and boom, this is a stack trace. Python calls it traceback. In other languages, when you see a stack trace error, you're probably going to get a list that looks like this. And it's a little intimidating, it's a little confusing, but let me try to break it down for you. You can see that Python is telling us about a bunch of files, right? And they don't really make sense. They don't look like they really exist, but they have line numbers. It's confusing. All it's telling us right now is that there are errors popping off in files that boot.dev is likely using to render this virtual environment for us. In other words, they're out of our reach. So we don't really have to worry about that. When you read a traceback error or a stack trace error in Python, the easiest thing to do is go to the bottom or the last thing that's listed, because that's where the error started. So this error we can see is in home pyodide main.py. So that's the path, and that is our main.py. And it's starting on line 3. So if we look at line 3 actually looks all right, but if you look at line 2, there's something going on here, right? And if we go to the very bottom of our error, we see that we have an indentation error. We haven't talked about this, but Python is kind of an interesting language because it treats white space as meaningful. So in Python, you have to have indents, and they have to be 4 spaces worth of space. So this total, this line here, this line 2, had originally 6 spaces worth of white space. For Python, that's an error. In other languages, they don't really care. They have other ways to delineate when code blocks start and end. So as you can see, this is our function, right? The function, because it's the first thing in our file and because it's in the global scope of the file, the program, it doesn't have an indent on the first line, right? Everything within that function has to be indented at least once in. Same thing if we were to have some type of if statement here. So if I wrote an if statement like if strength is, if strength is none, do something about it, right? That would have to be indented twice because now this is its own little block of code, and that's how Python likes it. So let's take that out. We don't need that. We fixed our indent error. Like I said, an indent is treated as 4 spaces. Now if we run this, we'll get a different error, right? It's still a traceback, but now you can see that it's a different type of error. So the idea of a traceback is that wherever the error is occurring is going to cause sort of a domino effect in the other files that are calling functions or working to get this output for our code working. So you always want to look at the bottom thing that's listed because that's going to be the first place that an error happened. Okay, so now that we've taken care of the indentation error, now we have this syntax error. And you can see we still have a traceback type error, or we still are getting a traceback error. And the first error to have happened in this sort of domino effect or chain reaction is this syntax error, which is telling us that there's an unterminated string literal. So if we look at our strings, there's really only one, right? This message. And let's scroll all the way over and make sure, because it looks like we have our first quote, but we might not have our second. So let's put a quote here. And you can already see from the coloring and the syntax highlighting, which is what this coloring is, that probably fixed it. Let me take it out again just so you can see. See how this is still orange, like it's still part of the string? That's because we haven't closed it. You can already tell that that's probably going to fix something. So let's run it again. Nice. We fixed both of our errors. It looks like we're passing everything. So let's try to submit this. Boom, nice. So now you know what a stack trace or a traceback error is, which is what it's called in Python. And we're all done with chapter 5. So nice job. Welcome back to Boot.dev's Learn Python course. We're on chapter 6, which is going to be a super fun chapter because it's going to be all about math. And I historically hate math, but since I've learned programming and I've learned fun math things that we're going to go over, like Booleans and bitwise operations, I actually really like it, which is crazy. So this is going to be a lot of fun, I promise you, because I think it's fun. Pretty much anyone could think it was fun. I hate math. Anyway, we're going to start here on section 1 of chapter 6. So make sure that this is where you're at. And we're going to start with just a review of numeric types, which we've already talked about back in chapter 2. So if you remember in chapter 2, we talked about 2 different numeric types in Python, and those were integers and floats. So integers are just whole numbers. They can be negative or positive, and floats are fractional numbers with a decimal point. Kind of like this one down here. So on these numbers, you can do all of the basic math operations: addition, subtraction, multiplication, and division. If you do addition, subtraction, and multiplication on integers, the whole numbers, you're going to get a whole number result. But if you do division on a whole number or a float or whatever, you're going to get a float type out of your answer. So let me reset that. Don't look at that. That was definitely not the answer to the assignment. Okay, let me show you what I mean. If we put 4 divided by 2 right here and run this, you would expect that we just get 2, right? An integer, a whole number. But because we're dividing, Python is actually going to give us a float value. So we have 2.0. Now later, we're going to learn how to turn this float into an integer in the case that we want one instead of a float, but for now, this is fine. So after our little review, let's do the assignment. All we have to do for this assignment is return from our calculate damage function total damage from all of these different weapon types and an average damage for the types. So that'll be a float, right? Because we're going to divide by the number of weapons. So let's do that real quick. I totally, this was not what you saw earlier. Make sure you don't go back and cheat because we're just going to do it right now. So we're just adding up all of the different weapons that we're getting in as parameters. That's going to be our total damage. And then for the average, we're going to take total damage and we're just going to divide that by 5, which is how many weapons we have, right? So let's run this first. Remember that last time we talked about these new test types, which is our unit testing assignment types. Instead of printing our output, there's a little script, right, that's going to be running against our function and giving it a bunch of test inputs to test how our function handles those and what outputs it gives back. So before we submit, we want to make sure that our code is doing what we want, right? So for this test set right here, 35214, those are all the weapon damage types. We're expecting 15 and 3.0, and that's exactly what we're giving back. So we pass that one. Same for this one down here. We're expecting 25 and 5.0, and that's what we're giving back, so we pass. So since we're passing, let's try to submit this, and hopefully we didn't miss any bugs that would maybe mess up our code with different inputs. All right, let's run it or submit it. Cool, we passed that one. All right, so let's go to the next section. It's really, really small, just a little question going over what we just talked about. So blank and blank are numerical types in Python. This is going to be integers and floats. Integers being whole numbers, negative or positive, and floats being fractional numbers. Boom, nice. All right, now we can move on. All right, so I just sort of hinted at something that we could do if we want to take a float value that we're given from Python and turn it into an integer. We can use something called floor division and the floor division operator. So with floor division, basically, as long as we're giving it two integers, it will output an integer type, which means it will chop off any decimal place of a division. So when you use floor division, you do the first number, let's say 7, divided by 3, and then you floor the value. And I'm going to show you what that looks like. So let's bring it to my diagram over here. When you floor a number, the floor of a number is the largest integer, which is less than or equal to that number. So if we just divide 9 by 3 regularly, in Python, we're going to get 3.0, right? We're going to get this float right here. But if we use floor division, we're going to take 3.0 and floor it, which means it's going to become 3. So 9 divided by 3 and then floored, or the floor division of 9 and 3, gives us 3. That's because when we have 3.0 as the result, the largest integer, which is less than or equal to 3.0, is going to be 3, right? So what happens when we divide 9 and 4? 9 divided by 4 is going to give us 2.25 in Python. So what do you think is going to happen when we floor this number? When we floor 2.25, as in 9 floor divided, the floor division of 9 and 4. We're going to get 2, right? Because 2 is the largest number, which is less than or equal to 2.25. Okay, now it's going to get a little weirder. And I want to make sure to go over this with floor division because it definitely tripped me up when I was a new coder. I'm going to show you what happens when we do floor division with negative integers. So let's come down here. Right here we have 9 divided by negative 4. Now that's going to equal negative 2.25, right? What do you think is going to happen when we try to use floor division? When we do 9 divided by negative 4 by negative 4 and then floor that value? You might think that we would floor to 2, right? But we're actually going to floor to 3. And the reason for that is because if you remember from up here, let's bring it down so we can reference it. The floor of a number is the largest integer, which is less than or equal to the number. So our number is 2, or negative 2.25, right? So the largest integer, which is less than negative 2.25, is not negative 2, it's negative 3. So if you ever use floor division in your Python or your coding, make sure that you keep that in mind. I also have some code to show so that you can see it in action. So the first thing, we have these two variables. One is called divide, one is floor. Divide is going to be set to 9 divided by 3, and floor is set to the floor division of 9 and 3. So 9 divided by 3 and then floored. Let's see what this puts out. Just like we were talking about, we got 3.0, the float, and 3. Now, if we put these, we comment these out and bring these in, you know, if Vim lets me. What do you think we're going to get? Let's run this. We got 2.25, the float, and 2, right? Because we floored it. Now, here's our last example with the negative number. This is the one that could trip you up. It definitely tripped me up when I was starting. We're going to do 9 divided by negative 4 and 9 divided by negative 4 and then floored. So let's check it out. Boop. So we got negative 2.25 for the division and negative 3 for the flooring. That's just to show what we just did on the diagram. Okay, so let's go answer our questions. What would be the result of 11 divided by 2 and then floored? Now, we got to think about this. I mean, I definitely do. So, thinking out loud, we're going to get 11 divided by 2, right? That's going to be something like 5.5. Is it 5.5? I'm so bad at math. So 5.5. What is the largest integer that is less than or equal to 5.5? It should be 5. Nice, we got that. We've made it to exponents. Exponents are a good example of why Python is so popular in disciplines that are heavily math-based. And that's because not all languages have support for things, for mathematical equations like exponentiation and stuff like that. So in Python, if we want to raise one number to the power of another, we use this operator, star star, between the two. So I'll just do a little tiny example of that. We have our variable expo here. Let me clear this, don't look at that. We have our variable expo, and that's gonna be set to the value of 9 raised to the power of 2. So let's run this real quick. It's gonna be python 3 math.py. Nice, we got 81. So that's just 9 times 9, right? That's all we need to know for this section. So let's try our little question over here. What is 2 star star 3? Or 2 raised to the power of 3? Now, the way that I like to do exponents, if they're small like this, is just literally in my head. 2 times 2 is 4. Times 2 is 8. Yay, we got it. Cool. Okay, so next we're going to be moving on to changing in place. Okay, we've made it to part 5. We're going to be talking about changing in place, which is kind of a weird concept, but it's really easy once you catch it, once you understand it. So let's go over it. The idea of changing in place is that you can change a variable in place, meaning you can use it on both the left-hand side and the right-hand side of the equal sign. And I'm going to show you what I mean, because that might sound kind of wacky. So right here, if I have, get rid of this, if I have current score, and I want to set current score to its value right now plus 300, all I have to do is say current score on the left-hand side, right? Because we're resetting its value. And on the right-hand side of the equal sign, we'll say current score plus 300. Now, the effect of this is that we're literally just resetting what this variable, the value that this variable has saved in it, to that same value plus 300. You following along? Does that make sense? Let's see what this return is. Actually, we're going to do something like, let's print it after. So we'll do an F string, and we'll say current score after changing in place. We'll do our little squiggle ma bobs. Oops, wiggle ma bobs. There we go. Current score. And then let's put another print statement right before we change it. Right here-ish. So print F string. Make it look nice. Whoops. Current score before changing in place. Wiggle my bob, current score, right? I can type. Dang it. There. All right. We're going to run this. We do have a main test py, so we're also going to get some outputs, but let's just ignore those for now. So our current score before changing in place is 0. So that's as it's coming in. And then current score after changing in place is 300, just like we thought. So this is not, this line right here, current score equals current score plus 300, is not valid math, but it is valid coding. And that's because if we were trying to do a math, if we were writing a math equation right here, well, technically, this is not an equation, right? Because in math, we're trying to say that, we're trying to check or see that current score is equal to this. But that's not ever going to be true. In coding, this isn't an equation, it's an assignment. So we're assigning this value to current score. Hopefully that makes sense, but we'll talk about it a little more as we do the assignment. So let me get rid of this. So for this assignment, we're going to practice changing in place. All we have to do is take current score, which we're getting as a parameter, right? And we're going to we're going to change its value in place by using it on both hand sides, and just on the right hand side, adding our increment value, which we're also getting in as a parameter. Then we're going to return that. All right, let's run this and make sure. Cool. So we're expecting 100, we got 100, we passed that one. Expecting 300, got 300, passed that one. So let's submit. Nice. All right. Next, we're going to talk about plus equals and minus equals, which is going to be related to this. So I'll see you over there. Now that we know about changing in place, we're going to learn a new operator, which is going to make changing in place even easier. These operators are called in-place operators. This is kind of what they look like. See this minus equal down here, multiplication or star equal, divide equal, we got plus equal. These are all in-place operators. And this is sort of how they work. I'm going to show you this diagram that I made. It's definitely not dumb, and it's super, super cool. And I'm hoping that this diagram really cements this idea. So this is all that we're going to do with our changing in place. I want you to think about this, and hopefully it'll help you remember how this works. So, like we just learned, when we do changing in place, we're using the variable on both sides of the equation to change its value, right? So in this example, we have current score equals current score minus 1. Now watch this. We can basically collapse this by using our in-place operator minus equal. And I'm going to show you what that looks like. Ready? You guys ready? I want you to sear this into your brain. Watch. Boom. Do you see how easy that is? Now that we have our in-place operator minus equal, we've collapsed our entire changing in place statement into this nice little thing here. Current score minus equals 1. Boom. I want you to think about that. If you ever get confused about the changing or the in-place operators, they all work this way. So let's go look at the code real quick. Let's actually try this. So we have current health. Let's do the same thing that we did on the last one. We'll print the values first so that we can see how they're changing. But we'll start as they come in. So current health. Put our little squiggle mabobs. Squiggle mabobs, please. Thank you. Just like that. Now let's do our changing in place. So we're gonna say current health. And let's try plus equals. Plus equals, let's say something we'll be able to recognize. 77. Yeah. Now, and by recognize, I mean I'm trying to change it by a weird amount so that it's super obvious. I don't know, maybe that's, maybe that doesn't make sense. But whatever. Okay, hang on. My fingers are kind of dumb. Give me a second. Boom, there we go. There. Another F string. We'll just say after this time, squiggle mabob. Nope, squiggle mabob, thank you. Current health. Okay, let's run this. I'll drag this up. So we start with a current health of 1,000. We plus equal 77, and now our current health is 1,077. It's pretty cool, right? Let's try multiplication. This might be a little toxic because we're about to multiply 1,000 by 77, but I think it'll be okay. Let's run it. Nice, 77,000. Okay, what happens if we divide equals? Dang, look at that. We got a nice float value. So those are all our in-place operators. They're really cool. They make changing in place super easy. Actually, hang on. Those are some of our in-place operators. They're really cool because they make changing in place super easy. So let's try to do our assignment. I'm gonna get rid of this. We're gonna complete the get hurt function. We're gonna use the minus equal sign or the minus equal in-place operator to subtract damage from the player's current health and return that. All right, all we have to do is set current health to, I did it again, negative equal current health minus damage. Current health minus equals damage. Okay, let's return this. Oops, it looks like we're gonna get an indentation error from Python, so we'll fix that in a second. But let's put current health here. And boop. Okay, it's just one little space. There we go. Okay, this is looking good, right? Let's run it and make sure. Nice, we got 900, 900, 840, and 840, so I think we're clear to submit. Boom! Now we know about in-place operators, which is gonna make our life way easier from now on. Let me show you my diagram that I made for this assignment. Okay, so we have our player permissions here. We're going to pretend that each of these boxes are kind of like a little function for each permission. Each box is going to tell us whether or not the player has that permission related to that box, right? So let's give this first create guild check permission function thing our player permissions. Now, for this to work, this function is going to use bitwise and to compare our players' permissions to the permission that they need in order to create a guild, which is this most significant bit set to 1, right? So least significant, if you remember, is over here. The most significant bit set to 1, that's gonna be our create guild permission. So if we and these all the way down, we're going to get 0 and 1. We know that that's 0. 0 and 1 again, 0. 0 and 1, 0. Okay, hang on. I just noticed that my dog is in the scene. So let's say hello to Navi. But I'm gonna put her away now. Okay, there we go. Carrying on. So these three first bits all are set to 0, but we don't actually care about these, right? We only really care about the most significant bit, which is our create guild permission bit. So 1 and 0, that's gonna be 0. So this function is going to return the number 0, 0, 0, 0. And that tells us that this player does not have the permission to create a guild. So let's move on to the next one. Let's ask if this player has permission to review a guild. We're gonna put this in here and we're gonna and again. Let me grab this. We're gonna do 0 and 1. We know that that is a 0. 0 and 1, 0. 1 and 1, this is the bit that we care about. So the third bit from the least significant bit, right? This is going to be a 1. So they have the permission to review a guild. And then 0, 0, 0 and 0, 0. So because the bit that we care about is turned on or is set to 1, that means that this player does have permission to review the guild. All right. So if we continue and do these other permissions, it's going to be very similar. It's going to be exactly the same. 0 and 1 is 0. 1 and 1, that's going to be 1. That's our bit that we care about. 0 and 1 is 0. 0 and 1 is, or 0 and 0 is 0. All right, so this function is going to return, yes, this player does have the permission to delete a guild. Now let's do our last one. All right, we've got 1 and 1. That's the bit we care about. Set to 1, so they do have permission to edit a guild. And then I ran out of zeros somehow, so I'm just going to make a ton right here. 0 and 1 is going to be 0. 0 and 1 is 0. 0 and 0 is 0. So that's basically what we're going to be doing for this assignment. And I've made it this way so that you can kind of see how that math is going to happen. So let's go back to our assignment up here. So just like we had in our little example, we've got these 4 functions. And we've got these Booleans, right? Well, okay, these are not Booleans. These are binary numbers. We've got these binary numbers. Now this 0b1000, this is how Python notates a binary number. So this is the syntax for writing a binary number in Python. So let's work on this first function. You can see that we're going to get the user permissions right here. That's what we're going to be anding against. And our permission for this one, so this is our get create bits, right? Is going to be the can create guild binary number. So we're just going to say, let's say, I'm going to say permission. That's a variable that I'm going to make. And I'm going to set it equal to user permissions and can create guild. And then I'm just going to return that. It's going to be pretty much the same for all of them. Whoops. Hang on, Vim. But we can, instead of creating a variable, we can also just return our little equation. So we'll do user permissions, and this is review, so can review guild. Nice. Then we just go down here, same thing. User permissions, and can delete. And then user permissions, and can edit. All right, so I've got all of those filled in. Let's run it first and make sure that it's making sense. Okay, so for our first test, remember we got our test pi up here. Our input is 0110, that's the player's permission. So we're expecting false, true, true, and false, and that's what we're returning, so we pass that one, nice. The next one is 111, true, 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 true. We got all that, pass, pass. Okay, we passed all of the test cases for running. Let's submit it. Nice, we got it. Okay, so we just learned bitwise and, but if you remember back from the Boolean operator section, we still need the equivalent of a Boolean OR. So we're gonna learn bitwise OR today. And instead of me just telling you, like going through it very painfully and slowly, we're gonna jump straight into the assignment instead because I think you've got it. It's super simple. All right, so this assignment is all about being in an MMO. It's gonna be about our Fantasy Quest game. We have a party of 4 players going into a dungeon. And depending on their role in the dungeon, damage dealer, tank, or healer, they get different permissions, right? They can either invite players, kick players, enter the dungeon, or surrender. But not every role has every permission, so you need a combination of all the roles in order to get all the permissions. And that's because we're gonna be using a bitwise OR. Now, bitwise OR is gonna be a lot like our Boolean OR. This is the operator for it. Sometimes it's called a pipe, but that's what it looks like. So let me show you how we're gonna go through this. To get the party permissions, because the party adopts the permissions of everybody in it, it's gonna be different than the bitwise and. If one player has one permission, the entire party adopts that permission. So these are 2 damage dealers, 2 different players, right? We got Wagslane and Acorn, Bad Cop and TrashPuppy. Bad Cop's the tank, TrashPuppy's a healer, and these 2 are damage dealers. In order to find out the party's permissions, we're going to take a default set of permissions, which is all of them turned off, right? And we're going to OR them together. So let me drag this up here so we can see it. This, I should have left down here. Boom. Okay, I'm gonna move it up just a bit. So we're gonna take our first player, Wagslane, and we're gonna take his permissions. He's got, because he's a damage dealer, he can enter a dungeon, but he's not allowed to do these other things. So let's OR these. If you remember from when we talked about OR, well, I made a little table for us to figure out all the combinations of OR and what they would be. Kind of like our truth tables. We're gonna start with our least significant bit. If we say 0 or 0, that's gonna be 0, right? 0 or 0 equals 0. 0 or 1 is gonna give us 1. Then the rest are zeros, so 0 or 0, we're gonna get another 0 here, and another 0 here. Okay, so these are our party permissions so far. So I'm gonna grab this, put this back. We're gonna move this up to where our permissions are. These are our old permissions, right? This is not us anymore. These are gone. We're replacing this value with this one. So this is our party's permission so far. All right, let's bring the next player in here, Acorn. Okay, so Acorn is also a damage dealer. So are we going to adopt any permissions from her? Let's try. 0 and 0, or sorry, 0 or 0. 0 or 0, that's gonna be 0. Just gonna make a bunch of over here so we can use them. And I'll make a bunch of 1s. All right. 0 or 0 is 0. 1 or 0, that's going to be a 1. 0 or 0, 0. 0 or 0, 0. So you can see that our new permissions are the same as our old permissions. when we included Acorn's permissions. Okay, so let's get rid of the old one. Bring the new one that we just got up, and we'll do the next player. Okay, next we got Bad Cop, who's a tank. Now as a tank, Bad Cop can enter the dungeon and also surrender. So let's try it now. 0 or 1, that's gonna be 1. 1 or 1, that's gonna be 1. And then these are zeros, right? So now our new permissions include surrendering. So let's get rid of the old ones. Oops. And let's put our new party permissions up. Okay, last one, we got TrashPuppy the healer. And I just want to say that I would never heal. Whatever, it's fine. In this world, TrashPuppy is the healer. So the permission that the healer brings to the table, or the two, is kicking players and inviting players. So we have all the permissions so far in our, or those are the two permissions that we're missing as a party. So 1 or 0, that's gonna be 1. 1 or 1, that's gonna be 1. 0 or 1 is 1. 0 or 1, that's gonna be another 1. Nice. So now we can grab this, and since we've done the calculations with all of our players, we know that our party's permission altogether is satisfied for all the permissions. We have all of them as a party. And that's how OR works. Okay, so now that we've seen it in a diagram, let's try to do it over here in the code. All right, so in the code, we're just gonna do the same thing. Let's say, I'm gonna pull this out so we have a little bit more room to see. Party permissions, and we're literally just gonna use our bitwise OR with all of our players that are coming in as parameters. So Glorfindel, Galadriel, if I could spell, or Elendil. So these are their permissions, and Elrond. All right, so party permissions will be, there will be a binary number saved to this, right? We're gonna return that. And it looks like I'm about to get a syntax error or an indentation error from Python. So let me put another space in here. All right, cool. Let's try to run this and see what happens. Cool. So these are actually the decimal representations of our numbers, which is totally fine. It looks like we passed the run example. So let's submit. Nice. We did it. Now we know bitwise OR. Okay, congrats. We've made it to the end of the computing chapter. And the last section is on not, which we actually went over. So you're welcome. Now, if you remember when we did go over it, not you use in front of another value in Boolean logic, or, well, let's just say in Boolean logic, and it's going to basically invert the meaning of the value. So if I have true and I put a not in front of it, it becomes false. That's all it does. So we can do this. It's super easy. The operators and or and not are logical. Logical, we've been calling them Boolean, but they're logical / Boolean operators. Right? Right, guys? Yes. Okay, good. And that's it. That's the end of the chapter. Cool. Welcome to chapter 7. We're gonna be talking about comparisons, and this is where your coding is gonna actually start leveling up. So get excited, because doing comparisons between two values is one of the foundational concepts in coding. We're actually gonna be adding real logic to our code now, so get ready. So we've actually gone over a little bit of this already. Comparisons are going to include Boolean logic, true or false, and some comparison operators, one of which we've already talked about, which is equal equal. So when I talk about comparison, we're really talking about, as far as programming is concerned, we're talking about Boolean logic. And we already know what that is, right, from the last chapter. But just as a little review, Boolean logic is going to be comparing two values in a way that results in either true or false, right? Remember, in Boolean math and Boolean logic, we only have two possible values, true or false. So let me show you what I mean about comparison, because I'm sure you're wondering, you know, TrashPuppy, when the heck am I ever gonna need to compare two things in my code? That sounds, you know, dumb. But I have an example for you. We're making the Fantasy Quest game, right? In our game, players have to log in, and to log in, they have to use a username and password combination, right? And then to make sure that they're actually who they are logging in as, we have to do a check or a comparison between what we know of that player and what they're giving us for their login. So if you look at my little diagram here, I've got a login form over here for username and password, and we got the little login button. And then on this side, this is more like our back-end code or the logic that's gonna help us decide if the person trying to log in is who they say they are. If you remember back in chapter 1, we talked about back-end and front-end code. This is actually a pretty good example of those two. So this would be our front-end app where the form is rendered, where it's styled and displayed to the user. This is a good example of our back-end code where we're doing all of the logic and comparison to make the front-end work, right? We're gonna compare, we're gonna make sure that their credentials actually make sense on the back end. Okay, so let's say that we have a player, TrashPuppy, who's trying to log in, and they're using the password I love my mom 123. Now, when they use this password and they hit login, these credentials are going to be sent to our back-end code. If you look over here, I've got a little function called check login credentials, right? And it takes a login username and a login password, which is the credentials that the person is sending from the form on the front end to us. So I'm going to put these values in here, right there and right here. Now, we have in our database, most likely this would be in a database, we have what we know about the player TrashPuppy. We know that this is their username, and we know that their password is I'm the coolest puppy and I'm definitely 6 feet tall. So when somebody on the front end, when a user is trying to log in as TrashPuppy, we have to do a comparison between their credentials to see if they're actually who they are. So we have two sort of comparison questions in here. And we're using the equal comparison operator like we've already learned about. The first question is, does the login username equal the player username? And if you remember about equal, this entire question or statement is going to resolve into a Boolean. It's either going to be true or false, right? We have a similar question right under that. Does the login password equal the player's password? So let's do this. We're going to bring in what we know about TrashPuppy. And we're gonna do our little comparison code here. Okay, so they're trying to log in, the credentials come in, and our code runs, our little function. So what happens in this first statement? Does TrashPuppy equal TrashPuppy? Yes, that's true, right? So we get a Boolean true here. Does I love my mom 123 equal I am the coolest puppy and I'm definitely 6 feet tall? No, right? So this statement here is gonna tell us false. Now, likely what would happen is if this were the case, this function would return to our code that no, this player who's trying to log in is not legitimate, right? Because we have a true and a false. Now, let's say they had the right password. They logged in with this password and this statement became true. Now our function is going to tell us, yes, this is the right person. They're allowed to log in, right? All right, so there are a couple other comparison operators besides equal. I'm gonna show you one. It's super similar, so we're gonna go over a very similar example. Let's say that the person trying to log in is Nate Codes. That's the username. Here's what we know about Nate Codes. His password is password12345, which is actually the most common password. So don't ever use that. Don't be like Nate. Sorry, Nate. I know you probably wouldn't do that. Let's say this person is trying to log in with the password I love my mom 123. What's gonna happen? Let's bring these down here into our little function. It's the same function, except now we're gonna be using this comparison operator, which is it's exclamation point equal, which means does not equal. It's the exact inverse of the equal comparison. So if this means not equal, then the logic in our function is going to flip from what it was doing last time. So let's bring what we know about Nate Codes in, and let's do our comparisons. Does Nate Codes not equal Nate Codes? So that's the question we're asking now, the exact opposite. With equal, we were asking, does TrashPuppy equal TrashPuppy? Are they the exact same? Down here, we're saying, are they not the exact same? So this is going to actually return or become false. This whole statement resolves to false because they are the same, right? Does Nate codes not equal Nate codes? That's false. Now, does I love my mom 123 not equal password 12345? This one's actually going to resolve to true, right? Because they don't equal each other. So in order for somebody to log in successfully, these two would have to both equal false. So let's make that happen. Let's say instead of I love my mom 123, let's say they tried to log in with the correct password 12345. It comes down here. Now it becomes, does password 12345 not equal password 12345? Well, they do equal each other, so this whole statement is false. So now, with both of these statements equaling false, this function likely will return to us, yes, this is the correct user, right? Now, I'm not saying that this is how you would actually code this function. In fact, you probably shouldn't because it's a very confusing way to do this check, but I thought it would be a good example to show that equal and not equal are the exact inverse of each other. So don't code like this, but just take it as an example of what not equal is supposed to do as a comparison operator. Okay, so what about the other comparison operators? Well, I think you'll probably be pretty familiar with them because they're really common in just basic math. You've got the greater than sign, the less than sign, the less than or equal to sign, and the greater than or equal to sign. Now, just like equal to or equal and not equal or not equal to, these being used in a statement are going to cause the statement in the code to resolve to a Boolean true or false. So let's try to do this assignment. It's going to be super easy. All we have to do for this one is return whether or not player 1 has a higher score than player 2. Now, because the statement, just like we showed in our little example over here, because a comparison statement resolves into a Boolean value, we can use that as our return, and I'll show you what I mean. We're just going to say return player 1 score is greater than player 2 score. And that's because before the function returns, this is going to execute. Python is going to decide, okay, player 1 score as it's coming in as a parameter. Is that number larger than the player 2 score that's coming in as a parameter? If it is, this is going to become true, and we're going to return true. So let's run it and see if that's actually happening. Nice. It looks like we're passing all of our run tests, so let's try to submit it. Yay, nice, we got it. All right, now you know about comparisons in code. We're going to talk about how we can store the result of a comparison in a variable to be used. So I'm going to bring you over to my code. I've coded our little example from here that we just did in the last section. I've made our check login credentials function here. So we're going to pretend that this is our little database, and this is where we have all of our information about the user Nate codes, right? We know his password, we know his username, right? So down here, we're going to pretend that these are the credentials that somebody is trying to log in with. And then this is going to be our function that does the check like we did in that diagram, right? We got login username and login password here. So you can see down here that I have a variable called login successful, and I'm setting that to whatever is returned from check login credentials. And we're giving this function our login username and our login password, the credentials that somebody is trying to use to log into the game. Now, once we get login successful, the variable, whatever is returned from our function, we're going to print it, login successful, right? And I'm not going to give away yet what it's going to print to us. So let's finish out this code. In the last section, when we did the assignment question, we just returned the result of our comparison statement, right? But this time, we're going to save our two comparisons, the ones that we did over in our diagram like this. We're going to save this value that we get from our comparison statement in a variable. So username's match is going to be my variable for whether or not the login username and the user username that we have in our database match. So all we have to do is say that usernames match is equal to login username equals user username. Okay, so this is our statement, right? We're checking, does login username equal user username? And if this is true, usernames match is going to have the value, the Boolean true saved into it, right? Now passwords match is going to be super similar. We're going to say login passwords equal, oops, user, oh, this should not have an S. There we go. User password. Okay, now we have our two Boolean values. Down here, I have another variable because we're actually going to do one more Boolean comparison, right? We have two Booleans up here. We want check login credentials, our function, to return true if both of our credentials match, if our username matches and if our password matches. So both match is what we're eventually going to return. Now, remember in the last chapter, we learned our bitwise and, like this. We're actually going to use that right here because we want to collapse these two variables into a single variable that we can return. So we're going to compare them. So both match is going to be equal to usernames match and passwords match. So remember in our last section when we talked about bitwise and, when you put bitwise and between two Booleans, both of them have to be true in order for the statement to be true, right? And since these are both going to be holding Booleans, we're using the bitwise and to compare them or to find out whether or not both of these are true or false, right? So let's say that the usernames match, but the passwords don't. This one's going to be true, this one's going to be false. If we do true and false, that's going to resolve to false, right? So both match is going to be false and our function is going to return false. Okay, so if they do both match, if these are both true and we bitwise and them, true and true, then we're going to get true saved into both match and we'll return true. Do you see how that works? That's how our function is going to tell us whether or not the user that's trying to log in is legitimate. All right, so let's save this and we're going to try to run it. So see down here, login successful, false. Now why is that? Because the login password that this person is trying to use is "wow is a lame game!" exclamation point. But the real password for Nate Codes is password 12345. So if we change this to match our other password, the password that we know our user is going to use because it's in our database up here, or that our user should be logging in with. If we change that to the correct password, now our function should return that this is the right person and their login was successful. Boop. Nice. See? Login successful is true. Okay, so now that we've sort of seen how to do this, let's go to our assignment. So for this assignment, we're getting the height of 5 different people and we're going to compare them with a couple of variables, or we're going to compare their heights and save the outcomes to some variables and then return those. So we have, is Mustang Edward the same? Is Alphonse and Edward the same? Is Winry and Alphonse the same? So all of these, if you are reading the variable names, if you read the variable names, you can kind of guess what we're going to compare, right? And this is good practice. Try to make your variable names make sense for what they're actually holding and the value that they're supposed to hold. So let's start with is Mustang Edward. We're going to say is Mustang Edward same. And we're going to set that equal to Edward height equals, oops, let's do it the other way. Mustang height. It doesn't really matter, but just to make it more, just so that it makes more sense. Mustang height equals Edward height. So that's our first Boolean. Next we have is Alphonse Edward same. We're going to set this equal to Alphonse height equals Edward height. And then our last one is Winry Alphonse same. And same thing, we're just gonna set Winry height, or we're gonna ask if Winry height is equal to Alphonse height. Now, we have our 3 variables that we created and saved our Boolean values to. Now we're just gonna return them all together and in the right order. So we wanna return, is Mustang Edward the same first? Then is Alphonse Edward same? And then is Winry Alphonse the same? Okay, let's try to see if this is gonna work. What do we got so far? It looks like we're passing our run test, so let's try to submit it. Yay! Now we know how to save Boolean statements, or the Booleans that we get from comparisons, into variables. Okay, in section 3, we're just gonna do a little practice with some of our comparison operators. So let's just do the assignment together. In this assignment, we have to complete the can withstand blow function so that it returns true if the hero's armor in our game is greater than or equal to the damage dealt by an enemy, and false otherwise. Remember, 2 assignments ago, we were able to return our statement in our return line, right? Because it's gonna resolve to the Boolean that our function needs to return. So let's try it like this. We're gonna return hero armor greater than or equal to the damage that they were just dealt by an enemy, right? So if their armor level, let's say it's like 100, and the enemy damages them for 70. Well, their armor's higher than that, so they'll be good, right? It'll take 70 points of damage before, yeah, I know what I mean. Okay, let's try to run this. Cool, we passed. So let's see, I wanna kinda look at this for a second. Our inputs here, 175 for the hero armor, 250 for enemy damage. So yeah, no. The damage is too high. Our hero is gonna take some actual damage to their health because the damage is, you know, taking up all of their armor. Or however you say that, you know what I mean. Okay, so let's submit this and see what happens. Yay, we got confetti. Cool. So next we're gonna be talking about if statements. And you should be really excited for that. So I'll see you there. Okay, in this section, we're gonna be talking about if statements. And just like the last section when we talked about comparisons, if statements are going to be a big building block or a foundational building block for doing true logic in our code. So if you think about it, your code, you're probably gonna want at some point to change how your code executes based on certain conditions that are met, right? And we do this in code using an if statement. So let me show you what I mean. First, we're gonna talk about what if statements kind of look like in Python, but in also a lot of other languages. They kind of look like this. You're gonna have literally the word if, and then you're gonna have some condition, and this condition has to result into a truthy value. And when I say truthy, I mean that not necessarily true, the Boolean, but things that Python, based on the rules of the Python language, things that Python considers to be truthy. So to explain it, we can also talk about falsy. There's truthy and falsy. So an example of something that's falsy is a string, which we learned about, that has nothing inside of it. An empty string would be considered falsy. If you had a 0, that would be considered falsy. If you had a 1, that would be considered truthy for Python. So the value that the condition resolves into doesn't necessarily have to be true, the Boolean that we've been talking about. It just has to be truthy. Okay, so let me get rid of this. Now, let's say our condition is met. We could use the example like with our login credentials. If both the credentials match, that could be our condition. If they both match, do this, right? If the credentials that the person or that the player gave to us when they logged in are both correct, then we're gonna do this, right? In Python, like we talked about before, Python cares a lot about white space. So when you have an if block like this, you need to indent at least once over, and everything that you write as far as your code goes, or the code that you want to execute if the condition is met, has to be indented at least once. So every line under the if statement that you want to be part of the if statement has to be indented at least once. Okay, so basically, everything that you want to happen if your condition is met or if it is truthy is going to happen here underneath the first line of your if statement. Now, let's go to an actual real world example. We'll be using our game Fantasy Quest. Now, if you have ever played a video game, and most of you hopefully have, then you're probably familiar with the idea of an attack radius on an enemy. As in, there's an enemy in the world, and if your player gets close enough to that enemy, then they will attack you, right? So, if we were to code this into our game, into our Fantasy Quest game, our if statements might look something like this. If player distance from enemy is less than the enemy radius, enemy attack player. So, if this condition were to be met, it would look something like this. Let's make the distance green. So here's our player. Their distance from the enemy is less than the enemy radius, right? So the enemy is going to attack them. They've met this condition. This condition is truthy. And so this code here after the indentation is going to execute. Now, what else could happen? The other condition is that the player is not within the enemy's radius. So we could have an if statement that looks like this. If the player distance from enemy is greater than the enemy's radius, enemy not attack player, right? Now it's not going to be written exactly like this in Python. You could call this pseudocode the way I've written it here. It's not truly written like this. The syntax would be totally messed up, but we're just planning how our if statements might look. So we're using pseudocode, or basically it's just a way to write code that you're planning for. You're not going to execute this, right? It's just a way to plan for it. So if I were planning these two if statements, I might write it like this. But the source code that we write to actually achieve it would look completely different. It would have to have the right syntax, right? Okay, so if this condition is met, the player's distance from the enemy is greater than the enemy's radius, then the enemy is not going to attack the player, right? So you can see with these two if statements that we have conditions that if they are met, the code does something differently, right? Okay, so let's go up to our assignment. In this assignment, we're going to complete the print status function. If the player's health is 0, we're going to print the text dead to the console. Afterwards, whether or not the player is dead, print the text status check complete to the console. So we haven't quite talked about what this second part means, but I'll show you by doing our little assignment. So we're going to do this function up here. We're going to add our if statement. So remember, we're going to start with literally the word if, and we're checking to see if the player's health is equal to 0. Now, this is my condition that I want to be met in order for the next piece of code to run. So I'm going to put a colon. That's going to tell Python that we're going to indent a little bit, that this is our if statement, and this is the code that we want to happen if this condition is met. So we're going to print dead to the console, right? Now, the other part of this part of the assignment, the second part here, it says afterwards, whether or not the player is dead, print the text status check complete to the console. Now, what it's saying is that after our if statement, we're going to indent once, just like we would in our function, and we're going to print status check complete. Now, what this is showing is that whether or not we meet this condition, this code is going to execute no matter what. So there are two things that could happen in this function. First, the player health is equal to 0. If the player health parameter comes in and it's equal to 0, this if statement is going to be met and we're going to print dead. And then once this is done executing and we come back out of our if statement, then we're going to print status check complete. Now, the second thing that could happen, player health comes in and it is not equal to 0. So Python is going to do the check. If player health equals 0, it doesn't. So this check will resolve to a falsy statement, right? It's going to be false that the player health is equal to 0. It's going to skip this line of code within the if block, and it's just going to run this. It's just going to print status check complete. Okay, so let's run it and see if that happens. All right, so when our player health is coming in as 0 on this first test in the run, you can see that checking status is printed. Dead gets printed. This is our code in the if statement, and then status check complete, right? Because status check complete is going to run no matter what, whether or not the player's health is equal to 0. Now, we can see that here in the next section, or the next test. Player health is 5 now. So checking status gets printed. Then our function is probably being called, and all we get is status check complete because our condition was not met, right? The player health is 5, so it is not equal to 0. So this is false, meaning the code underneath it is not underneath it, indented underneath it in the if block is not going to run. All that's going to run is this one here. All right, hopefully that makes sense. Let's hit submit. Boom, we got that. Okay, so next we're going to talk about if else. It's going to get even spicier. In this section, all we're going to do is practice what we just learned about if statements. So let's go straight into the assignment. For this assignment, we're going to complete the check swords for army function, and we're going to return whether or not we have the correct amount of swords for this number of soldiers, right? So if the number of swords is equal to the number of soldiers, we're going to return the string correct amount. If they're not equal, we're going to return incorrect amount. All right, so let's put our first if statement in here. We're going to say if number of, swords. And you could write it both ways, but for me, it makes sense to put the swords first. Because the swords are going to be the deciding factor, right? If the number of swords is equal to the number of soldiers. Make sure we put our colon. Then we're going to indent in because now we're writing the code that we want to happen if our condition is met, meaning the number of swords is equal to the number of soldiers. We're going to return correct amount. Boom. Okay. Now, right here, are we going to write a second if statement? We totally could. We could write if number of swords does not equal. In fact, let's do that because I want to show you something. If the number of swords does not equal the number of soldiers, we could potentially put return incorrect amount, right? But we don't actually have to do this. We don't actually have to write a second if statement because there are only two things that could possibly happen when these two parameters come in. The first thing is that the number of swords is equal to the number of soldiers. So if this condition is met, we know that this line is going to run. And if you remember when we talked about functions a few chapters back, when we return something, that's the end of the execution of the function. So if we return here, the code under here is never going to happen, right? Now, the other thing that could possibly happen is that the number of swords does not equal the number of soldiers, in which case we would return the incorrect amount. But if you think about it, do we really need to check for that? Do we need to ask that question? Because there's only two possible things that are happening. If this one happens and we return out of the function, then why do we need to ask this at all, right? Let's say this condition is not met. Then the only other thing that could be true is that the number of swords does not equal the number of soldiers. That's the only thing. So we can just return right after the call of that, or right after that if statement. That's all we have to do. We don't have to ask again. Technically, our question has already been answered. And because we return out of here, we know that this is not going to run if our condition is met. So if our condition is not met, this is going to run. Does that make sense? All right, let's try to run it and see what happens. Cool. So we passed our first two run tests. Let's try to submit this. Nice. Good job. Now I want to make sure I cement this in your brain because it's a little weird. There are only two possible things that could happen, right? If this condition is met, we're going to return out of the function. The rest of the function is not going to execute. So this will never happen, right? If this condition is met. If the condition is not met, which is the only other possibility, then we can just immediately return. We don't have to ask again. We don't have to have a second if statement. because we already know that because this condition, this if statement didn't run, that means that the other condition was met, so we can just return right here. Okay, cool. Hopefully that's cemented in your brain, because next we're going to be talking about if else. I want to point out that in the last example, I actually made a little mistake. I was saying that when you have your if conditionals expanded out like this into their own statements, that if the health was 0 and this if block conditional was met, that these other two, even though they weren't going to be met, would Python would still have to check them. But guess what? It's even worse. It's even worse than that. When we have them all expanded out like this, and Python isn't just skipping when the first if block is met back, out of the whole if block itself. This one is going to run and actually be true. The condition is going to be met here because if health is coming in as 0, 0 is less than or equal to 5, right? So this one is actually going to fire off and you're going to get your status variable set to injured. So then you're going to be returning the wrong status, right? Because first it's going to be set to dead because this condition is met. Now this condition is also going to be met, so it's set to injured. And even though it's going to skip this one because this one won't be met, you're going to be returning that the player is injured even though they're dead. So just wanted to make sure that I fixed that and showed you how having each condition expanded into its own if statement can actually be way worse than just having the chain of if, elif, and else. All right, cool. Now that we've just learned about if, we're going to learn about if else, because what we just did before was having a bunch of if statements checking for our different conditionals. And we were only dealing with conditionals that really only had 2 possible outcomes. But what if you want to be more fine-grained about the conditions that you're checking for and treating specifically? What if you have more than 2 conditions? Let's look at the assignment because that's how our assignment sort of is written. It has multiple conditions that we want to check for and do different things for. So I'm going to use that and we're going to work through it so I can tell you all about if else. So what we've learned so far, if we were to solve this problem using just what we've learned so far, if statements, it would look like this. And by problem, I mean we're writing this function which is going to return the different possible statuses of our player depending on their health, right? So instead of just having 2 possible outcomes, there are 3. The player is either dead because their health is less than or equal to 0. They're injured because their health is less than or equal to 5, or they're healthy where their health is greater than 5. So that's 3 conditions that we want to check for and do different things for. So if we were to write it just using if statements, it would look something like this. If health is less than or equal to 0. Oops. Make sure we put our colon and make sure we indent. We're going to have this variable called status and we're going to set it to dead. Now, quick little side note. Remember when we talked about scope, that this variable being created within the if block is still being scoped to the function, which is unique to Python. Python scopes its variables to their function, so status is going to be available to us even when we're outside of the if block. All right, so let's write the next one, if it'll let me. There we go. If health is less than or equal to 5, then status equals injured. Whoa, injured. And then our last one, if health is greater than 5, then status equals healthy, right? Now we're just going to return, if it lets me, we're going to return the status. Okay, cool. So we could write it this way, but there's a few reasons why we don't want to do that and why we want to use else and elif instead, which I'll get to. But let me explain why this is kind of gross and toxic. If someone's trying to read your code, first of all, because you're expanding each condition into its own little if block, they're not as logically packaged together on the page, which makes it a little harder to read. When you're writing conditionals that are related to each other, you kind of want to group them together in a way that's easy to see as someone who's reading your code. Now, the other thing is that we're checking for conditions that are very specific, right? But what are we going to do if none of these conditions are met? Well, I'm going to show you. We can use else instead. So let me introduce you to else and elif. Else and elif are keywords in Python that you chain together with an if statement. So for this example over here, if the score is greater than the high score, we're going to do this. Else, if the score is greater than the second highest score, we're going to do this. Else if whatever. And then at the very end of our chain of conditions, we have else. Now this else at the end is going to check, or is going to catch every other possible condition, right? So using if, elif, and else is going to be better than having a bunch of if checks, because first of all, we're grouping them logically on the page for somebody else to read. Somebody who's reading our code is going to know that these elif and else statements are connected or related to this if block. And I want to point out that you cannot have elif or else if you don't have a starting if statement. Another reason why this is better is because over here in our bad example, let's say this condition is met, right? Whether or not this condition is met, this next if is still going to have to fire off. Python is still going to have to execute this and check if it's going to be true or not. And same here. So let's say the health comes in and it's 0. Technically, status is this condition is going to be met and status is going to be set to dead. But there's nothing stopping Python from checking the health again, like 2 more times. Even though we know that this is not going to be met, that these conditions aren't going to be met, and the status is not going to be recalculated to either injured or healthy, the execution is still going to be less efficient because Python has to actually look at each of these blocks. Python is not grouping them together, right? Whereas when we use if, elif, and else, Python knows that these conditionals are chained together. So if the first if statement is met, if this condition is met, it's going to skip all of these other things. It's going to skip the elifs and the else and just continue on the execution. So it's a little more efficient. It's easier to read for other people and yourself. And with this else statement, you're going to be able to catch every other possibility, which can also be a good thing. Because if you don't catch every possibility, you might run into bugs that you can't foresee because you haven't caught them or dealt with them in any way. We're going to rewrite our code with else and elif, and I'll show you how that works. Okay, so we have our first if block. We're checking to see if the health is less than or equal to 0. Now, if that doesn't happen, so in plain English, else if the health is less than or equal to 5. Now, I expanded this into else if. This is not proper Python syntax, but I wanted to show it to you because you're going to see it like this in other languages, but also just to demonstrate how it would sound if you were to literally be asking this question in human language, right? So what Python does is a little interesting. It's going to contract else and if into elif. So you're going to say if health is less than or equal to 0, do this. Else if, or elif, the health is less than or equal to 5, we're going to do this. We're setting status to injured. Okay, now the last thing is else. Now I'm not going to put else, health, whatever. That doesn't make sense, right? When you use else, you use it by itself on the line. All you have to say is else. You're not checking another conditional, right? Because this is a contracted else with an if. The if sort of tells us this is a new conditional. You're just saying else if anything else is happening, else anything else. If these two conditions aren't satisfied, else we're going to do this, right? It catches everything else that you haven't checked for. In this case, the health is greater than 5, right? So we're going to put right here status equals healthy. Okay, hopefully that makes sense. You can kind of see with the written out like this, how it makes it logically just a little easier to read and group together, but let's make sure it works by hitting run. Okay, we passed the first one, we passed the second one, now let's submit it. Nice, okay, hopefully that helped you understand if else. Okay, we're gonna do a little bit more practice with if else in our assignment here. So in this assignment, there's a bug that we have to find. Our function check high score should return whether or not the current player is the highest scoring player or not. And we're just going to do that by checking to see if the current player name is the same as the high scoring player name. So right now, if we read this, you can see that the if statement here is just saying if true. Now, if true is always going to be true, right? True is true. So if I run this, what do you think is going to happen? What we're getting out of our code is you are the highest scoring player, right? Which is this string here. And we're getting that no matter what, right? So in our first input, Ash Ketchum is the current player name and Ash Ketchum is the high scoring player. So, you know, that makes sense. But in our second input, Brock is the current player name and Ash Ketchum is the highest scoring player. But we're still getting you are the highest scoring player. That's because this is always true. If true is always true, so we're always going to return this. So this is where our bug is. Let's fix this. We want to say if current player name is equal to the high scoring player name, then we can return you are the highest scoring player. Else, we're going to return you're not the highest scoring player. Okay, let's run this and see if we fixed it. Okay, we passed the first one, but that was true last time. So what about this one? It looks like we passed. Nice. So let's submit and see what happens. Boom, we got him. That was super easy, right? Let's go on to the next one. So in this one, we're going to complete the check high score function. If the player name matches the high score name, we're going to return the string high. Otherwise, if it's lower scoring, then we're going to return low. If either of those conditions aren't met, we're going to return neither. So we probably want to use if, elif, and else, right? Because we have more than one conditional, or more than two conditionals, more than two possibilities, right? Okay, let me fix this up. I'm going to tab over. We're going to open our if block by saying if player name, oops, let's see. If the player name matches the high score name. Yeah, so it's going to be the same as last time. If player name is equal to the high scoring player name, then we're going to return, messed up my tabs over here. Python will not be down with that. We're going to return the string high. Elif, right? Player name. And this time we're going to be checking if it's lower, if the low scorer, if it's the low scorer. Okay, yeah, so now we're going to check if the player's name is equal to the low scoring player's name. Boom. If that's true, then we're going to return the string low. Else, basically, if anything else, like if either of those aren't met, we're going to do this. Return the string neither. Okay, cool. Let's run this and see if we got it. Okay, we passed the first one. And it looks like we passed the second one. But right now, we're only seeing low and high. So the run test cases aren't testing for the last thing. So let's see if we got submit. There's a chance that we didn't since we can't see in our run tests. But I have a feeling that we did. Nice. Okay, good job. We got all three of them done, and we're good on this one. Congrats, you've made it to the end of chapter 7. And before we close it out, we're going to go over Boolean logic again, and I'm going to show you how we can combine Boolean logic with Boolean operators like we used in the last chapter with our new comparison operators that we learned. So we're going to jump right into the assignment. For this assignment, we need a way for our game, our fantasy quest game, to track whether a character's attack hits or misses an enemy. So we're going to complete this does attack hit function, and it should return true if either of the following conditions are met. Either the attack roll is not a 1 and the attack roll is greater than or equal to the armor class, or the attack roll is a 20. Now, you can actually, this sounds like 2 conditions, but you can actually break this into 3 conditions, and I'm going to show you what I mean. So for me personally, when I code, it's easier to create variables to save all of the different working or like moving pieces of my code. So I like to expand everything out into its like most simple part, I guess you could say. Let me show you what I mean. This first condition here, the attack roll is not a 1 and the attack roll is greater than or equal to the armor class. It sounds like it could be one condition, and you could probably code it as one condition, right? But I'm going to break it into two conditions, into two different variables, because it's going to help me think about how they both interact with each other and this last one. So I'm going to call them, I'm going to start with condition 1. Oops. Condition 1 is going to be the attack roll is not a 1. That's all I'm going to do. Attack roll does not equal 1. Remember what we learned about. This is going to be resolved into a Boolean value. So condition 1 will be a Boolean. Now our second condition is, I'm going to call it condition 2. And that's going to be the second part of this sentence. And the attack roll is greater than or equal to the armor class. So that is the condition. So the attack roll is greater than or equal to the armor class, right? Cool. Now we have a third condition, right? Call it condition 3. The third condition is the attack roll is a 20. So attack roll is equal to 20. Okay, now we have our 3 conditions. How are we going to combine them into something that we can return from this function? So let's reread this, make sure we understand it. The function should return true if either of the following conditions are met. The attack roll is not a 1, and the attack roll is greater than or equal to the armor class, or the attack roll is a 20. This is where our Boolean operators are going to come in. So we're going to take condition 1 and condition 2. And remember that we can nest our conditions or our expressions. So the first one is the attack roll is not a 1. We already took care of that. And the attack roll is greater than or equal to the armor class. So remember, condition 1, 2, and 3 are all going to be they're all going to be Boolean types by the time they make it to line 6. So we can compare Boolean types, remember, using our Boolean operators. So we're just going to say, and condition 2, right? I want to say the attack roll is greater than or equal to armor class. We can even, yeah, we'll say it like that. Now we've nested those together so that this sentence or this statement resolves first. Now we can add our last condition, and we're going to append it onto here with an or. So, or the attack roll is a 20. I'm literally just going to say or condition 3. And let's save this to a variable. We're going to call it, we'll just call it result for now. And we'll return the result. Okay, so let's walk through it just to see what might happen, just to think about if we've written this right. Let's say that our attack roll is a 6 and our armor class is 5, right? So condition 1, attack roll does not equal 1. This is going to become true, right? Attack roll is greater than or equal to the armor class. I said 6 and what? What did I say? 1? Attack roll is 6. Did I say 6 and 5? I forget. Let's say armor class is 5. Attack roll is greater than or equal to the armor class. So the attack roll is 6, armor class is 5, so this is going to be true, right? Okay, now our last condition. The attack roll is equal to 20. This is going to be false. So what's going to happen? Condition 1 and condition 2. Well, we know that true and true is going to resolve to true. So this is going to be true. And I can try to make that easy to read by putting in, oops, hang on, by putting in a little comment right here above it. Okay, so this is going to be true. Or condition 3. Well, we know that condition 3 is false. We'll put a false right above it. I actually do this when I code, by the way. Like, I will actually write in with comments little practice or little pretend values and see how they go through step by step. Okay, so result, true or false? Well, we know that true or false is equal to true. So the result is going to become true. That's what it's going to be with this little test case that I've made. All right, so I think this is working pretty well. Let's see what happens when we run it. Okay, we passed the first two. That's awesome. I'm not gonna walk through what they're doing because we've already done that. So let's see if our function holds up to the submit cases. Nice, cool, we freaking nailed that one. All right, we have one more little question about Booleans before we're done with the chapter. So we're gonna refer to these as we go through the questions. What is the value of result? Talking about this over here. Okay, let's go through it. So, result is set to is tall and is fat. Well, is tall is true and is fat is true. So this first little nested expression is going to be true. Now this one over here, is skinny is false and is short is also false. So false and false is going to be false. So we have a true or false. So the result is going to be true, right? Nice. Okay, next. Okay, this is our last assignment. Let's go over it. In this one, we're going to be fixing up this function should serve customer. So basically, we want our function to check these conditions and decide whether or not we should serve our fantasy quest if the bartender in the game at the pub is allowed to refill or give them virtual beer. Okay, so here are the conditions. The customer has to be 21 or older. The bartender has to be working. And the time has to be at least 5, but not later than 10. So those are our 3 conditions that have to be met in order to serve whatever customer is coming in as a parameter here. So it actually looks like we're probably getting we're getting 2 Booleans, and this one is likely, it's either gonna be a string or a number, but I bet you it's an integer or a number. Let's do the same thing we did last time. We have a couple of conditions. We can break them down and make them easy to read, right? So our first condition, we want to check if the player age or the customer age is greater than or equal to 21. So condition 1 equals customer age is greater than or equal to 21. Our next condition, condition 2, is going to be whether the bartender is on break. So actually, we don't even have to write a condition for this because, oh, did I say that this was a Boolean? This is not a Boolean coming in. On break is a Boolean coming in. Customer age is an integer, and so is time. So scratch that when I said that at the beginning. Now, we don't actually have to set condition 2. We could, but it's a little verbose. It's a little like we don't really need to because this is already a Boolean. It's either going to be true or false that our bartender is on break. So I'm actually not going to write this one, but I'll keep it here because it'll be easy to reference and, while I'm writing the rest of the code. Okay, so I'm still going to call this one condition 3. Our condition 3 is that the time is at least 5, but no later than 10. So we want time, let's see, we might have to use 2 different Boolean or 2 different comparison operators in this one, and I have to think about this when I do that. So we want the time to be at least 5, but no later than 10. So I think we can say 5, at least 5, so greater than or equal to 5, right? I think we put time here. So basically what I've said so far is 5, we got to turn this around. 5 is less than or equal to time. And then here we're going to say, which is less than or equal to 10. Okay, so see how I've used 2 comparison operators in here? Now we're going to return true or false, right? Let me read this again. Only return true if all of these conditions apply. All right, cool. So we can do this. Return, we're going to say condition 1, and then condition 2 is just already a Boolean that's on break. So we want to say and on break and condition 3. And the reason I'm using and is because all of these have to be true in order for our function to return true. That's how it should work. So and is a good use here because it will only return true if all of them are true, right? Okay, let's run this and see what happens. Hopefully I got it. I freaking failed. That's okay. Well, look at what happened. So it looks like I'm passing 2, but let's see. Okay, so our bartender is not on break and the time is 10. So I must have read this no later than 10. I must have read that part wrong. Oh yeah, we want time to be less than or equal to 10, not greater than. No, it is less than. Less than 10? Let me read it one more time. The time is at least 5. Okay, so it can be 5, but not less than 5. But no later than 10. Let me think about it. 5 is less than or equal to 10. Okay, time. That makes sense. And the time is less than, it cannot be equal to 10? No later than 10? Yeah, no, I'm still failing that. Okay, let me think. Let's check our other conditions. Customer age is greater than or equal to 21. That should be fine. Let's see if it's working on all our customer ages. We get false here? Nice. Okay, we're gonna look at these and we're gonna figure it out. Customer age 22, that should be fine. On break, false. So if they're on break, they can't give beer, right? Yeah, it looks like I'm returning false when I should be returning true. And I think it's because of this on break thing. I think I was thinking about it flip-flopped. So because this is a Boolean, if they're on break, they can't give anything. So we wanna make sure that they're not on break. That should work, and not on break. See, that even sounds better when you say it. Let's run it and see what happens. Okay, cool. We passed, but we still have to pass the submit test cases. Yes, got him. Freaking got him. We got him. Good job, we finished chapter 7. Hey, welcome to chapter 8. We're gonna be talking about loops, and you should be pretty excited for this because as far as I'm concerned, once you've learned if statements and loops and all the cool stuff that we talked about before those topics, like Booleans, all that stuff, once you've made it to the end of this chapter, I believe that you could pretty much code anything. So if you wanted to go out on your own and code a little project, I think you could. However, you should stick around for the following chapters because it's gonna make coding that project a little easier, but I just want you to feel good about making it this far, because after loops, you're pretty much a bona fide programmer. You could code anything. All right, so what are loops? Loops are something that we use in coding when we want to do the same job multiple times, and I'm gonna show you what I mean. See here how we're printing 0 through 9? Well, if we wanted to print the numbers 0 through 9, we could do it like a savage and print every single number like this. Like this is gonna work. See? 0, 1, 2, 3, 4, whatever, all the way to 9. But there's a better way to do that, and that's with a loop. So let me show you my loop. This loop is gonna do the exact same thing, but it's a little nicer and a little more civilized. So, boop, see? It's exactly the same. So this is a loop, and I'm gonna pull up a diagram so we can talk about the syntax of loops and whatnot. I'm gonna show you my little diagram, and we'll talk about the anatomy of a for loop. So this is literally just a screenshot from the for loop we just looked at in the code. Now, let's go over the anatomy. So I've got some things kind of highlighted here. Let's start with this I variable. In Python, when you want to do a loop, the most simple type of loop to do is this range loop, where we're just doing a loop through some numbers from, like here, 0 to 10. Now, when you have this I variable, you're actually declaring I in the loop, and Python is going to set it to the first number that you're giving to this range function. This might be a little overwhelming, but you'll get it. I promise. It's super easy. Range is sort of like an inbuilt function in Python. So it takes some parameters, right? Or right now, some arguments. So this first number is going to be where our loop starts. And this next number is going to be the number after where our loop ends. But don't worry about that. We'll talk about that too. So when you declare I, Python is going to set it to 0. Yeah, it's assigned the value of 0 at the start of the loop. Each execution of the loop, Python will increment I by 1. So in the next loop, it'll be 1, right? And the loop will stop before I equals 10. Now, the way I just said that should kind of like spark off in your head, I guess, a little bit. This is a conditional. So the conditional for this loop is that as long as I is greater than or equal to 0 and less than 10, we're going to do this code right here. So notice we have an indentation again. This indentation into our for loop is where we're going to write the code that we want to keep happening. So this is kind of how it works. We start I at 0, we start the loop, we're going to print I, which is 0, right? Once all the code is done in this indentation in the for loop, then Python is going to increment I by 1, so I will become 1 and the loop will start again. So this is going to pop off 10 times. It's going to loop 10 times because we're going from 0 to 10, right? Okay, so now that we've seen the syntax or the anatomy of a for loop in Python, let's look at the output and break it down a little bit. Okay, so here is our code that we just looked at, right? And here's the output. 0, 1, 2, 3, all the way to 9. So like I said, range is a function that is built into Python and it takes 3 parameters. Right here, we're only giving it 2, right? We've got this one and this one. So some of these parameters are optional. They're defaulted. Remember when we learned about default, when we learned about functions? Okay, let's talk about all the different parameters that you could give range. The first parameter is the starting value, which is this 0 here. It's not required, so if you don't give it, the default will be 0. And it's inclusive, which means that I will start at the value of 0. Now the second value in purple, which is this one here, the 10, this is the ending value. This one is required. You have to tell Python how many times you want it to loop. And it is not inclusive, so I will never be equal to 10, right? Remember we talked about the conditional? For as long as I is greater than or equal to 0 and less than 10, we're going to print I. That's why you never see a 10. You only ever see a 9 because it's going to stop before I becomes 10. So that means that the ending value is not inclusive, right? Now the last one is the step. We don't have a step here, so you know that it's a default or it's an optional one, and the default is 1. The step just means by how many numbers or values do you want Python to step through the loop. So it's always going to default to 1. So if we're looping through the range of numbers 0 to 10, the first I is going to be 0, the second I is going to be 1, and the third one's going to be 2, right? If I were to change this step, and let's say I added the number 2 here, where we called it, then it would be different, right? It would be 0 the first time, and then it would step by 2. So it would do this. So the next time I would be 2. So that's basically how a for loop works. I don't want you to get too overwhelmed because we're going to do a lot of practice. So let's go to our first assignment. So for this assignment, all we have to do is fix our print numbers function so it prints the numbers 0 to 99. All right, so this is our for loop. It looks exactly like the one I wrote in my little coding thing that I showed you. We just have to add the range, right? And we have to add our variable I. So we're going to say for I, let me pull this out like this. For I in range, and our range right now, you might put 0 to 99 as your first thought, but actually let's see what it does when we do 0 to 100, because remember the second parameter, the ending value, is not inclusive. Okay, so that's our for loop. We got to make sure we have our colon here, and now we're going to print I. So let's run this and make sure it's doing what we think. Okay, go to the bottom. Nice. See how we got 99? We didn't get 100, right? Because we're not including 100. We're printing 99 values, we're printing 100 values, 0 to 99, and leaving out 100. All right, let's submit this and see what happens. Yay, nice. Okay, good job. Okay, we're gonna practice the same loop one more time, except this time we're gonna print the values from 0 to 199. So, same thing, ready? We don't have anything to start with at first, but here we go. For, remember we have to set a variable, for I in range. Range is our function. Our starting value we want to be 0. Our ending value, again, you might think it's going to be 199, but remember that the ending value that you give to range, the function, is exclusive, not inclusive like the starting value. So if we want to print 0 through 199, we're actually going to print, or we're going to put 200 here. And then just to show you, remember how we talked about the step parameter, the third parameter? We can just put a 1 here. It'll work even if you don't put anything because it defaults to 1, remember? Okay. Now, let's print I, and this should be good. Okay. Let's run it. Nice, looking good. What do we got? 199 at the very end. Cool. Let's submit it. I think we got it. Nice, cool. We're gonna do one more loops practice. So for this last practice question on the loops, for this assignment, we want our for loop to print from starting at 5 to the end value, right? So we're just actually going to change this right here to a 5, because that's our starting value. Now, if I save this and run it, we should be good. Okay, here we go. Okay, so it looks like for our first test, we're printing to 15. So we start at 5 and we get to 15. Nice. 5 to 5. This is a good test. This is a good example of a test that we may not have thought about and could have tripped us up, perhaps, but it looks like we got it. And then we got 5 to 10. Looks like it's all good. So let's submit. Nice. Okay, we've done some loop practice. Next, we're going to talk about more loops, and we're going to talk about white space as well. So I'll see you over there. Let's do a few more review questions about loops. So this first one, why would you want to use a loop? Is it to do the same thing over and over without writing the same code? Like a savage? Perhaps. Is it because the computer understands loops better than repetitive code? No. Is it because loops speed up your app? It's definitely not that. It's this first one for sure, right? Remember how we were printing all the numbers from 0 to 9 to the console with like 10 print statements? That's savage. We don't want to do that. We're civilized coders now. Okay, next. Why does the code on the left print 0 to 999 and not 0 to 1,000? So we see that our starting value is 0 and our ending value is 1,000, but remember that the ending value is exclusive. We're not going to include that. I will never be 1,000. Well, I is less than or equal to 1,000. No, because print I only happens while I is less than and not equal to 1,000. That sounds right. Remember, we have a conditional that's keeping the loop looping, right? Because print I only happens while I is greater than or equal to 1,000. Heck no. Our loop would probably run forever. Because print I only happens while I is greater than not equal to 1,000. It's going to be this second one, right? Nice. Oh, cool. We got an achievement. Okay. Now let's do this white space question real quick. It is blank to indent the body of a traditional for loop in Python. It's required. So remember when we talked about if statements in the last chapter, the code that you want to execute related to your if statement has to be indented at least once under that if statement, and that makes it an if block, right? So everything that's indented at least once under our for loop is going to be our for loop block. So it is required in Python. That's a Python thing. Nice. Okay, cool. Next, we're going to talk more about range. Okay, so I showed you the range built-in function in Python a little bit, but we're going to go into it a little more in this section. So let's jump into the assignment. For this assignment, we want to fix the for loop in the countdown function so it prints the numbers counting down from start, but not including the end in order. So remember how we talked about step? Well, we haven't really used it in our assignments yet, or we haven't had to. Now we're going to have to. And the cool thing about step is that you can actually use a negative number. So if I give this for loop a negative step, like -1, then it's actually going to step backwards from the starting number. But because of that, you have to make sure that your start value actually makes sense. I don't know how many freaking times I've had this set to 0, but had a negative step value and was confused why the code wasn't working. So let me show you what that looks like when you don't think about your starting value enough. This will let me. What's going on? There we go. Okay, we're going to run it. Nice. It didn't do anything. So we're supposed to be printing numbers from 10 to 1. So starting at 10 down to 1, right? But our I is starting at 0. So since our end is 1 and our starting is 0, we're not going to print anything, right? The loop is not going to happen because it's already, basically the rules that you've given it have already been satisfied. So it's not going to run it. So let's try it with 10 just to check it out. Nice. See how we got 10, 9, 8? That's because our step value is negative. We're starting at 10. So we're stepping by -1 each time till we get to 1. So that's all that is. It basically just, having the step value be negative like that is nice because it basically just reverses the direction that you want to go in for your loop. So let's actually fix this. We're going to put start back. And let's run it. Nice. So we got the 10 again, right? This one's working. 15 to 12. Perfect. I think we can submit this. Oh, cool. We got that. All right. So for the next 2 sections, we're going to be doing 2 little games that are going to involve our for loops. I'll see you there. This is going to be our first sum game at the end of chapter 8. So let's jump into the assignment. For this assignment, we want to fix our function so that instead of adding 1 to the total at each iteration or each execution of the loop, we should be adding I instead. So if we were to print this, or if we were to run this right now, where we're adding 1 to the total every time. Let's actually print it so it's a little more obvious. I'm going to say print total. Do a little debugging. Okay, so see how when we run it, we're printing 1, 2, 3, 4, 5, because we're starting at 0 and the end is likely 6, right? So instead of that, we're going to add I instead. Also, I want to point out, remember when we learned in chapter 6 about in-place operators? Well, that's what this is right here. So remember, if we expand this out, it looks like total equals total plus 1, right? So that's our in-place operator again. All right, let's bring that back. We're going to change this to I, and let's see what happens. So now we're getting 0, 1, 3, 6, 10. And it looks like we're passing because it was expecting 10 and we gave it 10 at the very end. So now we're starting at 0. Then I becomes 1, so we add a 1 to 0, right? And get 1. Then on the next iteration or the next execution of the loop, I is 2, so we're adding 1 plus 2, and that's why we get 3. Kind of see what's happening? So now that we've fixed that, let's try to submit it. Oh, you know what? First, we got to take our print statement out. Oh, just kidding. That's a lie, because we actually are doing the unit test type assignment style type. So we don't have to worry about the prints. We can leave them actually. All right, let's submit this. Cool, nice job. Let's go on to the next one. For this one, it's gonna be super similar to the last one, except for our sum of odd numbers function, instead of adding just I, we only wanna add I if I is a odd number. So there's probably a couple of ways that we could do this. But I think the easiest way to do it is to make sure that I is always an odd number. Another way that you could possibly do this is like using if statements to check for if I is an odd number. As in, we would keep the for loop the same and just only add I to the total if I was odd. But it's a little toxic doing it that way, so we're gonna do it the easy way. We're just gonna change our for loop so that I is always an odd number. So if we want to do that, if we want I to be odd, what's the first thing we should think about? First of all, 0 is not an odd number, right? So let's take this out. We're going to start at 1. Now, we're not going to touch end. Let's keep that the same because that's part of our solution here, our problem statement. But let's change the step. So if we're starting at 1 and we only want odd numbers, then we probably want to step by 2, right? And before we do anything else, let's add some print statements so we can make sure that this is actually working. I'm going to say print, we'll use an F string, and I'm going to say I equals squiggly bracket, I, and then let's do another one here for the total and make sure that this is doing what we think it's doing. Print F string total. We're gonna get our squiggle mabobs in there. Nice. Okay, let's run it. Okay, so we were expecting 4 and we passed with a 4, but let's see what's happening. I is 1, total is 1. I is 3, total is 4. Okay, so this is looking good so far, but since our end is 4, it's not really enough data points for me to trust that we actually did that the right way. So let's look at this one where we get up to 9. Okay, when I is 3, total becomes 4 because we're adding, right? And when I is 5, it becomes 9. So this is good. I think we have enough data points in our data set to trust that we did this well. So let's submit it. Yay, good job. So that's the end of the loops chapter. And next, we're going to be talking about lists. So yeah, see you over there. Welcome to chapter 9, where we're going to be talking about lists, which are the first data structure that we've encountered learning Python. So when I say data structure, I'm talking about constructs in our code which we use to store data and which make it easy for us to access those data points later on. So lists are one of those. There's a couple different types of data structures, but we don't have to worry about them yet. The only thing I'm going to point out is that you'll hear in coding the word list and the word array used interchangeably. That's because lists in Python are the same data structure in other languages, but in those languages it's usually called an array. Now, I don't want you to get confused because Python does technically have an array type data structure and they're very similar to lists, but I will explain their difference in a second. So what is a list? Well, I have some code to show you. A list is basically just a list of items. It's that simple. So pretend we're coding our game, right? Our Fantasy Quest game. And we have players and they have an inventory, right? Well, a list is a great way to handle a player inventory in a game because we can list items in that inventory, right? In Python, we can have different types of values in our list. So I'm going to run this code. It's just going to print our player inventory variable, which is set to the value of this list, which is all the items in our player's inventory. Before I run it, I want you to notice that between each item, we have a little comma. That's just differentiating them for Python. We also are using square brackets, or brackies as I like to call them, but that's the basic syntax for a list. Now, I'm gonna run this so you can see our list printed to the console. Boom. Just like that. Now you can see that most of these are strings, string types, and then we have this one numeric type, right? We could take this and change it into a string type and it would still be fine. With lists in Python, you can have different types of data types. You could even have a list full of other lists, but we won't get into that because it looks a little toxic. Okay, so let's change this to 200 gold. And we can do the same thing, run it again. Nice. Now we just have a list full of a bunch of strings, which are our players' items in their inventory. So now that you've seen a list in Python, let's go to our assignment. So for this assignment, all we have to do is finish our get inventory function. We're going to add a short sword to the end of the list. A short sword, it's just going to be a string, one of the items in our player's inventory. So all we have to do is literally just add it right here. We want to make sure that we put a comma and we'll add short sword. Hopefully I did the spelling right? Yeah, nice. Okay, let's run this. Cool. So it's kind of like our player picked up another item in the world, right? And we just put it in their inventory for them. Let's submit. Cool. Okay, we're going to do the next assignment as well because it's just a couple of questions. Now, you can see here that when we create a list in Python, we can put each item in the list on a separate line. And what that does is just make it super easy to read. So since I can't run this over here, let's go back to my code and we'll do the exact same thing. So to make this nice and easy to read, we're going to put each item on its own line. starting with 200 gold. See, notice how I left the bracky up here. That's pretty standard. Boop, boop. Just like the first bracky, we're gonna put the last one down as well. Nice. So let's save this and we'll run it again just so I can show you that Python doesn't care that we've put each of them on a separate line. It's not gonna break the syntax and we're not gonna get an error or anything. Nice. So this might not be that useful for a small list like our player inventory right now, but imagine we had a player inventory that had hundreds of items in it in our code. This is a lot easier to read now that we've given each item a single line. All right, let's go back to our question. When would you declare a list on multiple lines? When there are only a few items, when there are many items and it's hard to read them all in one line, when the array or list contains strings instead of numbers. No, it's gonna be this second one. Yeah. Nice, good job. I think we have another question. Which types can be stored in a list? In Python, we can store multiple different types of values in the same list. So I'm gonna put all of them. Now I'm gonna stop here and we'll talk about arrays real quick. So in other languages that are not statically typed, remember when we talked about static versus dynamic typing in languages, you would only be able to put the same type of item in an array, which is what they're normally called in other languages, or that language will give you an error, right? So like this flower type's list over here has a bunch of strings in it. Now in another language, if I were to put like an int or some other type as another item, we would get an error. So Python lists don't care, but Python arrays will. If you use an array, which looks exactly like this, and you try to put different values or different types in it, then Python will get mad at you for that. Now, we don't have to worry about arrays beyond that. So when I say it's gonna look a lot like this, what I really mean is they're gonna be declared differently because there's gotta be some way that we can tell the difference between a list and an array in Python. So don't worry about that too much, but I just wanna point that out since we do have arrays in Python. So we're gonna say all of them. Did I do that already? Yeah, we did. Okay, cool. Okay, in the next section, we're gonna be talking about indexing. Okay, so now we're gonna be talking about counting in Python, but really we're gonna be talking about indexing. So you might be wondering, how do we access a single item in our list, right? Because we talked about how lists are a type of data structure, and data structures store data for us and make the pieces of data, the items, easy to access, right? So how do we actually do that? Well, let me show you. I got some more code. All right, so remember we had our player inventory, right? Let's say that our player goes and spends money on an item. So we want to update this item in their inventory, the 200 gold. Well, how would we even access that thing in the first place? We're going to use indexing. So I'm gonna run this and then I'll explain to you what's happening. Okay, so you can see we've got our inventory being listed and then we have gold right there, 200 gold. So how am I printing the gold? If you look at my code, let's start where we're printing gold because that's where we're interested in, right? This is our little F string. You can see that there's player gold, the variable in here. So let's go find that. Player gold is right here and it's set to this weird thing we've never seen before, really. Player inventory, square bracket 0. So this is indexing. Indexing is basically using each item's place in the list to refer to it or find it in our list. Let me show you what I mean. Okay, so here is the code that we just ran, right? When we're talking about indexing, in order to access a specific piece of data in our list, we use indexes. And when I say indexes, I'm talking about the position in the list that data exists in. So in coding, in most coding languages, indexing into data structures like lists or arrays begins at 0. There are some languages that aren't like that. I think Lua is one, will start at 1. But for the most part, they're going to start at 0. The first item in our list is not going to be at index 1. It's going to be at index 0. Don't let that trip you up. But if it does, it's okay because it's kind of weird. And I've tripped over that myself. So what is the next item? The next item is going to be index 1. Iron breastplate is at index 1. And then, potion of healing's at 2, etc. In our code, when I'm creating this variable player gold, I'm setting it to the value of player inventory at index 0. I'm basically saying that player gold is pointing to this item in the player inventory list, right? That's where this bracket with the 0 comes in. If I wanted to get, let's say, the potion of healing, all I would have to do is change this 0 here in, that is not clear. Change, here we go, this 0 into a 2. And I could get the potion of healing. So that's what indexing is. So now that we've seen indexing, let's go back and do our our assignment on this one, which is just some questions. Which index refers to the second item in a list? We don't even have to look at the list because we know that the first item in the list is always at index 0. So what is the second item? It's going to be index 1. Nice. Okay, so for this next assignment, let's just, let me pull this down and let's look at what we got. We want to allow our players to access items in their inventories, right? So we're going to fix our get leather scraps function by changing the value of item index, which is right here, to the index in the inventory list that holds the value leather scraps, right? Because that's what we want to get for our player. So right now, item index is set to 0. So I bet you if we run this, we're going to be grabbing the healing potion, right? Boom. See, we failed that because we were expecting leather scraps, but got the healing potion. Let's change this. Leather scraps is the second item in the list. So we're going to change this to 1. Okay, let's run it. Nice. Let's submit it and see what happens. Cool. So it just ran the same thing twice. Nice. Okay, that's it for this part. Now that we've learned about lists, let's talk about their length. When you are wondering what the length of a list is, which you're going to find yourself doing a lot as you program, you're actually just asking how many items are in it, right? Because the length is equal to the number of items. So if we were wondering this about our list here that we're getting as this inventory parameter, all we would have to do to find out is use the length or len built-in function in Python, and I'll show you what that looks like. I'm going to make this variable. It's called length. And I'm going to set it to len, the function, and we're going to give len inventory, which is our list that's coming in as a parameter. Now, let's print the length so we can see. Let's use an F string to print our length. And we're going to put the word length in here so that it's super obvious in our output. So squiggle mabob, length. Nice. Okay, let's run it and we'll see what happens. Cool. So if you see down here, our inventory parameter, this input here, has 4 items in it, so the length is 4, right? Now, I want to point something out to you because this is going to trip you up. Even after I point it out to you, it's going to trip you up. It's just natural. It's part of being a programmer. Everyone gets tripped up by this. When we're talking about the length of a list, remember that the index into the list starts at 0. So the first item in the list is at index 0, right? What tends to happen and what tends to get confusing about this is that sometimes you'll find yourself confusing the length of the list with the last index into it. So if our list has 4 items in it, you might be tempted to say that the last index is 4. So if you were trying to get the longsword out of your inventory list, you might put, inventory bracket 4, and Python will yell at you. So let me show you what that looks like, just because I want to get you ready for the big scary world of programming where this is definitely going to happen to you. Okay, let's say longsword. We're going to make a variable, and we're going to set it to inventory 4. Because the length is 4, right? Let's see what happens. Oh, yeah, we're gonna get an error. Cool, so look here, we have literally an index error. So Python has a specific error for this issue. It's basically telling us index 4 doesn't exist in your list. You're trying to access a value that doesn't exist. So just remember that when we're talking about the length and the last index, they're going to be different, and that's because the first index is 0. So the actual value, the actual index of longsword in our list, at least in this last example when we print the test cases, is going to be 3. Now I'm going to prove that to you right here. Actually, let's put a new print statement in. We're going to say print. We'll put an F string and we'll say, let's call it index 3. And then squiggle mabob, we'll put our longsword. Okay, let's run it. Uh-oh. Oh, did I not? Oh, because we don't have that many items. Okay, but we can fix this. We can actually fix this. So some of the test cases, right, don't even have 3 items. So we're still getting that error for these other test cases. But we can fix this. Watch. You're going to see this a lot too. When you want to get the last item in your list, another way that you can get the index is you can use the list's length and then subtract 1 from it. So just like with our print, remember back when we started this course, we talked about how you can do evaluations in this parentheses of print. Well, you can also do expressions and evaluations of things inside these brackets for our index. So if I put length minus 1, it's going to get our last value in our list because, let's say for the last one, we have 4 items, but the last item is at index 3, right? So let's run it. Nice. Okay, so when we have 1 item, the last item is the potion, right? Ignore the 3 for that one. Let's just jump down to our case that we were trying to do this for. Okay, so we got our 4 items. The length is 4, and our index 3 is longsword. Okay, that was a very rough way to show you the bug that you're probably definitely going to run into as you use more lists. Okay, so let's do this actual assignment. Oh, perfect. It's actually perfect. For this assignment, we want to complete the getLastIndex function so it returns the length of the inventory list minus 1. So we're actually sort of already doing this, but we're going to return right here. I'm going to clean all this up, don't worry. Check it out. Let's get all of this out. We're going to do return length minus 1, just like we used in the brackets. Oops. Right here. So now I'm just going to delete this line and let's try to run it. Let's see if I'm done bumbling around. Cool, we passed all these, so let's submit. Cool, nice. Okay, if you've made it this far, you're probably wondering, TrashPuppy, I thought we were going to change the amount of gold our player had. Well, we are ready for that now, so let's go back to the code and I'll show you how to do that. We're going to update our list, and it's super easy. All we have to do is use our index into player inventory. If you remember, 0 is going to be our gold, right? And we're going to just use an equal sign. We're setting the value at this place in the list to a new value. Let's say they spent 50 gold. We're going to change this to 150 gold. Now, let's print it and see what happens. Nice. Okay, so you can see in our little printout that it actually changed the value in our list, right? So let's go to the assignment. For this assignment, all we have to do is update our little smelt ore function because our player is smelting the iron ore that's in their inventory. So we want to turn that iron ore into an iron bar. We're not just going to do it right here though. We're not just going to be a savage and just hard code it right here into the list. Let's do it with indexes, like a civilized person. All right, so I'm going to leave that print statement and I'm going to say inventory, and the index we want is going to be 1, and we're just going to set it equal to our new value, which is iron bar. And then we can actually print again just to prove to ourselves that we actually changed it. You know what? I'm just going to grab that print statement. Oops. Okay. Ah, bim. Cool. Let's run it, see what happens. Okay, looks like they have an iron bar now. Oh, maybe I messed up the outputs a little bit, but that's okay. We had an iron ore and now we have an iron bar. Okay, so let's submit it. Hopefully my little mess up doesn't ruin it. I don't think it will though. Okay, nope, we ruined it. So let's fix it. Let's see what happened. I think it said we were a few characters off. So I think I'm just going to put this back. See what happens. Oh, yeah, I did ruin it. So that's my bad. But good job. Now we know how to update an item. Okay, so let's pretend that our player in our Fantasy Quest game has picked up an item and we need to add it to their inventory. Well, Python has an inbuilt function for this, which is also called a method, that kind of comes with the list type of data structure, the list data structure type. Data structures often in programming languages come with their own methods, and basically all that means is they have functions attached to them that come built in with Python that we can use to manipulate them in different ways. So with lists, we have something called the append method, and it looks like this. A method is just a function, but it's sort of attached to another code structure like our data structure list here. So we're going to pretend, so append is a method, which is basically just a function that is attached to our list data structure type. So we can pretend, no, we're not even pretending, it's just true. These parentheses here that are at the end of the append keyword or method, these are just like where we would give a function arguments, right? So if we had, just real quick, as an example, if we had a function called append, we would give arguments here, right? That's what this is. So whatever we want to append to our list or put at the end or add to our list, we put into these parentheses. So let's say that our player picked up a ring of power. We want to add it to their inventory, so we're just going to use the append method and put ring of power as the argument. All right, let's see what happens. Cool. So you can see up here, we've got our 4 items that we had before. And then down here in our print statement, we've got the ring of power at the very end. It's super easy, right? Let's try to do the assignment. So this assignment is going to include a for loop. Remember, we learned about for loops in the last chapter. Super easy. For this assignment, we're going to generate a unique ID for each player in our game. And we're going to do that basically by incrementing I and putting that into our list of player IDs for this loop. So right here, you see that we have a variable as the second parameter to range, or the second argument. Remember, our second argument is going to be the ending value. Our loop is going to go from 0 to our number of users. And for each value of I, we're going to place that value into our player IDs list. Okay, so that's going to look like this. We're going to take our list here, and we're going to use append, and we're just going to put I right in there. Oops. Okay, let's run this and see what happens. Cool. So you can see we're starting from 0, we're going all the way to 4, and our player IDs, which we're returning here, has all of the numbers, right? Let's submit this and see if we pass. Nice, good job. Okay, so we're going to talk about the opposite of append, and that's pop. Pop is another method that's built into Python, but instead of adding a value to the end of our list, it's actually going to pop a value off. So the last value on our list is going to pop off. Remember how we talked about how append is a method and methods are kind of like functions? This is kind of similar. Let's go to our code. I want to point out something specific though. If you remember from when we learned about functions, our functions return things, right? We've been doing a lot of that actually. So pop will actually return us something. This thing lets me type, there we go. Pop will actually return a value to us when we call it. So I'm going to put pop here. We don't have to give it anything. And I'm going to go to the beginning of this line and I'm going to say, let's say last value. Let's call it item. Last item equals player inventory.pop. Now, instead of printing the inventory, let's add another print statement. We're going to print f string popped value. And we're going to use our squiggle mabobs and we'll put last item. So this will show you how pop is returning the last item that it pops off into our variable last item. All right, let's run it. Sweet. So inventory, there it is. You can see that we don't have shield anymore. It was on the end here, but our popped value is shield. So that's kind of cool, right? now you know that methods can also return just like a regular function. So there's really not a difference between a function and a method, except that the method is a function attached to another sort of coding construct. All right, let's do this assignment. Okay, so for this assignment, let's pretend that our player is selling items out of their inventory. So we're gonna use pop, and I wanna point out, we have a for loop here. So basically the idea of the question is that they're selling multiple items, one after the other, out of their inventory until their inventory is empty, right? So we're using a for loop so that we can pop an item off of our list. And remember, for loops, we're gonna use that for when we wanna repeat code. So instead of just like popping off an item over and over again, like writing that code over and over, we're just gonna put it in a for loop and have our for loop do it for us. Now, I want you to notice real quick before we start, we're still using the range, but now we're using the length of the inventory list as our value, as our ending value for range. So the last value that I will be is actually going to be the length of our inventory list. So I want you to notice that we're using the length of the inventory as the last item or the last number in our range for loop. All that means is that we're going to remember the last value in our for loop is exclusive. So if our inventory has 4 values and we're doing a for loop from 0 to 4, the last thing that I will be set to is 3. So we're never going to be outside of our list, because remember when we talked about the length of the list? The length of the list is 4 values, but the last index is 3. So because range excludes, or is like the last value in our range is exclusive, we don't have to worry about that, because I will only equal up to 3 in the case that our list is 4 items. Okay, so now that we've covered that, what are we gonna do to fix this? Right here, I'm gonna delete this, and we're just going to make an item variable, and we're going to set it to inventory.pop. Now, what this is gonna do is whatever item we pop out of the inventory list is gonna be saved in here, and like I showed in my code, in our little example, the inventory is actually going to change, right? We're actually removing those items out. So let's run this and see if it works. Okay, this is a lot of output, so let's go through it. Our last item in the first test is this tattered cloth. Here, that'll make it a little easier. So you can see that we sold the tattered cloth, leather scraps, we sold leather scraps. Let's look at the first item in our inventory, healing potion, to make sure that we made it to the end of the inventory, right? So when healing potion is the last thing in our inventory, we pop it off, we sell it, and then our inventory is empty. So this looks good. I'm gonna submit it. Nice, good job. Okay, we're gonna talk about counting items in a list, and we're gonna jump right into the assignment. For this, I want you to imagine that our player is selling items out of their inventory, right? So for this assignment, all we have to do is sell those items out of the inventory and make sure that they're actually sold. So there's a couple of concepts that we're going to combine from the course so far in this assignment. We're gonna be doing the for loop. We're gonna be indexing into our array, but we're also gonna be using if statements like we learned in the last chapter, and we're gonna be using Boolean comparisons as well. So it might seem like a lot, but we can totally do it. All right, here we go. So for this assignment, we're going to finish this get item count function, and in our for loop right here, which is already partially written for us, we're going to check if any items in the player's inventory are potion, bread, or short sword. So as you can imagine, a player can have multiple of the same items in their inventory. So we're basically just going to count how many of those duplicate items they have, and we're going to return that, right? Okay, so let's do this. Notice here first that we are using the length of our items list in our for loop. So the first I in our for loop is going to be set to 0. And let's say our list has like 5 items in it. The last value of I is going to be 4. Remember, because our list has 5 values, but when we use this range function, the last value is exclusive, right? So let's pretend this is 0 and 5 for a 5-item list. The last value of I is going to be 4, which will also be the last index into our items list because the first index is 0, right? All right, let's see it work. So let's get rid of this pass. All we're going to do is use some if statements to check what the current value of the current item is. Now this is going to be kind of cool. You can use I to index into our list because since we're starting at 0 and we're ending at the last index, 4, those are all the indexes into our list, right? If our list is 5 items. So I'm going to create a variable. I'm going to call it, let's call it current item, because if we use I to index into the list, then the current item is going to change each iteration, right? Because I is going to change. So it's going to be items I. So on the first iteration, this is going to be item 0, so the first value, right? And then the last iteration will be, remember, if we have 4, it's going to be, or if we have 5 items, the last iteration, I is going to be 4, which is the last index. So that's kind of cool, right? You can use I to index into our list. And you're going to see that a lot as you do more programming. All right, so current item equals items I. Now we're going to check if that current item is potion, bread, or short sword. So we're going to need some if statements, right? And I'm going to use if, elif, and else. So if current item equals, let's start with potion. Whoa. We're going to do this. We're going to increment our potion, our potion count by 1. And we can use our in-place operator plus equals for that. Cool. Now, we're going to use elif and else because, like we learned in the last chapter, it's a lot easier to read because we're grouping up all of our different conditionals, but also we're preventing Python from having to execute multiple if statements, because that's kind of gross. It's toxic, right? We don't want to write a separate if statement for each condition because it's going to have to execute even when it doesn't have to. Whereas with our grouped up elif and else, if this first condition is met, the other ones will be skipped. All right, so for this one, if current item equals, we have bread next. Nice. We're going to put our little colon, indent in, and we're going to say bread count plus equals 1. Let me make that better. 1. All right. I'm going to use another elif. I'm going to say elif current item equals short sword. And increment short sword count by 1. Now, really quickly, I just want to point out, this has to be this little Boolean condition here. Let's say we want to make sure that the items that we're looking for definitely match this. So what I mean by that is, let's say we had this here. We didn't use an uppercase S. Python would not treat an item called short sword with an uppercase S. Did I just say? If we have a lowercase in our conditional, but we have uppercase items in our inventory, Python is not going to treat this condition as being met if we're coming across an uppercase short sword, right? Because they're not exactly the same. So make sure that these are exactly how they should be as they're listed over here in the problem. All right, now I'm going to have an else, and this is just going to happen in the case that the current item is none of these things. And we don't have to have this else here, but I'm going to have one just to help with debugging in case I get something wrong, right? So I'm actually going to print this. I'm going to say, this item is not something we care about. Boom. So we've incremented all our counts. Let's see if this is going to work. Cool. We're passing. It looks like in this second case, we had 2 items we don't care about. That's probably the buckler and the iron mace. This is looking good. Let's submit it. Nice. All right. That's it for that one. Up until now, we've been able to iterate over the items in our list by using indexing. but Python actually has a really simple syntax that'll allow us to do the same thing, but not with indexes. And I want to show you what I mean. So you're probably familiar with this player inventory list that we've been referring to and how we use the range and for and the index to get a specific item out of our list for each iteration of our loop, right? Now I'm just going to run this code so we can see it real easy, because we're going to compare it to the new way, the other no index syntax way of iterating over a list. Okay, boom. Now let me show you the new way. I'm going to grab this and I'm just going to pull it to the side so that we can see both syntaxes at the same time and kind of compare them. So over here, we have for I in range 0 to the length of the player's inventory, right? Whereas over here, this is the no index syntax of iterating over a list. Instead of using range and instead of making this I variable and setting that to a number in our range, we're actually just going to create this item variable, and Python will know that for each iteration of the loop, the current item is going to be whatever item comes next in the list. So let me show you what I mean. I've got another console here that I'm just going to do the same thing with. We're just pulling them side by side so we can compare them. So I'm going to run this code and it's going to do the exact same thing, or the output will be exactly the same. Nice. So with this new syntax, it's just a lot easier. We don't have to worry about the range or the length or which I is which or any of that. All we do is just say item, and Python will know to package that entire item into that variable. So we don't have to use the index of the current item at all. Okay, let me bring this over. Now we're going to go over the syntax a little bit more just to be sure that we got it. So this is the same code that we just ran. This is the no index syntax of iterating over our list in our for loop. So we have this item variable. We're declaring it in line here, and what Python is going to do is it's going to set it equal to the first item in our player inventory list. So basically item is literally going to equal player inventory bracket 0, right? Now, this here is our list, right? Player inventory. Python, when we use this syntax, Python knows to loop through all of the items in the list, so we don't have to give it a starting value, an ending value, or a step like we would with the range syntax that we have been using. And then if you remember, when we do a for loop, we have at least one indentation in. Whoops. We have at least one indentation in, and that's where the code that we want to run for this iteration is going to go, right? So that's pretty much the same. For each iteration, Python will set the value of item to the current value in the list. That's why when we print this, or when we run the code, you can see that it's printing the item itself right here, right? Okay, I hope that makes sense. Let's go try to do our assignment. So for this assignment, we're just going to answer a couple of questions. When should we use the no index syntax that we just learned? Is it when we want to write code that is harder to read? Probably not. When we don't need to know the index, just the value, that's a good choice. Or when the index starts at 0. No, it's going to be this one right here. We don't need to know the index. We don't need it to get the item out of the list. And also regarding this one, it's going to be a lot easier to read code like this that uses this new syntax. Okay, next question. Which method of writing for loops is considered more clean, assuming that both options work and do the same thing or get the same output? Is it going to be for item in items or for I in range 0 to length of items? It's going to be this first one, right? That's much easier to understand. Cool. Okay, for this section, we're just going to do this assignment to practice this new no index syntax. So for our assignment, we're going to iterate over this list of items to see if it includes an item called leather scraps. Now, you can see that we're given this found variable. You're going to see this a lot in programming. This is what you call a flag. And basically how we're going to use it is while we're going through the list, while we're iterating through it in our for loop, if we find the item, we're going to change this found variable to true. So it's flagging us, telling us that we did find the item. And because this function is only going to return true or false on whether or not the items contains leather scraps, we can just actually return that flag at the end. So the idea is that while we're iterating over the loop, if we don't find the leather scraps, then found will never be changed from false. And so we'll just be returning false at the end. Okay, so let's try to use our new syntax. Using the no index syntax, we're going to do our for loop right here. So we're going to say for item in items. Whoa. Now, for each iteration, we're just checking if the current item is the item that we want, which is the leather scrap. So if item equals leather scraps, remember to put a colon, then we're going to set our flag to true. There, that's all. We're going to run this and see what happens. Cool. So if we look at the output here, we can see that leather scraps is here, so we should be getting true. Nice. Nice, nice, nice. We're passing everything here. I also quickly just wanted to show you something, just to reinforce the if-else statements. If we put an else here, that's going to catch every other condition in which we don't see leather scraps, right? So basically everything else. So we can just put a print statement, like if we were trying to debug this, we could put a print statement that says, you know, this item is not leather scraps. Wow. Leather scraps. Maybe with a little sad face. Boom. Okay, now if we run that, it's going to print that every time we don't find leather scraps. Cool. Okay, let's submit this and see what happens. Yay, we got it. Nice. In this assignment, we're going to be practicing lists more and looping over them, as well as using indexes to get the values out of them in our for loops. Now, I know we just learned the no index syntax for looping over a list, but in this assignment, we're going to need indexes, and you'll see why. So we have two lists here. They're the same length, and that's because each list is filled with player levels from our game. So imagine it this way. We have a list of old levels of our players and then a list of new levels of our players, as if we're stopping to check the players' levels and we're just putting them into this new list. Now, what our assignment or what our for loop needs to do is compare the lists index by index to see if players have increased their level since the last time that we got their levels, right? So if that doesn't make sense, let's just show a little example. If we're looping through our list and we have this player here at index 0, 1, 2, their old level was 43 and their new level is 45. So since we last checked, they've increased by 2 levels, right? So that's basically what our for loop needs to do. Because both of these lists are the same length, we can use the same index to index into them and get their values. Now, the reason that we don't want to use a no index syntax, the easiest way for me to show you why we don't want to do that is to just try it out. So let's try to do it with the no index syntax that we just learned. If we say for level in old character levels, yeah, and then we want to do our condition here, right? It's gonna be something like if level is less than our new level. Well, where is this new level coming from? Where is this variable coming from? All that we have is this variable for the level in the old character levels list. If we use this no index syntax, we can't really, it's not easy to make a variable to represent the current level in our new list. So that's why we want to use indexes in our for loop like we have in this for loop that was already pre-written for us. So let's fill this out. Now, to make this easy on myself, I'm going to make 2 variables here. One is going to be called, oops, if I can type. One is going to be called old level. And I'm actually just going to set this to the value in old character levels, and I'll do that using the index. So the current index is I, right? Now I'm going to make another one that's going to be new level. And because our lists are the same length, we can actually use the index in the same way just into the new characters level. So now that I have those, that's going to make my comparison a lot easier because I've basically taken all of this kind of gross syntax and saved it into here so I don't have to do it again when I'm doing the conditional. Okay, so my question that I'm asking with my if statement is going to be if old level, and we want to see if it's less than the new level. If old level is less than the new level, then all we want to do is print the current index. Now I'm also going to add an else here so that we can sort of see what happens when the old level is not less than the new level. And that's just for me for like debugging in case my code that I'm writing right now doesn't make a lot of sense. It'll help me figure out if my conditions and my if statements are set up appropriately. So we're just going to print the player did not level up. All right, now I'm going to run this. Let's see how we do. Okay, so it looks like for the first 2 iterations, the player didn't level up, but here at index 2, they did. So if we look at our lists over here, we can compare them. This is 0, 1, and 2. And it looks like, yeah, their new level is 45 and their previous level was 43, so they leveled up. And then at the 3rd index, we got 54 and 53, so yep, that makes sense. And 7, so this is 3, 4, 5, 6, 7. We got 38 versus 34, so again, they leveled up. So this is looking good. I think we can submit it. Oh, let's see what happened. Oh, you know what's happening? This is one of those tests. This is one of those assignments where we don't have a unit test and it's our output that is being tested. So I'm actually going to take out this extra print statement that we put for the debugging because that's going to break our submission. Let's try it again. Nice. There we go. Got it. For this assignment, we're going to be solving a problem that's actually very common in coding and you'll see it all the time. And that's that we want to find the maximum value in a list of a bunch of values. So this problem is so common that Python has this little inbuilt function float where we can give it a negative inf to help us solve it. And basically what this is going to do is it's going to create the negative infinity value. So if that's not making sense, don't worry. I have a little diagram to explain how we're going to code this problem. Okay, so this is my little diagram, and let's go through it. So this right here, combat log, this is going to be our list that we're iterating through and trying to find the maximum value in. The idea is that combat log is full of a bunch of values that represent the damage that a player in our Fantasy Quest game has done to an enemy recently. And we want to report to the player what their highest damage dealt has been. So for example, this value here represents a time that they did 123 damage to an enemy, and we have it saved in this list. Now the idea is that, well, let's say it this way. So far while working with lists, we've been able to see all of the values in our lists, so we know what index they're at, blah, blah, blah. Before we could find the max in a list pretty easily because we could see them all. But now we're going to treat this more realistically. In this scenario, we don't necessarily know what the combat log looks like. It's not hard-coded into our code anywhere. So we're writing a function that takes a combat log from any player. It could have hundreds or thousands of items in it, and we have no idea what they are. So we have to go through that list, iterate through it, and find the maximum value. So when it's like this, when we're going in blind and we have no idea what all the values are, typically you'll see that you create a sort of flag variable like this one here, max damage dealt. Now, the first time you saw a flag was in a couple lessons back when we used a flag and set it from false to true if a certain thing was found in our list, right? This is going to be kind of similar, except we're not going to say, hey, I found the max damage value. We're actually going to set it every time we see a number that is higher than all of the numbers that we've seen before in the list. So basically, we're going to loop through combat log, and each time we see a value, we're going to do a comparison and ask the question, is this the highest value that I've seen so far in this list? If it is the highest value that we've seen so far, then we're going to overwrite the value of max damage dealt with that one so that it saves the highest value that we've seen. That way, at the end of our loop through the list, it's holding the value that was the highest, and we can report that back to the player, right? Okay, now that we get the basic idea, you might be wondering why we're using negative infinity as the first value of max damage dealt. So imagine this is our code, and this is where we're setting that. We're saying that when we create the variable max damage dealt, we're setting it to the value of -infinity. If you think about it, -infinity is the lowest possible number, right? So why are we doing that? What if, like, I think if it were me, I would probably, without knowing what I know already, want to set this to like 0 or something, right? Because theoretically, all the values in here are going to be at least higher than 0. So when we do the comparison, the first value will probably, or max damage dealt will probably be overwritten with the first value. But that's not always the case. So let's look at this first value. The first value in our combat log is -54. And that's because sometimes when you deal damage to an enemy, some enemies are able to reflect that damage back at you and not take damage at all, or they can absorb that damage if it's a certain type, and they can use it to pad their own health. So it's really like you're doing negative damage to them because you're really just giving them more health, right? Imagine if this entire combat log was full of negative values. If we tried to use max damage dealt and we started it with the value of 0, and we do this comparison, in the first iteration, then max damage dealt is never going to be reset because 0 is always going to be higher than a negative number. So to prevent bugs like this, which happen every once in a while, remember that this function we're going to be reusing for thousands of players. So it's likely that one of them is going to have a combat log full of all negative numbers, right? That could happen. So to prevent a bug like this, we use -infinity because nothing is smaller than -infinity, right? So let's set that back to -infinity. And that basically just guarantees that the first comparison that happens is going to replace max damage dealt. And so we're basically making sure that every value is being considered like it should be in our little condition during our for loop. Okay, now let's walk through an iteration. Let's walk through our code in our little pseudocode diagram thing here. So for the first iteration of our for loop, the first value is going to be -54, right? Now we're going to compare these. If -54 is larger than -infinity, then we're going to change the value of max damage dealt to -54 because that's the highest value that we've seen so far. That's the highest damage dealt in this list so far. All right, so that's changed. Now we're going to put, we're going to put this one back, and we're going to look at the next value. It's 617. So is 617 greater than -54? It is, right? So we're going to overwrite this with 617. That's the highest damage that we've seen so far. Okay, same thing. Next value in the next index is 123. Now 123 is less than 617, so max damage dealt is not going to be overwritten. So let's put that back. Next, we got 700. So 700, that's greater than 617, right? So like we did before, we're going to overwrite this variable. And now 700 is the highest damage that we've seen. All right, next one, also 700, not higher, so this isn't going to be overwritten. Nothing changes. And then the last value, 515. 515 is going to be lower, so also not going to overwrite max damage dealt. And by the end of our for loop, this variable is holding 700 as the maximum damage that we've seen in the list. So that's basically how our code is going to work. But let's actually go code that now. Okay, so we're here back at boot dev. I'm going to pull this out. And here's our little function. You can already see that max so far is set to -infinity. I'm going to change this to kind of mirror our diagram because it's not going to hurt anything. So we're going to call this max damage dealt. And I'm also going to do that with nums up here. Nums is like our combat log. All right. Now that those kind of match our diagram, let's do the rest of this. Okay, so we're going to say for damage in combat log. Now, for each damage that we iterate through, we're going to ask the question, if the damage is greater than our max damage dealt, then we're going to overwrite that variable, right? Max damage dealt equals, get a space in there, damage. Now, just for debugging, I'm going to add an else here so that just in case I wrote something wrong, I'm kind of seeing, I'm gonna write a print statement to show me how my conditional is working, right? Maybe it'll be popping off when I don't think it is. That's the idea. I'm just gonna put a little print statement here. This is not the highest damage we've seen. Oop. Make sure that we use double quotes because this little apostrophe is going to break Python because it's going to treat it as the closing quote. So make this a double quote. That's going to prevent that bug. All right. Now, once we're out of our for loop, we want to return the max damage dealt. Boop. Cool. Let's run it and see if this is working. Nice. So it looks like the maximum damage for this test in this input is 5, which we're getting. Nice. And then the max for this is 300. Cool. So we passed those 2 tests. And you can see here, this is that print statement that I made in the else block. The 2 times that the current damage was not higher than the max damage dealt. Now you might look at this and say, well, wait a second. 1 and 2 and 4 and 5 are all lower than 300. So wouldn't it be 4 times? But if you think about it, max damage dealt before our loop starts is negative infinity. Negative infinity is less than 1. And then 1 is going to be less than 2. So by here, max damage dealt is set to 2. Then we're comparing 2 to 300. So it gets set to 300, right? Now, once we're comparing 4 to 300 and 5 to 300, 300 is going to be the largest number, so it just stays. Max damage dealt stays set to 300. So these last 2 print statements are actually these last 2 cases, 4 and 5. All right, let's submit it and see if that's working. Nice, we got some confetti. Sweet. Okay, do you remember back in chapter 8, lesson 9, where we had that assignment where we had to go through a range of numbers, loop through the range of numbers, and if I, the index, was an odd number, we would add that to a total. Do you remember that? If you don't, that's okay, because you might be kind of weird if you did. But it's okay. I have it here for us. This is exactly the code that we wrote. If you remember, back then I said something along the lines of, if we want to increment total by just odd numbers, there's a couple of ways we can do that. But the easiest way would be to change the values that we're giving the range function. Let's run this code and see, make sure that it's working. How we ended up solving this is we changed the first value in our range to 1 and then the step value to 2. So I was only ever an odd number. So that's kind of a little bit of a cheat, right? But now we're gonna learn modulo, which is an operator that would make this same type of problem much easier. So let's go to odd.py, which is a little script that I wrote for this. Imagine that our list, instead of incrementing by I, imagine if we had a list like this and we wanted to increment the total only if the actual value in the list was an odd number. Now we can't really use range because we don't know what values are in our list, and we can't really write range in a way that's going to allow us to skip or start in certain places to only get odd numbers. Now we're going to have to actually loop through every single value, look at every single value, and decide whether or not it's an odd number. So don't look at this print statement. That's cheating. Let's try to think about how we might do this in a for loop. So if we were to write this right now, we would do something like for num in numbers. I'm going to put a little pseudocode here or comment to try and suss out what I might do. It's going to be something like if num is odd, then I want to increment total by the num. But how are we actually going to check if num is odd? Given what we know and have learned so far, there's not really an easy way. The only way that I've thought of is definitely kind of toxic, and I'll copy and paste what I was thinking in here for you to see, just so you can get an idea of how gross it is. So my best solution that I thought of was we could take the number and divide it by 2, and then we could floor by 2. And if you remember about floor is going to, if divide is going to give us a float, which it would, floor would chop off the float, right? And then you could see if there's any remainder between the two of them. Now that's gross. We don't want to do that. I'm not even sure it would work, honestly, because I haven't tried it. But that was my best approach at how we might do this problem if we didn't know about modulo yet. And now we know about modulo. So what is modulo? Let me show you now that we've gotten here. Modulo looks just like this. It's just a percent sign, and you're gonna put it between two values, and this is what it's going to do. Actually, let's make this one a 5, and we'll put 2 here. So modulo is kind of like dividing, except instead of actually dividing the two numbers, it's going to give us the remainder of their division. So what I mean by that is, let's say you have 5 modulo 2. The way you can think about this in sort of like a stepwise piecemeal type of way is, if you think 5 divided by 2, well, 2 goes into 5 twice because 2 times 2 is 4. The remainder of that, 5 divided by 2 is going to be 1, right? Because you can divide 2 evenly into 4, and then you're left over with 1. That's the idea of modulo. Instead of giving us the division of the two numbers, it's going to give us any remainder from their division. So if I clear the terminal and run this right now, I'll show you what I mean. This is odd.py, boop. Uh-oh. My indentation is wrong. Oh yeah, because I left this kind of like hanging thing. We can put a pass here. All right, let's try this now. Boom, see, you got a 1. So that's modulo. Now, how are we gonna use this to check if our value is an even number? It's kind of cool. If you take any number and you modulo it by 2, if it's an even number, then the result, the remainder is gonna be 0, right? So if I change 5 here to 6, we should get a 0 in the console. So I'm gonna clear again and run. Oops. I gotta save it first. Okay. We're gonna clear it and run. Boom. See, I got a 0. So we can use this to try to figure out if our current number in our for loop is an odd number. So I'm gonna ask a question. We're gonna use a conditional if statement. We're gonna say, I wanna make a variable called remainder just to make it easier for us. We're gonna say remainder equals num modulo 2. Now we're going to ask the question, if remainder is greater than 0, or this is even better, if the remainder does not equal 0, then we know that num is not an even number, right? Because we would have gotten 0 out of moduloing it with 2. So now we can increment the total right here. Total plus equals num. Now for debugging again, I'm going to add an else just to see if this is working on those cases where it is an even number. Print, we're going to do an f string, and we're going to say, I'm going to put my squiggle-mabobs, num is even. All right, let's see if what I've written is going to work. Okay, let's clear first. Boop. Okay. Ignore these little ones, but we got 54 is even, that's true. 298 is even, 2 is even, 10 is even, 8 is even. That's looking good. I think that's actually working. So that's how we would have done this before if we had modulo. So now that we kind of have an idea of how modulo works, how are we going to use it in this assignment that we have? So this assignment is actually going to be a lot similar to what we just did. The only difference is that when we come across an odd number in our for loop here, we're using range, but we're not going to mess with range at all. We're going to go through every number in our range. So whenever we come across an odd one, instead of incrementing a total, we're just going to add it to this odd numbers list. All right, so we're going to do the exact same thing. I'm going to make a variable remainder. That's for me just to make it easier. You don't have to. But remainder equals I modulo 2. Now I'm going to ask the question, if remainder does not equal 0, then I'm going to append it to odd numbers. Cool. All right, let's run this and see what's happening. Looks like we got this first one right. And the second one, nice. I'm gonna submit. Nice, cool. looking good. Look, even against this like crazy test here, I told you the test cases were gonna get crazy. So good job, we passed that one. In the next couple of sections, we're gonna be learning a couple of operations that we can do on lists, starting with slicing them. So in Python, slicing a list means that you take a list and create a new list that's filled with just specific values from the old one that you want. So for example, if I took this champions list and grabbed the first 3 values out of it, if I did that using slicing, then it would just create a new list with only those first 3 values in it. So let me show you the syntax a little bit. It's going to be very similar to when we learned about the range function. So if you look here, you can kind of see it, and I'm actually going to grab this and put it into a comment so it's super easy for us to see while we're writing the code. All right, so my example was I wanted the first 3 values out of champions, right? That's going to look like this. I'm going to create a variable called slice, and I'm going to set it to champions. And this is where I'm going to use the operator. So the operator is just this colon here. Now, if I put anything before the operator, that's going to be the start of my list. So if I wanted the first 3 values, I could put a 0, or if I left it blank, Python will just start it at the beginning of the list. But let's put a 0 for now as like a placeholder. Now, where do I want to stop? So I said the first 3 values, right? Well, that would mean that we wanted index 0, 1, and 2. So you might think that we would put a 2 here, but if I print this, let's use an F string so it's really easy to see in the output. I'm going to say slice. If I print this, it's probably not going to do what we think. Okay, so here's slice. See how it only grabbed the first 2? So just like in the range function, this second, you could call it a parameter. It's not really a parameter, but this second placeholder here is going to be exclusive. So it's going to go up into the number that we put, but not include it. So we're getting indexes 0 and 1, right? So if I want the first 3, I actually have to put 3 here. Now let's run it and see if that worked. Boom. Now we have the first 3 values out of champions. Now that we've seen how to use the first 2 values here, let's try to use it with a step. So I want to step by 2, but I have to be careful about what I choose as the ending value, because if we're going to step by 2, we have to make sure that we actually have enough values in our list. So let's do 5 here, and let's think about what it's going to do before we run it. So we're going to start at 0. So our little list that we're going to create with slice is going to include Thrundar. Then we're going to step by 2, so it should have Gondolfo in it. And then, since we're only going to 5 exclusive, 0, 1, 2, 3, 4, 5, our stopping value is Norwad. And since we're stepping, Norwad should be the last thing in there. So let's run it and see if that works. Nice. So it did. So that's how you would use that step functionality with the slicing operator into our list. So now that we've seen a little bit, let's try to do the assignment. For this assignment, we have a champions list that's coming in, and we want to create 3 different sub-lists or slices of that list and return them. So to make this easy on myself, I'm actually going to create 3 variables, and I'm going to call it, let's say, list, or how about sublist 1. So reading the directions, sublist 1 is going to be a slice of the champions list that starts with the 3rd champion and goes to the end of the list. So that's going to be champions, and then we want to use our brackeys with a slicing operator. We want to start with the 3rd champion and go to the end of the list. All right. So 0, 1, 2. Our 3rd champion is index 2. Now, if we want to go to the end of the list, we can just leave the slicing operator like this, and Python will know to include the rest all the way to the end. All right, so that's our first sublist. Let's get our second one in here. Whoops, sub-Luis. I can type, come on. Sublist 2. Sublist 2 is going to be a slice of champions that starts at the beginning of the list and ends with the 3rd champion from the end. So if you remember with range, we can use negative values to work backwards in a loop, right? So it's kind of like that with slicing too. So, oops, I forgot my equal sign. Let's do champions. My typing is atrocious. Okay, we got our bracky. We want to start at the very beginning of the list, right? So we can leave this part out. We'll put a little slicing operator. And then it says the third champion from the end inclusive. So you might want to put a -3 here, but this is not technically going to be true or technically going to work because remember, this is our ending value. And our ending value, our stop here is exclusive. So if we want to include the third value from the end, then we want to use a -2 here. I know it's a little weird. All right, let's write our last list. We got sublist. We got sublist 3. Set that to champions. I'm trying to watch my keyboard so I can friggin' type. The last sublist is going to be a slice of champions that only includes champions in even numbered indexes. So we're going to be using our slice, right? Or sorry, our step in the slicing operator. So we don't have to put anything at the beginning because we're going to start at the very beginning. Then we're going to go all the way to the end. So we don't have to put anything here. But if we want to only include even numbers, even indexes, then we're going to put a 2 in the step, right? Okay, hopefully this is working. Let's return everything. We want to do it in order. So sublist 1, sublist 2, whoops, and sublist 3. Okay, let's run this and see if this is going to work. Hopefully it does. Fingers crossed. Here we go. Cool, we actually passed. I'm mildly shocked, but that's okay. Let's submit it and see if the submit tests are going to work out for us. Yay, thank God. All right, now you know about slicing and the slicing operator. The next list operation we're going to be talking about is concatenation. Now, we haven't really talked about concatenation since we learned strings back in chapter 2. But if you remember from that, remember when we learned F strings and how F strings are way less toxic than string concatenation? Let me remind you what string concatenation looks like. So if we have a string and we set it to trash with a space, and then we have another string and we set it equal to, what else? Puppy. If we print the concatenation of these two, we will get, you know, a concatenated string. So let me show you. S1 plus S2. We're going to print that out. Oh, God. Whoa, what just happened? We're going to try to print that out like this. Here we go. TrashPuppy. When we say concatenate in programming, we really just mean squishing together, okay? You can just, for now, that's how you can think of concatenation. We're just taking the two things and we're squishing them together, okay? It doesn't have to be hard. We don't got to get complex about it. We're squishing them. So, with lists, you can actually do the same thing. And let me show you by doing the assignment. For this assignment, our game Fantasy Quest allows users to keep lists of their favorite items. Our job is to finish the concatenate favorites function. It takes 3 different parameters: the player's favorite weapons, their favorite armor, and their favorite items. And what we want to do is create a new list which combines all 3 of those parameters, which are each a list, and return that list that we created by concatenating them. Okay, so let's do this. I'm going to get rid of all this. We're going to make a variable here. I'm going to call it megalist. And literally all we're going to do is take favorite. Let's do I think it has to be a certain order. So favorite weapons first, plus favorite armor, plus favorite items. Boom. And then we just are going to return it. Return mega list. Okay, let's run. Looks like we passed. Now, I want you to notice something. We're concatenating these 2 lists, we're squishing them together, but really what we're doing is we're making sure that the items in both lists are all in this new list. So what Python is doing on the back end, or where we can't see how it's handling this code, is it's taking our 2 lists and really it's making a new list filled with all of the values from both of our lists. But each value is going to be in the same order. So if our first list was sword, dagger, and our second list is bracer's helmet, you're going to see that in the list that we created by concatenating, they're going to be in that order. It's going to be sword, dagger, bracer's helmet. So that's what's happening when we concatenate two lists. Super easy, right? I don't think we've submitted yet, so let's do that. Boom, nice, super easy. Okay, the last operation that we're going to learn on lists for now is deleting an item. The syntax is pretty easy, so I'm gonna show you by walking through the assignment. So for this assignment, in our fantasy quest game, players can go to strongholds and defeat bosses in them. If they defeat all the bosses in a stronghold, then that stronghold is completed for them. So we want to make a function that deletes certain bosses from, or certain strongholds from the player's map, and those strongholds are the strongholds that they've completed, right? So that their map now only includes the ones they haven't done yet. So this assignment has three basic parts, right? We're going to delete the first stronghold from the list. Then we're going to delete the last two strongholds from the list, and then we're going to return the new list. Now, when we delete items from a list, it's going to actually delete that item. We don't have to make a new value. We don't have to return something else. We're just going to delete things from strongholds and then return strongholds, the list, at the end. So this first part, we're going to say we want to delete the first item. All we have to say is delete strongholds. And we're going to use bracket and the comma or the colon again. So if it's the first two, we actually don't need a colon. We're going to just say 0. Did I say the first two? If we want to delete the first item, we just say bracket 0. Okay, now the second part. We want to delete the last two strongholds. So same thing, strongholds. We're going to put a bracket. Now, if we want to delete the last two, the notation is going to be sort of similar to when we learned about the slicing operator, our little colon. The first value that we put is going to be the start. So we're starting from the last two values. Then we can put the colon, and putting that here just tells Python that our ending value, we're leaving out the ending value, and that tells Python that we want to leave everything else. So that's how we're going to delete the last two items in strongholds. Now, the last part is just returning this new list. So now that we've deleted things out of it, we can literally just return it like this. Okay, so let's run this and see what happens. Nice, we passed. Before we hit submit, I do want to show you a little bit more about the values that you can put in here. So I'm going to comment this part out for a second. Let's say I wanted to delete, starting from the first value, every other value. We could do something just like this. We're going to say 0, then I'm going to put the colon, and I want to go to the fifth value. And remember, this one is going to be exclusive. So if we have 0, 1, 2, 3, 4, 5, it's just going to stop at Mordane. So Mordane will be the last value that it looks at to delete, and it won't even look at Gondolin over here. And then we can put a step here. If we put 2, it's going to skip every other one. So let's run this and see what happens. Okay, let's pull it up. We're starting at 0, so Rivendell should be deleted. Nice. Now we're going to skip this value, and we should be deleting Lonely Island. So yep, that doesn't make it in, right? But Morgoth Mountains do. And we're going to skip Mordia and delete Mordane. We should include Morgoth Mountains, Mordia, and Gondolin. Nice. So see how that's kind of similar to slicing? You can use it in pretty much the exact same way. Now, let's bring this back and we'll fix our code to how we had it. Boom. Now if we submit, this should work. Yay, nice job. Okay, cool. Now we're going to be moving on to tuples. In this section, we're going to talk about tuples. Tuples are another data structure in Python that are very similar to lists, but have some very important differences. So before we talk about the differences, let me show you a tuple in the code. All right, this right here is a tuple. It looks like a list, right? Except what you're probably noticing first is that we're using regular parentheses rather than square brackets. Now, let's run this code And then I have a diagram to go over what it's doing. So we're going to say Python 3, tuple.py. You can see it's working in this for loop exactly how you would expect a list to work. We're just using I to index into the tuple and we're getting the values, right? So when I is 0, we got 2. When I is, 2, we're getting true, right? Kind of like a list. But let's look at our diagram and I'll start to break down how they're going to be pretty different. So what exactly is a tuple? A tuple is a type of data structure that can store different types of data. However, unlike a list, once you've created your tuple and you put your values in there, you cannot change it. You can't add things to it. You can't take things out. So this is the idea of immutability, which we haven't talked about yet. We've been able to skirt around immutability until now. And now that we've made it to tuples, it's time to have the talk. Immutability is exactly how it sounds. It basically just tells us whether or not a type or a data structure or whatever in our code, usually types and data structures, whether or not we can change them. So if something is immutable, that means it cannot be changed. If it's mutable, it can be changed. So lists are mutable, tuples are not. Now, tuples. Why would we use a tuple over a list? Tuples are used for very small collections of items, especially ones where we know that that collection is going to stay about the same. So let's say you wanted a tuple that was just like included. I think the example on bootdev is like it has a dog's name and like their age in it. So you just create a tiny little tuple list that just has the name of the dog and their age. So 2 different type values, but a list of items is probably not going to change, right? That's when you would use a tuple. With tuples, it's okay to store different types of data. In general, it's bad practice to do that with lists. With lists, you want to keep the same types of data in there, even though you can technically put different types of data in a list. It's just bad practice. So you might want to use a tuple instead, if that's what you want to do. Store values together that are different types. Tuples are good for grouping data that you know you don't want to change, especially if it's small little groups of data. So just like lists, they can be looped over, they can be indexed into, but let's talk about how they're different from lists. So I have another little diagram over here, a little comparison chart. Okay, so on the left, we have our code that we just ran, right? We have a tuple, it's got these items, and then over here on the right, we've got a similar thing, a similar collection of data, but this time in a list syntax. So the first thing you're going to notice is that with the tuple, we're declaring with parentheses, and with the list, we're declaring with the square brackets, right? Or the brackies. Now, when we move down to the for loop, you can see that that's sort of similar too. We can, like I said, iterate over the tuple just like we would a list. We can index into it using I that we create when we declare I in the for loop. But after that, this is where it's going to start getting different. So with lists can be changed, right? We just learned a couple of ways to change lists. We can use append, like if we said list.append and then added this little value in there. We can delete items in the list by using the del keyword, and we can change individual items in a list by using the index, right? So if I say list at index 3 equals yo, what up, we're actually going to change index 3, which I believe is, 0, 1, 2, 3, 11.6. We would actually change that to yo, what up. But if you try to do these things with a tuple, you're going to get errors. And I can show you, but I do have them screenshotted and printed here. So I'm going to zoom in a little bit right over here so we can kind of read them better. With a tuple, we can't change the atoms. We can't add to a tuple once we've already declared it and put values in it in its declaration. If we try to add something, we're going to get an error like this. So let's try to add something real quick just so you can see and you actually, you believe me. Let's do right here, oops, after our for loop, I'm going to say tuple, oh my God, tuple.append, add me. All right, we'll save this and let's try to run this again. First, I'm going to clear. Boop. Boom. See, I told you. Why did you ever doubt me? Right here, it says tup.append add me, attribute error, tuple object has no attribute append. So what it's telling us is that tuples do not have the ability, do not have this built-in append method onto them because we're not allowed to change them in the first place. All right, so also we cannot delete from a tuple. So if we try to use the del keyword, like we do with lists, so let's say we say del tup of 1. We want to delete puppies here. And we would never want to delete puppies, by the way. This is just an example. Okay, let's clear it again and run. Boop, boop. Now we're getting this one here. Type error, tuple object doesn't support item deletion. So we can't delete things, right? Now, last thing. We cannot change the items that are already in the tuple like we can with a list. So if we try to do the same syntax like we do over here with the list to a tuple, again, we're going to get an error, but if you don't believe me, let's check it out. Let's say I want to change puppies. So tup1 equals kitties. All right, let's clear and run again. Boop, boop. Right there. Type error, tuple object does not support item assignment. So, if you don't believe me yet, I don't know what else to do for you. With tuples, we cannot change anything about them once they're declared and created and they have the items that we've given them on declaration. They are immutable. Now that we know the basic idea of tuples, let's work on this assignment. So, for this assignment, we have somebody helping us code our Fantasy Quest game, but their code is not very good. In this example, we've got, okay, they've coded this heroes list, which if you look at, has a pretty distinct pattern, right? We've got a name, a number, and then a Boolean. A name, a number, a Boolean. A name, a number, and a Boolean. Now, this looks like data that we probably don't want to change, right? But because we've put this in a list and we've sort of just mushed them all together into the list, this is kind of toxic because, like we just learned, lists are mutable. They can be changed, right? So, there's not really anything stopping somebody else who's coding our game with us from changing these values. It's a list type. Python is not going to stop them. So unless they know not to change these values, we can't make sure that they can't, I guess. Also, it's just kind of gross to have these all in these little indexes. You know, it's just, there's nothing stopping these groupings from getting messed up. So what we want to do for this assignment is change each of these into little tuples. So our list, because it's a list, it can hold different values, right? Lists can hold tuples. And since each of these little collections have the same sort of 3 pieces of data in them, or the same types, they can each be a tuple. And we'll just turn them each into their own tuple. And then our list will become a list of tuples, and everything will be happy and everything will be great. We can add more tuples to the list. We can, you know, get these tuples out. They're gonna stay how they are because they're tuples. It'll just be better, trust me. Okay, so how are we gonna do that? All we have to do is literally just surround each of these little collections of data with our parentheses. So right here, and then we wanna make sure, because this is a list, we wanna make sure to put the commas, right? Okay, next we're gonna go Gandalf here, little parenthesis, and right here, and then a comma. So right there, we've already made 2 tuples. This is the first tuple, and this is the second tuple. Okay, next. Oh God, no, not another list. Okay, make sure we put a comma, and then we have our last one. If I was better at typing, this wouldn't be so painful to watch. I apologize. All right, let's run this and see if it works. Nice. Okay, and let's submit it and see if it works. Yay! We took our list and we just broke it into a bunch of little tuples. Isn't that nice? Isn't that neat? Wasn't that fun? Okay, for the remaining lessons in chapter 9, we're going to finish out the chapter just by doing a couple of little practice assignments on lists. So for this first one, all we want to do is write a function which returns the first element from a list And if the list is empty, then we're going to return the string error instead. Now this is kind of good practice because a lot of the time, if you're coding or you're doing code wars, something like that, you're going to be getting lists and forgetting to check if they even have elements in them or values in them. And if they don't have a value in them and you're trying to do things like iterate over them or whatever, delete from them, you're going to get an error. So it's kind of good practice to make sure that the list that you're getting into your function and that you want to do work on actually has values in it. So right here, we're going to say if the length of items is greater than 0, then, so that's just checking to make sure we have at least one item in our items list. We're going to return the first value. Else, this is where we're going to put our little error. Return the string error. Okay, let's run this. Oop. Nice. Now I do kind of want to show you what happens if you forget to check if there's items. Let's say we didn't do this check, right? I'm just going to, let's see, can I comment all this out at once? I'm going to comment some of this out. Actually, you know what? Just going to delete it. So this, you could write this as simple as this, right? Return items 0. But this does not check to see if there even is an item 0. So likely we're going to get an error or a bug. You know, maybe if we submit. Nice. So see how when we ran the run cases, we got away with it because all of our little test case lists had items in them. But submit is always a little trickier. It's going to give us trickier tests. So when we hit submit, we do get this error. It's an index error saying that the list index is out of range. That's because our list is completely empty. There's nothing in there. All right, so let's bring this back to what we had it before, where we check to make sure. And now let's try to submit. Yay, nice. So let's go down to the one where we didn't have one. Boom. Error. Perfect. All right. Okay, let's go to the next assignment. For this assignment, what we're going to have to do is reverse a list. Now, it might sound a little daunting, but we actually know a couple of ways to do this. We could either use slicing or we could use a range for loop. So personally, I want to use the range for loop first, but we'll go over both just in case you want to see. All right, so item is going to be the list that we want to reverse. If we're going to do it with a for loop, we're going to say for I in range, we're going to start with the length of our list minus 1. And that's because if you remember about range, we can go backwards if we give a step of -1, right? So we haven't gotten to the step yet, but I'm planning ahead. We're going to give an ending value of -1. And here's our step. That's going to have us go backwards. So let me stop and explain this for a second because it does look kind of weird. Basically what we're saying is we want to start at the last index into our list. Because remember, length, if our items are 5, if there's 5 items in our items list, then the length is going to be 5, but the last index is going to be 4, right? Because we're starting at 0 going to 0, 1, 2, 3, 4. So we're starting with the last index. That's going to be our starting value. Then this is going to be our ending value, right? But remember that the ending value is inclusive. So if you might think that you want to put a 0 here because you want to go backwards through the list starting from the end to the beginning with the last index, but it's inclusive, or it's exclusive, sorry. It's exclusive. So if we use a 0 here, we're actually going to stop at index 1 and we're not going to include 0 at all. So we have to actually say -1. I know it's weird. Because we're going backwards and we want to include 0, so we have to go 1 past it, right, in the other direction. All right, and then our step is -1 so that we make sure that when we increment I, we're incrementing it by -1 or we're decrementing it by 1. We're going 1 backwards. Okay, so now that we have our range here, I'm going to create a new array. Sorry, I think I messed up my white space. We're going to call it reversed. Actually, let's create it outside of the for loop. We'll just make an empty one. So reversed equals these empty brackies. Now, in here, I'm just going to say append the items I. Now, throughout all of our little assignments, have been avoiding doing this because I think it looks gross. It's kind of like hard to read. So to make it easier, what you could do is say something like item equals items I. And that makes it much easier to read, right? Because now right here, I can just say item. All right, let's see where we are so far. Once we get out of our for loop, we want to return this so we can see it. Oops. All right, I'm gonna run it and see where we're at. Okay, it looks like we're passing, but let's see here. I'm gonna go with the numbers. It's gonna be a little easier to read. So our input was 1, 2, 300, 4, 5. Our output is 5, 4, 300, 2, 1. Nice, so that's how we would do it with a range for loop. Now, how would we do this with the slicing that we learned? Okay, I'm gonna get rid of this real quick. We'll keep reversed. Now, with slicing, it's gonna be slightly different. We're going to say, instead of saying that the reversed is this empty bracket, all we have to do is get a slice out of items, right? So remember that a slice is basically a sublist of items. It just includes all of the values in the list that we're slicing that we want it to include. So to reverse it, it's a little hacky. We're gonna have all of the items that are in items, but we're gonna use slicing to reverse those items. So we're gonna say reversed, and then we're gonna say items. Here's our little brackets where we're gonna do the slicing. We wanna start from the end. So we're gonna say length, items, and then -1, right? Just like we did in the last one. Then we wanna put our slicing operator. This is gonna be our end value. So our end value, we want it to include everything. So we don't have to put -1. We don't have to do anything weird like that. We're just gonna put another operator, and that'll tell Python, because it's slicing, it'll tell Python to include everything else, right? And then we're gonna put our step is gonna be -1. Okay, let's see what this does. Likely this is gonna look the same. Boom. So it looks the same because we were able to accomplish the reversing with the slicing. Okay, so those are the two ways that we could do it. Now let's submit this and see how we do. Yay, nice. Okay, so we're about to enter the last section of this chapter, and it's gonna be a big problem, so get ready. It's gonna be probably the most difficult problem we've solved so far, but it's gonna be fun. So I'll see you over there. Welcome to the end of chapter 9 on lists. This is going to be the pinnacle of all of our knowledge so far. This assignment is gonna be pretty tough. We're gonna be dealing with nested loops, which are a classic coding thing that you'll see a lot for solving different problems, but they're kind of complex. At least when I first had to do a nested loop, it was kind of complex and it was hard. But I'm gonna help you out. We're gonna do it together. Okay, for this assignment, we're basically taking messages from chat in our Fantasy Quest game, and we're filtering through them to make sure that they don't include the bad word dang. So our chat messages come in as a list of strings, right? Where is it? I think there's one, like this sort of. It comes in as a list of strings. Now we're gonna have to loop through the messages to get each message, but then we're gonna have to loop through each message to get each word to check if this word is dang. So before we just start trying to code this, let me show you my little diagram that I made for this to try and step through how we're gonna use a nested loop. Okay, here's my diagram. Here is our list called messages, and here are the items in it right now. We've got dang it Bobby, look at it go, and wow, where's the dang healer? So these are all messages that are in our chat right now in our Fantasy Quest game, and these are the ones we have to loop through to find if the bad word dang is in them. So you can already see that 2 of them have dang in them. So how are we gonna use nested for loops? Well, to do this, we're gonna have to use 2 loops because there are actually two things that we need to loop through, two types of things. The first loop, of course, is going to be our list of messages, and it's going to look like for current message in messages. So we'll have this current message variable that we create in the for loop declaration here. And then we're going to have our dang counter. Oops. And let's pretend that this was set to 0. Yeah, let's pretend that was set to 0 because that's where we're going to start, right? Now our second loop is going to be for each word in the current message. So if our current message is dang it Bobby, because our index is 0 into the messages list, and that's what we're looping through. If our current message is dang it Bobby, actually I gotta clean this up too, dang. Dang it Bobby! If our current message is dang it Bobby in our messages list, then in order to check each word in our message, we have to have this second loop. And this second loop is gonna be created by taking this message here and using the split operator or the split method here to split it into a list. And I'll show you what that means in a second. So once we've split the current message into a list, it will become a list of just each word. So index 0 into this new list will be dang, right? Index 1 will be it, and index 2 will be Bobby. So let me show you splitting first, because that's going to make this a little easier to understand. And I've got some code for it. So let's look at my code where we mess around and play with split. So here's messages. It has our two messages in it, dang it Bobby and look at it go. Now, first message, of course, is going to be messages 0, right? That's going to be dang it Bobby. I'm going to have it print here when we run this. We'll see that the first message is dang it Bobby. Now, if we split that message, if we say first message dot split, it's going to turn that message into a list of words. So, like I said before, dang will be one index, it will be the second index, and Bobby will be the third index, or the third value in the list. And then, if we want to get dang out of that list, we can say split bracket 0, and that'll be the first message in split. So let me run this, and it'll make a little bit more sense. So Python 3 split.py. Okay, so you can see here, first message is dang it Bobby, right? Because we're doing messages bracket 0. Now, split is dang it Bobby. That's our list. That's our list that we've created by splitting the first message, which is message 0, right? So dang it Bobby becomes a list of words. Now, the first word in our list is dang, right? So split here, that's our split message. So split 0 is the first word, that's dang, boom. You can see it right there. Okay, hopefully that makes sense. Let's go back to our little diagram and we'll step through the code that we're thinking about doing. All right, so to do this nested for loop, this is kind of what it's gonna look like. And I'm just gonna show this so that when we code it, it makes a little bit more sense. All right, so let's start with everything, you know, where it should be. These are all messed up, ignore those. All right, so this is our code. When our first loop starts, we're looping through messages. So we're gonna have this loop literally in the code for current message in message. Our iteration is gonna be the first iteration. So our current message is gonna be dang it Bobby. And we're gonna start our dang counter at 0. All right, now this second loop is gonna be inside our first loop. So it has to happen before our first loop can end. So for our second loop, we're gonna write it literally like this, for word in current message dot split. So current message dot split is going to split dang it Bobby into its words. So on our first iteration of this inner loop, our word is gonna be dang. See how that's working so far? All right, let's make sure everything is where it should be. So now here's our little question we're gonna be asking for each word. If word dang is equal to dang, then we're gonna increment dang counter by 1. So we can do that, right? We'll just replace this 0 with a 1. Nice. Now this iteration is gonna end. So let's put this word back. It's gonna be the second time the loop goes off. So remember how I said that the first loop, the outer loop, can't end until this second loop ends? We're gonna have to loop through all of the words in current message.split before this second loop ends, and this loop can go to its next iteration. So this is going to stay on the same iteration. We're basically pausing on this current message in our first loop until this second inner loop is done. And then the first loop will go again and we'll have a new message to look at. All right, so it's the second iteration of our second inner loop. Our current word is going to be it, right? Because we did dang already. Now we're on to it. So if it equals dang, counter goes up by 1, but it's not, so we're not going to move the counter. Nice. All right, so now it's going to be the third iteration, and we're looking at the word Bobby, right? So is Bobby equal to dang? It's not, so we're not going to increment the counter. Now, because we've looped through all the words in current message.split, this loop ends, okay? It's done. So we're going to put all these back. Boom. Now the first loop can go to its next iteration because everything that needed to happen within that iteration has finished happening. So we can change first to second, and we're now on the second message. The second message being, look at it go. All right, cool. So we've changed these. We're on our second iteration. Now another loop is starting because remember, we finished that first loop, and within each iteration of this outer loop, then this loop is going to start again with the next current message. So for word in current message.split, which is going to be this message split into its words. If we're on the first iteration, then the word is going to be look. We're going to do the same check, doesn't work out. So then we're going to go on to the next, right? Becomes the second iteration. The word becomes at. Boom, doesn't work out. So it becomes a third iteration. Did we do it already? I forget. Boom. Is the third iteration? Yeah, that works. Okay, so not dang. And then it's going to become the fourth iteration. And we look at go. Now this is the last word. This is the last word in current message.split. Fourth iteration. If this doesn't match, the loop ends and the first outer loop can start again. Now, we don't have to step through all of it again, but this would become the third iteration, right? We would get this last message in here, and we would do the same thing. We would iterate through the words in that message in this second inner loop. And when we find this dang right here, we're going to increase the counter by 1. It'll become 2. And by the time this inner loop ends, we've seen all the words in this current message. Then the outer loop is going to end, right? Because it's gone through all of the values in messages. And our dang counter will be 2. Okay, sick. So we've seen how a nested loop works. Now let's write one. Let's go back to boot dev and look at our assignment. So we're basically going to do exactly what that code does, or in the diagram. There are a few things that I left out that are going to be part of our return, but what we did with the diagram is the basic like backbone meat of the problem. So we're going to start there. Okay, so let's make our dang counter first. We're going to say dang counter. We're going to set it equal to 0. Now, I'm going to put comments so that we can keep track of this real easy. We want to loop through each message in messages. What we're going to do first. So we have our loop here. We're going to say for current message in messages. Nice. That's our outer loop. Okay, now in here, we want to loop through each word in the message, but first we should probably try to split the message into words, right? So we're going to use that split method. So we can do that right in the for loop, just like we did in the diagram. So I'm going to do that just like this. Let's put our note or our comment first. Loop through each word in current message. Okay, so we're just going to say for word in current message dot split like that. Whoops, like that. Cool. Now that's our inner loop. All we want to do for now, the backbone of our problem, is check if this word is dang, right? If word equals dang, then we're going to increment our dang counter. So dang counter plus equals 1. Okay, so that's literally the meat of it. Now, to check on how we're doing, to debug this and make sure that what we've coded so far is good, because remember, back in our earlier chapters, we talked about how the best way to sort of debug your own program is to do little pieces of it and then make sure each of those pieces are working. So let's do that before we move on. Okay, so right here, I want to make sure, let's see, our return is going to be a list of the same messages, but with all instances of the word dang removed, a list containing the number of dang words. So I'm going to do this. We're going to have 2 returns. I'm going to set the first one to none, and the second one, for now, I'm just going to set as dang counter. That's not what it's going to be, but I just want to see what dang counter is doing right now. So let's run and see what happens. So our first messages list has darn it, this dang thing won't work, let's fight one-on-one. So we're expecting at least 1 dang counter, right? You can see it down here that our first return is supposed to be the cleaned list, but we're just returning none. And our second return is a list of all the times that we found a dang in our messages. But right now, we've just got it set to 1. That's our dang counter. So it looks like it's working right now. We only have 1 message that has dang in it. Okay, so I think for now we can move on. To make sure that this is working smoothly and to help us with our debugging, I'm going to add some print statements just inside where we start our loops. First, we're going to print the current message. Current message, boop, wiggly mabob, and boom. And then in our second inner loop, we want to do the same thing, but for the word. That way, as we're looking through the output, we can see, you know, okay, I can see the current message is this, and the current word is that, you know, why did so-and-so happen? Or such and such, whatever. Let's say, I'm just going to say word. We'll keep it nice and consistent. Wiggle mabob, word. Cool. Okay, let's run this, make sure that's working just like we want it. Oh, I messed up somewhere. Okay, let's go to line 9. For wording, current message. Did I mess up some white space? Yes, look at that. Disgusting, disgusting. Okay, fixed. Now we can run. Okay, see how we got current message, darn it, word, darn, word, it. Perfect, love it. So with these print statements, we can tell that our inner and outer loops are working. We're pausing on each message in the messages list and looping through each of their words, right? So this dang thing won't work, this dang thing won't work. So congrats, we got our nested loops working. And that's actually pretty hard. I remember it being really hard, and you know what? Sometimes I still have an issue with it. So, all right, now that we've got that done, let's look at our problem statement here and make sure that we're doing everything. I already know that we aren't. So, what else do we need to get done now that we have the meat and potatoes coded? The hardest part. Now that we have the hardest part coded. Okay, so the 2 things we want to return. The first thing is a list of the same messages, but with all instances of the word dang removed. So we're going to want to take our messages and just remove dang if it's there. And then a list containing the number of dang words that were removed from the message at that particular index. So this is not going to be that hard. We just have to add 2 more lists in here, which we're going to use as these returns. So instead of a dang counter, just an int, I'm going to actually make a list, and we'll call it dang occurrences. And we'll start that as an empty list. Then, let me think about this. Our next thing is the message, but with the word dang removed. So I think I'm going to want the thing I'm going to want to return in the end is a list of all the filtered messages. So I'm going to make that here, and we'll set it to something, to an empty list again. Okay. Now, inside of our first for loop. So the idea behind the dang occurrences is that if a message has 2 dangs in it, you know, we would want to be able to catch that, and we would put 2 for that particular message. So let's think about that first. I might need another dang counter. Okay, yeah, I think I do want a dang counter. So we're gonna put dang counter back in. I'm gonna put it above the print statement, dang counter, and we're gonna set it equal to 0. So for each time this outer loop restarts, dang counter is going to become 0 again, and that's how I want it. Okay, now let's go inside of our for loop. This is where things are gonna get a little bit more interesting as we change it up and include all the work that we need to get done. So if we see the word dang, dang counter is gonna go up by 1. We also are gonna have to deal with the filtered messages. So if a word is not dang, I wanna put that into our filtered messages, but not here, because what we're gonna end up doing at the end is using the opposite method to split, which is join. And we haven't talked about join yet, but if you come down here and read, join is just going to take a list, and if we join it with some type of string like this, you can see this is just a space. If we say space dot join a list, it's going to take all the words in that list and join them into a string with a space between each word. So if you have hello there Sam in a list, and then you use space dot join that list, you're going to get hello there Sam as one string with the spaces in between each word that were in the list. So we're going to do that at the very end. So what I'm probably going to do is for each message, I'm going to have a list of words that are fine, and then we're going to join them. So I think it's actually okay to use filtered messages here. We'll do that. So if we see dang, we're going to increment the counter. But if a word is not dang, this is where I'm going to add it to our list, because it's a clean word, right? So we can include it. So we're going to say else filtered messages dot append this word. Nice. Okay, I think that's all the work that I want my inner for loop to do. Now we're going to have to think about what happens when all of this, or when this for loop ends for the current message, what we want to do next. All right, so when the inner loop ends, I want to stay within this first loop and continue to do a little bit more work, right, before the next iteration. So I'm going to come back out, and right here, we've potentially filled filtered messages with the words that are fine, right? So our return is going to be a list of the filtered messages, right? Yeah. So what's going to happen here is when we return, we're going to be returning the original message with the word dang removed, right? But if you think about it, the filtered messages that we return is actually going to be a list of strings like we got here, right? So let me find a good example. It's going to be exactly like this, except dang will be removed, right? So our filtered messages that we want to return would look like it, Bobby, look at it go. Now, what I'm trying to get at here is that we're probably going to have to we're going to want a list in here called filtered words instead of filtered messages. And then I'll show you what we're going to do with that. So we're going to set this equal to an empty list. That way, each time we have a new iteration of this for loop and get a new message, it's going to be reset to empty. So before the for loop ends, though, we don't want to just lose the words that we found. In the inner loop, instead of appending our clean words to filtered messages, let's instead append it to filtered words. Okay, so these are basically all the clean words in the current message. Now, before the iteration of the next loop, because like I said, the next iteration, filtered words, is going to be overwritten with an empty list. So we're going to lose all of our words that we appended into there. We want to take those words and make them into a string, and then we're going to add them to filtered messages. So we're going to do that right here. We're just going to say filtered messages dot append. Now, inside the append parentheses, we can use the join method. So we're going to say filtered messages dot append, and we're going to put, hang on, we got to put our space because we want spaces between our words. Oops, that is not a space. So we're going to make a little string with a space in it. Dot join, not dot join. My typing's so bad. And then we're going to put our filtered words list. Okay, now that's going to be in filtered messages. Now it's okay if we get rid of filtered words by resetting it to an empty value on the next iteration. The other thing is we have our dang counter. Dang counter is also going to be overwritten when this inner loop starts over again. So we want to make sure that we save the value that we get from the current message. So before this loop ends, we want to whoops, do something very similar. We're going to say dang occurrences dot append however many dangs we saw in that message. So dang counter. If I could type. Boom. All right. That was a lot of coding. Let's see how we're doing so far. Oh, and to do that, we're going to have to return filtered messages. This one. Okay, let's run it. Is it doing what we think? Let's look at our returns at the bottom. So darn it, this thing won't work. Let's fight one-on-one. This is what we ended up returning with our code. And that looks like what we were expecting, right? Because originally our messages were, darn it, this dang thing won't work. Let's fight one-on-one. So we were able to remove the one dang in the second message. Now we are still failing. That's okay. We'll fix that. It looks like the major part of our problem, we're actually doing well. We're removing the dangs and putting the filtered messages back into this filtered messages list. Okay, so the bulk of our code is working, but we're still failing, right? It looks like in our other return, we're able to return the filtered messages. That looks fine, but our words removed is not returning what we think. We want a tiny list of all the times that we removed a dang. Basically, each of these indexes matches up to one of the messages that we got in the input, right? So like for darn it, we didn't have to remove a dang, so we put a 0. So let's see what's going on with our return here. Now we have dang occurrences. That's the list we should be returning, but it looks like we're still returning the dang counter. So that's probably our bug. Let's fix this and see what happens. I'm also going to comment out some of our print statements because they're getting in the way of me being able to tell what the heck is happening in the output. Now let's run it and see what happens. Okay, cool. We're passing now. Nice. So remember, this is just the run test. We might not pass a submit, but let's see. Nice. We freaking nailed that. Okay, cool. So that's the end of chapter 9 on lists. I hope it was fun. Next, we're going to be talking about dictionaries. But until then, good job. You should be proud of yourself because nested for loops aren't easy. And I'm going to keep saying that. I will die on that hill. I still have issues with them. So congrats. You should be proud of yourself. All right. I'll see you in chapter 10. Welcome to chapter 10. We're going to be learning about dictionaries, which is the next data structure for this course. So we've already learned lists and tuples. Dictionaries are going to be another way to save pieces of data. The biggest difference, though, is that we're going to be saving each piece in a key value pair instead of just a single item demarcated by these commas like we would with a list and a tuple. So before we talk about tuples, let's go try to use one because I think using them in the code will help you understand what's happening. So here's my code. This is our dictionary. We're calling it potion. And these are the values that we're saving. These are the data points that we're saving inside of it. You can see here, this name value, this is actually a key. So each piece of data is saved, like I said, in a key value pair. The key is going to map to the value. So if you see, this is, we're not gonna run it yet, but if you see down here in this print statement, in the squiggle-mabobs of our F string, I'm referring to potion, the dictionary, and then I'm using brackets and putting name, the string here. Now, name is gonna be one of our keys, right? So when this prints, we're gonna get potion of spell power in this placeholder. Let's run it and I'll show you. So you believe me, ready? Boop. All right, so we have 2 messages here. You've taken a potion of spell power. Your spell critical has increased by 25%. Cool. So why do we use dictionaries? Dictionaries are a good way to save data for things like potions in our Fantasy Quest game, right? So in Fantasy Quest, we probably have multiple potions and they're each gonna have varying properties, but we can save the data on their properties in a similar way, right? Each of them is gonna have a name. Each of them is gonna have some stat that they buff, some resource pool that they affect, etc. Oops, let me fix this. We'll get to that later. So to cement this idea, we'll write another potion dictionary, but this is gonna be a completely different potion in our game. It's just gonna have the properties, like similar properties to this first one up here. So we're gonna call this potion, its name is going to be potion of defending. Okay, we're gonna put a comma here. That's the end of our key value pair. Now, the next property that I want to give it is I want to know what stat that it buffs. We're going to put a colon in between those. And this is going to buff our armor value, our armor rating. How about that? Cool. Now, I'm not going to fill out this entire potion dictionary, but do you kind of get the idea? Because we have multiple potions, it's nice to have a dictionary structure like this, because if we wanted to, let's say we put all of our potions in a list, if we wanted to iterate that list and get the name of each of our potions, we can do that really simply because we'll just say for each potion, potion bracket name, and that'll get us their names. Kind of nice, right? Okay, I'm gonna get rid of potion 1 here. Let's talk about this last F string just to cement how we're indexing into this dictionary. So in this second string, you see that the value is your spell critical has increased by 25%. That's because the first squiggle-mabob in our F string is holding potion bracket stat buff. So what's that going to be? Stat buff is the key, and stat buff in our dictionary maps to the value spell critical. Now this one over here, you see that we're using potion bracket multiplier. So multiplier is our key, and it's mapping to 0.25, this float here, which we're multiplying by 100 to get 25%, right? Now, the last thing I'm going to point out before we go check out our little diagram is that you can see that I've put a lot of white space in between our keys and their values. This is just a nice way to put it on the page so that it's very easy to tell what is mapping to what. Also notice that each pair is on its own line. They each get their own line. That also is going to help us read our code. It's going to help other people read our code and be able to visually tell what keys are mapping to what values and that this is a dictionary in the first place, right? So Python doesn't really care. Python doesn't care about the white space. It doesn't care that we're on new lines. It's going to let us run our code. This is totally valid syntax. It's just nice for other people reading our code. Now, I have a little diagram. We're just gonna go over a few points one more time to cement it. Okay, so here's potion. This is pretty much exactly the code we just ran. The only difference is that the colons are not nice and spaced out. So when we declare a dictionary, we're gonna be using squiggle-mabobs instead of square brackets like we would use with a list and regular parentheses that we use with tuples. Now, oops, let me draw something in here real quick. This is a comma. Nice. All right. The other thing I want to point out is that each value in our dictionary can be of differing types. So this string, this first value name is mapped to a string. Stat buff is mapped to another string. We've got a float. This is a tuple. The reason I'm pointing out the comma here is that when you have a tuple with a single item in it, you need to put a comma after that item, and that tells Python this is a tuple. So I had to write that in there because, you know, this is a mistake and I should have put it in there before. But this is a tuple, and then we've got a little list, and we even have a none type. So this is all valid. All of these values are good. They can be of any type. All right, enough about tuples. Let's try to use them in our code over here. Okay, so I want to get into this practice because I keep messing this up myself. We have one return out of this function. So I'm going to put a placeholder here, and we're just going to say none for now. All right, now that we've done that, for this assignment, all we have to do is take all of these parameters and put them into a dictionary and return that dictionary. So this function, we're using it in our fantasy quest game. It's creating a record of a character that includes that character's name, server, level, rank, and an ID, which we're going to create dynamically. So let's create the record here. I'm going to make this variable called record. I'm going to set it to these curly braces, and then we're going to fill those up. Before we code it, let's think about how we want to do this. If I were to be using this dictionary in the code and I wanted to get the name out of the record, then to get the name, I would probably have to access it like I showed before in our code, like this, right? Something has to go in these brackets to get the name value. So what do you think we're going to want to put here? The easiest thing, the most obvious thing is the string name, right? So when I create this key value pair, I want the key to be the string name, And I'm just going to map that to our parameter coming in, name. And I'm going to keep doing that down the line. That's super obvious, super simple. You know exactly what each value is going to be. So that's how I want to do it. That's how I want to solve this problem. Okay, so we're going to do server. We're going to do level, same thing. Remember, we're putting a colon in between the key and the value. And then at the end of our pair, we're putting the comma. That's to tell Python that we're done with that pair. We're moving on to the next one. Okay, let's make rank the string. And we're going to set that to rank again. And then it's time for ID, which is going to be our dynamic value that we're going to make in this function. So in our Fantasy Quest game, we want this ID for each character to be unique. So the way that we're going to try to make it unique is by concatenating the character's name and their server. Hopefully that helps prevent any overlap of other players' names in our game, right? If two people are named the same thing. So to make that, I'm going to make an F string here. The first squiggle mabob is going to have our name value in it. Then we're going to put a pound sign. And the second squiggle mabob is going to have our server. Cool. Now, last thing I want to point out before you try to run this, we can put a trailing comma here and Python will be fine with it. It's not going to yell at us. We could leave it out. It's still not going to yell at us. Let's make sure that this last squiggle mabob is indented over. I want to make sure that it's lined up with record up here so that Python doesn't get mad about our white space. Now, last things. Let's get rid of that and let's make sure we're returning our new record here. Cool. All right, we're ready to run this. Let's see what we got. Okay, we're passing. It looks like our ID is matching what was expected. Nice. Let's submit it. I think we're going to be good. I think we're going to be golden on this. Cool. Nice job. Now we know about dictionaries and we're going to practice doing different operations on them in the next couple sections. Okay, so when we have dictionaries and we're using keys to map to our data, our value, we cannot have duplicate keys. Technically we can, like Python's not going to yell at us if we have the same key twice, but we're going to lose data if we do that. So if I wrote this little dictionary and I was expecting the level key to map to level the parameter that's coming in, this would cause a bug because what's actually going to get mapped to it is this integer 1. Because when you have duplicate keys, Python is just going to take the last duplicate key that was created. So if I put let's say I put a third one all the way down here for level. If I said the level was insane and then we ran this, we're going to see that level is insane. So Python is just going to default to the last level key that was set in here. That's how we're going to be losing data. So for this assignment, all we have to do is make sure that we don't have duplicate keys. We don't have duplicate keys in our dictionary and that the one that we take out is the right one, right? So we have two levels here. I don't want to take out this one, which is the one that maps to our parameter. I want to take out the one that's just a hard-coded integer here. So take that out. Gross. Now we also have a second one. We have rank as a duplicate, but same thing. It's just like our last assignment. We want to keep the rank parameter as the value instead of this integer 2. Okay, this should be good. Let's try to run it and see if we win. Nice, we're winning, so let's submit. Good job. Okay, now that we're pretty comfortable with dictionaries, let's talk about manipulating them. First, we're going to start with accessing a dictionary and its values. Now, we've actually already seen this because we ran it in my code, right? Over here, where we did the print statements, this is accessing a dictionary. We're using the name of the key with the value that we want. We're using that key as the index into our dictionary to get that value, if that makes sense. So that's exactly what it looks like. Let me actually just put it on, in our code, let's just put it on a single line by itself to make it a little more obvious. Let's say I wanted to get the stat buff. I'm going to make a little variable here. We'll call it stat buff. And I'm going to set it equal to potion, bracket, stat buff. So that's all you have to do to access a dictionary and get a specific value out of it. Now I'm going to print this just to be sure. We'll do an F string, stat buff, squigglemabob, stat buff. Okay, let's run it. Nice. We got spell critical right there. So easy, right? Let's answer these questions. What kind of brackets are used to index into a dictionary? Just like with a list and a tuple, we're using square brackets to index in. Okay, all right, so how do we set values in our dictionary? Well, dictionaries are a little bit different from lists. We don't have to use append or anything like that. What we can do is to set a value in a dictionary, even if it doesn't already exist. So, okay, let's start over. If I have my potion dictionary here, let's get rid of this old code that we're done with. If I have my potion dictionary here and I want to add a value to it or a key value pair to it, let's say that I want to add something like, okay, we're talking about potions. Let's say I wanted to add a zone in the game that they drop in. All I would have to do is say potion, square bracket, zone drop, and set this equal to whatever that zone is that I want, whatever I want the zone to be. So in this case, it's northern elsewhere. That's where this potion drops in the game. This is going to be different than a list because this value zone drop doesn't exist. Now, if we were using a list and we were trying to set an index that doesn't exist, let's say our list has 5 items, so the last index is 4, but we want to add a 5th item. We can't just say, you know, list at index. Wait, we have 5 items. I said that wrong. If we wanted to add a 6th item, we wouldn't just be able to say list at index 5 equals this. It wouldn't allow us because we're going to be reaching past the ends of the list. But with a dictionary, we can do that. If zone drop, the key value pair, doesn't already exist in our list, we can just add it just like this. Now let me prove that to you. We're going to print this. We'll use an F string and we'll say, whoa, this potion only drops in, we'll do squigglemabob potion in our squiggly braces, we would say potion bracket zone drop. Okay, let's run this and see if I was able to set that value. This potion only drops in northern elsewhere. Nice, so it's pretty easy to set a value in a dictionary, even when it doesn't exist. Okay, now let's do our question here. Which is the correct syntax to create a new key value pair in an existing dictionary? Is it dict bracket key equals value, dict bracket key to this little arrow thing value, dict ... key equals value, or dict parentheses key equals value? It's going to be the first one, right? That's what we just did. Nice. We're going to talk about updating values in a dictionary. And the cool thing about updating is that it's going to be exactly the same as setting. So we just saw how we could set zone drop to a value, this key zone drop, in a dictionary where zone drop doesn't exist yet. Now let's say zone drop did exist in here. When am I ever going to get better at typing? Let's set it to a different zone. Let's see. Oh, and you might not know this, but if you know what game we're referencing right now, you will get extra points in boot dev, just so you know. That's a lie. That's actually a lie. Okay, anyway. Let's set the zone to Vardenfell. Nice. We'll save this. Now, what do you think? What do you think the zone is going to be when we print it? Boop. It's still northern elsewhere, right? So originally in our dictionary, the zone drop key mapped to the value Vardenfell, but we updated it simply by, using zone drop as the index and setting the value with an equal sign to our new value. So it's that easy. It's just like setting a value, like we did in the last section. Okay, let's answer this question. What happens if you assign a new value to an existing key? the value updates, the key and value are deleted, or a collision error occurs. Collision is the idea that something that already has that name already exists and it's causing a bug or an error. So it's going to be the first one. We don't have to worry about collision error, but I did want to throw that out there. The value is just going to be updated. Nice. Cool. Okay, so next we're going to be talking about deleting and other operations we can do on lists. Oh, nice. An achievement. It's time to learn how to delete values out of our dictionary. So let's go back to the code. It's going to be very similar to how we would delete something out of a list. We're going to be using the del keyword again, if you remember that from the list chapter. Okay, so if I want to delete this zone drop item here, I just have to say del potion, bracket, zone drop. Just like this. All right, to make sure that that actually worked, let's put a print statement to print out our entire dictionary. I'm just gonna put potion and we'll see if that value is in there or not. Oh, there we go. Boop. Okay, I'm gonna clear this. Okay, so it's kind of gross looking, but this is our dictionary. Now, at the very end, we shouldn't have the zone. Nice. So you see the last key value pair in here is other effects. So we actually deleted zone drop. Nice. Okay, so that was super easy, right? Let's go answer these questions. What happens if you try to delete or del a key that doesn't exist in the dictionary? Nothing. Damn it. You know, I was feeling lucky on that one. It's an error. Cool. Okay, next we're going to be talking about the in keyword. So I'll see you over there. The last operation that we're going to learn on dictionaries for this chapter is checking if a specific key exists in a dictionary. So let me bring you down to the code again and I'll show you what that looks like. If you remember from when we learned lists, we used the in keyword to check if something was in a list, and doing so created a Boolean value that we could use. So it's super similar with dictionaries. The only difference is that we can only search for a key in a dictionary and not the value using in. Okay, so I'm going to create this variable called isIn, and I'm going to set it equal to this expression here, stat buff in potion. Now this is going to resolve into a Boolean true or false, and that's what we're saving into the isIn variable. So down here I want to print that so we can check and see if it worked. So isIn right here. Now, when I run this, we should get a true printed to the console because stat buff does exist in our potion dictionary as a key. So let's run that and see what happens. Nice. Cool. Now I want to point out that when you're using the in keyword, you can only check with dictionaries. You can only check for if the key exists, not the value itself. I know that a lot of the times when we're working with dictionaries, we want the value and not the key. But remember that the key is what Python uses to index into the dictionary to get the value that's mapped to it. All right, so let me show you what I mean when I say that we can't use the value to index or look. We can't look for the value using in our dictionary. Okay, so let's say I wanted to look for the value that stat buff maps to, which is spell critical. Whoops. Boom. Now when we run this, we should get a false. Boop. Nice. False right there. Okay. All right. Now that we've seen how to search for a key in a dictionary, let's go look at our questions here. So for this assignment, we're getting a list, which is enemy names. And in that list are a bunch of enemy names, right? But some of the names are duplicated. And the idea is that this is a list of enemies that is within our player's radius in our fantasy quest game. So we want to tell the player how many of each enemy is within their radius or is, bound to attack them, right? So what we're going to do is we're going to loop through the list enemy names and we're going to create a dictionary, which in the dictionary, each key is going to be an enemy in the list. And the value associated with those keys are going to be integers that just tell us how many times that certain enemy was seen in our list. Okay, so let's start coding this. First thing I'm going to do is make sure that I put a little placeholder here for myself, because we're going to return our dictionary at the end, right? Now here, let's declare our dictionary. I'm just going to call it counts, and we're going to set it equal to this empty dictionary, or these little squiggle mabobs. Now, here we're going to have a for loop to go over the enemy names list. So for enemy, in enemy names, we're going to check if that enemy is already in our counts dictionary. And if they are, we're going to increment their value, the integer that's mapped to them, by 1. And if they're not, we're just going to set them as a value in our dictionary. So we're going to use the in keyword again. So if enemy in counts, we're just going to say counts of, or at bracket enemy, and we can just use the enemy variable. We don't have to use like a string enemy here, right? Because enemy probably is a string, right? It's enemy name, so this is going to be a string already. Counts enemy plus equals 1. Now, if counts enemy doesn't already exist, we can't do this plus equals 1 thing, because the value is not going to have an integer associated with it that we can plus equals, right? So we're going to take care of that in our little else block. So if the enemy is not in our dictionary, then we're going to put them in there, right? Else. And remember, when we talked about setting values in the dictionary, we can just use the value that we want to put into the dictionary, or the key. We can use that as an index and then set that value there. Let me show you what I mean to kind of jog your memory. Here we go. You just have to say counts enemy, even though it doesn't exist yet, equals 1. And we're going to set it to 1 because if that enemy wasn't already in our dictionary, now it is. So we've seen it 1 time, right? We don't want to set it to like 0 or something like that. Okay, cool. I think that looks good right now. Let's make sure that our return here makes sense. So I'm going to change this to counts, and whoops, we'll run it. Okay. For enemy in enemy names. Uh-oh, I put a semicolon. Oh no, what is this, JavaScript? Take that out. Now we should be good, right? Cool. Okay, so we're passing both these tests. Nice, nice, nice. Let's submit. I think we're gonna be good. Nice, cool. All right, good job. In this section, we're gonna talk about iterating over a dictionary, because just like lists, we can iterate over them. Let's go to my code. I've got 2 examples of iterating over a list and iterating over a dictionary so that we can see how similar they are. So I actually have 2 terminals here. Don't be overwhelmed. I'm just going to have one script print to one terminal and the other print to the other, just like this. So on the right-hand side, we have our list from before in the list chapter, player inventory, right? And we have all these little values in it. And then we have a for loop that iterates over it and prints each item. I'm going to run that. Oops, iterate list. Boom. Now over here, we have our potion area that we've been working with. And here's our for loop where we're going to iterate over it. Now, just like what we talked about in the last section, where we could only use the in keyword to find a key in the dictionary, it's going to be similar for iterating over it with a for loop. This value here, this ky that I've made, Python is going to save the current key for each iteration into that value. So let me show you. Iterate. Yep. Uh-oh, did I say 2? No, this is Python 3. Now let me clear that. Okay, so as you can see here, this is our little print statement for each iteration. I have the f string key set to the current key into potion. So we should be getting the values, right, from our key value pair. So this current key is the key into the name of our potion, which is Potion of Spell Power. This is a little confusing. I'm realizing that right now, but just think of it that way. We're using the key, this variable that we created in the for loop, to index into potion and get the value. So we have Potion of Spell Power, right? That's our first value for our first key, etc. down the line. So instead of the value being saved to key, it's just the key. That's why we have this here. Now, if I were to change this print statement and just put key, then we're going to get all of the keys for our potion dictionary printed. And then my print statement might make a little bit more sense. So let's look at that. There. So now we're actually getting the keys, right? Name, stat buff, multiplier, etc. So super similar, right, to what we learned about lists. So now let's go do the assignment on boot dev. Okay, so for this assignment, we're going to fix this function, get most common enemy, and it's taking in this dictionary, which is actually basically just the dictionary that we created a couple of lessons ago. So it is a dictionary full of enemy names as keys, and they're mapped to values, which tells us how many of those enemies are in the current area. So what we want to do is iterate through our dictionary and tell our player which enemy is the most common. We're going to be using the float negative int that we learned in the last chapter with lists. Okay, so I know that that's going to be a flag. So let's set that right here. I'm going to say, I'm literally going to call it most common enemy. And we're going to set it to float and the little string negative inf. So if you remember from the list chapter, this is going to create the value negative infinity and save it to our most common enemy variable. Now, we want to loop through our enemy dictionary and do our checks. So for enemy in enemy dicts. So at the very end in our little problem statement, we want to make sure that if there are no enemies that we return none. So before we even create our most common enemy, let's do that, because if our enemies dictionary is empty, we just want to return none right away. And we can do that using not, which we learned, at the very beginning of this course a couple chapters ago. So, okay, this is what it's going to look like. If not enemies dict, we can return here. We're returning something specific. We're returning none. So if we just return right here, it will return none, right? That's the default. Okay, remember when we were talking about if statements before, that we're checking for falsy versus truthy values. So none is going to be falsy, none is falsy, but this is also going to return falsy if the enemy dictionary is empty. So if enemies dictionary as it's coming in looks like this, if I could spell, if it's empty like this is considered falsy by the if statement. So when we ask if not enemies dict and it looks like this empty dictionary, this is going to be true, right? It's going to resolve to true. Basically, enemies dictionary is falsy and will return right here. All right. Now that we got that taken care of, let's return back to our for loop. We're going to create our most common enemy thing here. And then we're going to do our for loop. So for enemy in enemies dictionary. If enemy, geez, why can I not spell enemy? If enemy is greater than our most common enemy. If enemy is greater than our most common enemy, then we're going to reset most common enemy. Most common enemy equals, now actually, now that I'm writing this, I'm realizing that we're messing something up right here. Remember that our dictionary is full of key value pairs. So if I were to just keep this enemy thing here, right now we're just looking at the key, right? So we actually have to make sure that that we have the value mapped to that key when we do this conditional. So I'm actually going to create the value up here. I'm going to call it enemy occurrences. So the value right in our enemies dictionary for each enemy is how many times they occur. Am I spelling that right? Enemy occurrences equals, we're going to go back into enemies dict and use the key that we're currently on, like this. Nice. Okay, now, instead of asking this here, we can say enemy occurrences. So if enemy occurrences, and I'll bring this down so we can see it a little better. If enemy occurrences is greater than the most common enemy, then we're going to reset most common enemy to our enemy occurrences. All right. Okay, so, and one more thing here, because this is a key value pair, and we want to be returning the name, we're not returning the most common enemy. We're not going to return this, which is just an integer. We want to return the name of the enemy that is the most common. So I'm going to make another variable right here, and I'm going to say name equals enemy, because that's the name of the enemy is the key that we're using to get this value, their occurrences. Okay, cool. Now, let's see how this is doing. We've written a lot of code, but not really checked it yet. I'm going to return name and just see if this is doing what I thought it was doing. All right, let's look. Okay, we're passing. That's awesome. So let's look at one of them. Here, we're returning the name Gremlin because Gremlin has the most common, or has the most occurrences, right? It has 5 when the others have 1, 2, 3. Now this one should be soldier because it's 10. Nice. Okay, so if we submit this, we should be good. Here we go. Cool. Now I want to see real quick. Yes. Oh, did I say that before we even got? Nice job. I want to see what happens when we have no enemies. Make sure that's working. So like we already know, the submit test cases is where little bugs like this are going to be caught. Cool. All right. That's pretty good. Now we just have one more section in this chapter, so I'll see you over there. We've made it to the end of chapter 10, but before you go, we're going to talk about ordered and unordered because it's kind of important and it's a recent thing that's happened with Python. So basically, before Python version 3.7, dictionaries were unordered, which meant that when you declared your dictionary with all of its values in a certain order, if you tried to loop over that dictionary and print all of the keys for each iteration, they could possibly print in an order other than how you actually declared them. And that's because that's how Python was saving those values in memory, just in like random addresses. So it has since changed. Dictionaries starting from Python version 3.7 are now ordered. So whatever order that you declare all of the values in your dictionary in will stay. So now when you make a dictionary and you loop over it and you print the keys, those keys will print in the exact order that you put them. So that's it. It's important to know because that's, I guess, kind of a big deal in the Python world. All right, we just have one question. Here we go. Python dictionaries before 3.7 were unordered, toxic, gross. We don't like that. We want order. We always want order. Order is the most important thing, right? Just kidding. But that's the end of chapter 10. I will see you in chapter 11. And, good job. Welcome to chapter 11, where we're going to be learning about sets. And this is going to be the last data structure that we learn in this Python course. So sets are a lot like lists. They hold items, but the one big difference between sets and lists is that sets can only hold one of each item. So everything in the set has to be unique. There can't be any duplicates. When we use sets, a question that we ask, or that they help us ask, is, does this value belong in this set? And that can be a very powerful question. There's an entire mathematical field based on set theory, which we're not going to go into. But in Python, what we primarily use sets for is to check if a value is in a set, get rid of duplicate values out of other structures like lists, and also for really fast lookup. So let's go check out a set in the code. Okay, so in this code, we have a list called player inventory. You've seen it before. Let me actually bring this up by like a lot. So we have the player inventory list, which we've been using for a couple of lessons now. You can see that it has gold, iron breastplate, potion of healing, shield, another potion of healing, scroll of fire, and another potion of healing. Now, when we use this set function to create a set, and when we give it this player inventory list, what it's going to do is create a set of all the items in our player inventory. So it's going to basically remove all of the duplicate items because sets can only have one of each item, one of each unique item, no duplicates, right? So I have this variable here. I've called it unique items, and I've set it equal to a set created from the player inventory list. So when I run this code and print unique items in this F string, what do you think is going to print? Let's check it out. So I'm going to do Python 3. I think I called this set.py. Yeah. Okay. The following items are in your inventory: scroll of fire, iron breastplate, 200 gold, shield, potion of healing. So notice how with potion of healing, there's only one. When up in the actual player inventory list, we had 3 right here, and right here. Cool. So that's one basic use of a set, just getting rid of duplicate values in something like a list. Now, you might have noticed in the output that these values in the set are printed in a different order than we actually place them in the list. So you can see this list starts with 200 gold, but down here we're starting with scroll of fire. Iron breastplate happens to be in the same spot, but potion of healing instead is 200 gold down here. So another important thing to know about sets is that they're unordered, which we talked about at the end of the last chapter. What unordered means is that the way that Python handles sets makes it so that you can't iterate over them and get the same order that they're declared in. They're pretty much always going to be in a different order than what you created in your code. Because sets are unordered, this makes them kind of clumsy to iterate over, but it actually makes them faster to find a value in. And I'm going to show you what I mean. So I've got a diagram over here. We're going to compare finding a value in a list versus finding a value in a set, and why finding a single value in a set is a lot faster and more efficient in Python. Okay, so if we look at this first diagram, we're going to be comparing looking for a single value in a list versus looking for a value in a set. And I'm going to show you why looking for a single value in a set is a lot faster and more efficient in Python. So this is a list here. This is our player inventory list. And I'm going to show you what Python has to do when we ask the question, is shield in player inventory? So pretend here that we're setting this variable shield in player inventory to this Boolean shield in player inventory, right? We remember from lists that when we use the in keyword, we're asking the question, is shield in player inventory the list? So this is going to be a true or false Boolean, right? So when we ask Python that, what Python has to do to figure it out is it actually has to visit each index into our list or each value in our list sequentially. So it's going to have to go to player inventory 0, check, oh, that's not a shield. Then it goes to 1, check, nope, that's not a shield. Then it goes to 2, it checks, nope, that's still not a shield. It visits 3, boom, it finds the shield. So in order for Python to find a single value in a list, it has to visit every single value in that list in order. So that's pretty slow. We have to see a bunch of values that aren't the shield, potentially. Like if shield was in the first index, obviously we'd find it pretty fast, but potentially we'd have to visit every single value in order to figure that out. So like imagine if we weren't looking for the shield, imagine if we were looking for something that wasn't in our list, like puppy. We would have to visit 0, 1, 2, 3, 4 before Python could say puppy is not in this list, right? That's not efficient, it's pretty slow. So this is how a set works when it comes to finding a value. So with a set, when we're looking for a value in a set, Python puts the value through an equation or a function, and the result tells Python where to look. So it's a lot faster because basically if you're looking for shield, and you tell Python that with the same code, item in inventory equals shield in player inventory. Imagine player inventory right now is a set and not a list. When you ask that question with a set, Python is going to take the value you're looking for, it's going to run it through this function, and it's going to get a unique number out of that. And that number is basically going to be the address that that value lives in memory. Every value in your set is going to return a different result, and that's why it's a lot faster to look things up. Because instead of having to visit every single value to find the one that you want, all Python has to do is put it through this function and get the unique address out of the result and look there. So let me show you another example. Let's say we weren't looking for the shield. Let's say instead we wanted to find the potion of healing. So if we wanted to find the potion of healing, the value is going to go through this function. It's going to result in this result, right? In this case, it's going to be 6. And then Python is going to know, okay, potion of healing is at 6. So it's a much faster and more efficient way to look for a value. Now this is a little outside of the scope of boot dev, but I wanted to show you this because it's a big reason that you use sets in Python. So you might be wondering what happens if there are 2 shields in your set. Well, if you remember from the beginning, we can't have 2 shields in the set because a set will never have any duplicate values. Python will not allow duplicate values in the set. So that's another reason why we're able to do this function type lookup, because every value in the set is unique, so they're all going to have a unique address that they result through this function. Okay, before we move on, I just want to point out that this is a very simplified version of what's going on. I just wanted to sort of introduce the idea and explain why sets are used over lists sometimes in Python. Okay, so now that we've gone over that and we understand sets and what they're useful for, let's learn how to create a set. So I'm going to go back to my code. You can see here that we're creating a set with this unique items, and we're doing it with this set function, right? But there's another way to create sets, and that's if you just do, you can just do this. So I'm going to get rid of this player inventory thing. We're not going to use this anymore. I'm just going to create a random set here. We'll just call it my set. Let me delete this too. And we're going to say it's going to equal to curly brace. Let's say potion of healing 200 gold. And I don't know, bronze, whoa, bronze sword. So you can see here, to create a set, we just use these curly brackets, but there is a caveat, right? Because we've already seen one data set that is created with curly brackets, and those are dictionaries, right? Now, the way that Python knows that this is not a dictionary is obviously these are not key value pairs. However, if you were to try to make a new set, so let's say my set 2, an empty one, and you just did this, Python would treat this as a dictionary. So there is a caveat, right? You can't do this because this will create a dictionary, since that's how we declare an empty dictionary. So if you wanted to declare an empty set, you would use the set function like this and just not give it anything. Nice. All right. So that's the basic syntax for creating a set. Now, how do we add items to a set? All right. So if I have my set here, get rid of this, and I want to add an item, all I have to do is use another, we're just going to use another method. So I've got my set here and I want to add, let's say, I don't know, 500 arrows. We just use this add method. So we say mySet.add, and then in here we can add a single item. So that's going to be 500 arrows, right? Now, if we run this code, which is going to print our set, you'll see that 500 arrows is going to appear in there, right? Boom, right there. Notice again how the order is unordered, right? If this were a list and I had added 500 arrows with dot append, it would have gone to the very end. But like we've been talking about, sets are unordered. So this is going to print differently than how it's done up here in the code. Okay, so now that we know how to add and create, let's talk about iterating over a set. So like I said at the beginning, because they're unordered, it's a little clumsy to iterate over a set, but you still can. And the syntax is going to be basically the same. So let's make a for loop. It's just going to say for item in my set. So just like lists, we can use the in keyword here. And if I print the item, we'll say, let me do an F string. Wigglemabob item. You'll see that we're visiting every item, but it is going to be out of order, right? Boom. 200 gold, potion of healing, 500 arrows, bronze sword, and then there's our last print statement. Cool. Okay, so we have some basic operations that we can do on sets. We We're starting to understand sets. Let's try to do the assignment on boot dev. Okay, so for this assignment, we're receiving this spells list, and all we have to do is remove the duplicates out of it. So we've already seen how to do this. This is what I did at the very beginning with the player inventory. We're just going to make a new set using the set function, and we're going to give it the spells list that we're having given to us in the function as a parameter. So I'm going to call this unique spells, and I'm going to set it equal to the set function, and I'm going to give the set function the spells list. Now, just be able to return unique spells right here. Okay, let's run this. Oh, you know what? Actually, I'm forgetting something. We are going to do this, but I forgot that we actually, from this function, need to return a list. So we're receiving a list, we're taking out all the duplicates, and then we're going to create a new list out of without those duplicates. So actually, let's take this out. I'm going to put none as a placeholder, and we're going to have to iterate over our set to create a new list. So I'm going to declare a new list up here. This is the one we're going to return. I'll call it, we'll just say new list. It's going to be an empty list. And we'll do our for loop here. So for item in unique, let's call it for spell in unique spells. I'm just going to append that current spell to our new list. So new list dot append spell. Okay, now that we've created our new list using the set, we can return that here. Nice. Okay, let's run and make sure this is actually working. Boop. Okay, cool. We're passing. Let's see if there's an input where we have duplicates. Yeah, so this first one, you can see there's multiple fireball items in here. And we're returning a list with only one fireball. So that's working really well. Looks like we're passing all of these. Let's try to submit. Nice, good job. All right, so welcome to the next section. Before we do these questions, we're going to talk about removing items from a set. So let's go back to my code. Oops, not that one. Friggin' this one. Now, remember how we just learned how to add a value to our set? Well, removing is going to be super similar. We're just going to use another method, and that's literally going to be dot remove. So I have my set, right? It's got a potion of healing, 200 gold, bronze sword. We add 500 arrows. Now let's remove one of those. I'm going to say my set dot remove. And we're pretending maybe our player just blew 200 gold on like a new sword or something. I'm going to remove that. Now, if we run this, we shouldn't see 200 gold printed in our little F string. Cool. So we got 500 arrows, a potion of healing, and a bronze sword. No more gold, right? So it's that easy to remove items from a set. So let's do these questions, and then we'll be all done with this chapter. So the first question is, how do I remove an item from a set? Is it my set.remove item? Yes, I'm not even going to read the other ones because we just did that, right? Nice. Okay, next question. What is the type of my val in the following statement? My val equals empty curly braces. Okay, we just talked about this too, right? So sets are made with curly braces, but so are dictionaries. So if you're trying to declare an empty set, you can't use empty curly braces because that will create a dictionary in Python. Instead, you have to use the set function. So if we use my val equals these empty curly braces, we're actually going to be creating a dictionary, right? Nice job. Okay, next. Which would be a good use of a set? To store ID user pairs? Probably not. That would be a dictionary, right? Because dictionaries have the key value pair as values in them. To store all the possible spells in a game? That could be good. To store all the enemies in a game by difficulty. I'm going to say this one. Yes. So if you think about it, our game, the fantasy quest game, we could have thousands of potions, hundreds of potions, right? it would be a good place to store all the possible potions as sort of like a reference for the potions that exist, right? It wouldn't be like storing potions in like a player's inventory where they could have multiple of the same type. This would be like, hey, what are all the potions in the game? Let me go look at my set, which has one of each unique potion in it, so I can see what all the possible potions are. Hopefully that makes sense. Okay, next question. Oh, that's it. Nice. Okay, well, you know all about sets now, and I'll see you in the next chapter. Welcome to chapter 12, and congratulations because you made it to the last chapter in the course. So I want you to take a second and pat yourself on the back, because after this chapter on errors, you've accomplished the hardest part about learning how to code, and that's starting. So congrats. Good on you. All right. So this chapter is going to be pretty easy because it's going to mostly be review. If you remember back in chapter 1, we learned about errors and we learned about our first error type, which is syntax errors. Well, we're going to go over syntax errors and then we're going to go over exceptions. And you've actually seen exceptions. We've been seeing exceptions and errors throughout the lessons as we've been messing up our code, which is totally normal. We all mess up our code. Even the most accomplished programmers run into errors and bugs and whatnot. So this is going to be easy. It's going to be fun. All right, let's start by talking about syntax errors and exceptions. In Python, you can basically divide all the error types into two major groups: syntax errors and then exceptions. And the main difference between them is that syntax errors are going to crash your program. Your program's not going to run at all. Whereas exceptions, your program is written fine, it's syntactically correct, but there's some type of error in your logic that is causing it to crash or break or whatever. So I'm going to show you the difference in this code down here. All right, in this code, we have player inventory, which is a list, right? It's set to an empty list, and then we're printing, look, I'm running. Then we're trying to create this first item variable and set it to player inventory 0. But I have a syntax error here. Instead of using a square closing bracket, I'm using a squiggle-mabob closing squiggle-mabob. So this is a syntax error. If you remember back in chapter 1, syntax errors basically mean that something about how we've written the source code is breaking the syntax rules for that language. And every language has different rules about syntax. So in Python, this is going to break the syntax, and Python is not going to run our code at all. Let me show you. We're going to say Python 3 syntax py. Boom. You can see we have the syntax error here. It's telling us that the closing parenthesis doesn't match the opening one. And if this code had run before this error, right, we would have gotten this print statement. But we didn't get that at all because Python is refusing to run this code. It's not valid source code. Now, if we fix this syntax error and we make this a closing curly or a closing square bracket, now when we try to run it, we're going to get a different type of error. Boom. So we get an index error because our list index is out of range. This is an exception type error. Meaning that it is a flaw in our logic. The code was able to run it first, and then it ran into our flaw, our logical flaw, and it crashed. And you can tell that it ran because we got this first print statement, right? Look, I'm running right here, which didn't run when we got the syntax error. So what is the flaw in our logic right now? Well, I have this player inventory variable. It's set to an empty list, and then I'm trying to make this first item variable and set it to the first item in player inventory. But there is no first item, right? So Python is saying, hey, there's an index error. So that's the main difference between syntax errors and other types of exceptions. Okay, so now that we know the main difference between syntax errors and exceptions, how can we possibly handle exceptions in our code? Because it's actually pretty normal to have things which arise in our code that are going to cause errors and to handle them. So as an example, let's say in Fantasy Quest, they're trying to shoot a bow at an enemy, but they have no arrows left in their inventory. That would be an example of an exception or a logical flaw that we could catch and handle because it's likely to happen at some point, right? So let me show you how we could catch and handle exceptions in our code. So Python does error handling using a try except format, and that's what this is here. We have this try block, and then we have an except block. Now, the try block is going to run the code that's within it, and if an error occurs while running that code, then the except block is going to catch it. Now, I have a little diagram. The except block is going to accept the error, catch it, and handle it. And what this is going to do is it's going to prevent our code from crashing on this error. So let me show you. I'm going to say Python 3 try, boom. There was an error getting the first item, list index out of range. And then you see this print statement down here, made it this far, ignore the also part. That's running just to show that whether or not there's an error, this is going to run. Python, we're catching the error and we're handling it and preventing it from crashing our entire code. So that's what a try except does. Now the except line is gonna look a little funky, but basically what it's saying is it's saying except exception, and exception we'll learn about a little more later in this chapter, but exception is the blanket error type in Python. So exception, when you tell Python except exception, you're telling it catch all of the errors that possibly go on, right? And then it's going to save that error into this E variable, which we're printing here right after item, right? List index out of range. That's the error description attached to the exception that we catch. Okay, cool. So now that we have a little understanding of try except, let's try to answer the questions in bootdev. All right, so in this assignment, all we're going to do is wrap this code in a try except, because if we run this right now, there might be a bug, right? Look at that right there. The player ID was not found. So we want to catch this exception, prevent it from crashing our code, and if it occurs, we're just going to print it. We're just going to print it to output instead of just allowing it to crash the code. So we're just going to add a try here. Put a colon, then we're going to take all of these lines and indent them over. And then after that, we're going to have our except block. So we're going to say except exception as E. And E is the variable that we're saving that exception in. So if we want to print the exception, we just say, well, we index, or not, we indent over and we say print E. And that will tell us what the exception is. Okay, let's run and see what happens. Nice. So it looks like in our run cases, the fourth case or the fourth test is where the player ID is not found. And that's why we're getting this print statement here. And I can even show that a little further. If we do an F string, we're gonna have to fix this after, right? Because this is an output type test. So our output has to be correct in order for us to pass. But just to show you, if we put E and we say, or I'm sorry, if we put the F string and we say the error is, and then put our squiggle and bobs around the E with a closing quote, now we can see very clearly that this is where the error is happening. The error is all player ID not found. All right, let's take that all out because we want to be able to submit this. We'll put the E back and let's hit submit. We should be good. Nice, good job. Okay, so the next couple of questions are just going to be review, but I do want to show you this little diagram I made as another review. I think it'll make it easier to understand what's going on. So the try except, this is a screenshot from the code we just did in the last section. Doing a try except is sort of like an if-elif block. It's sort of like an if-else statement. You're basically saying, if there's no error running this code, then run the code, right? Else, if there is an error when we try to run it, then we're gonna print the error down here. Does that kind of make sense? So also we talked about how with the except block, we're creating this little E variable, and that's how Python is saving the error. It's saving it in that E variable for us to print. And then remember that when we use try except to catch errors, depending on how we're catching the errors, especially if we're using this blanket exception to catch all of the error types, then the code underneath will be able to run. Now, I'm saying that because we'll learn soon that there's different types of errors and you can catch them. You can catch specific types. But if you're catching specific types of errors, but your code in the try block causes another error that you don't catch, then you haven't caught that error and the program will crash. But we'll see that soon. So as long as you're catching all of the errors from your code that you're trying to run, this last print statement will run, because that's what try except is allowing us to do. It's allowing us to run the code whether or not there's errors. And it'll just give us an option to handle the errors as they pop up. Okay, let's go to boot dev and answer these 2 questions. So if no exceptions are raised in the try block, the program crashes. The except block won't execute. The except block executes with a none exception, or a no exception error is raised. Is raised. Okay, so basically it's saying if in our try block, the code actually is able to execute, then no exception is going to be raised, right? The program's not going to crash because it's running. The except block won't execute. I like that one. The except block executes with a none exception. No, that's not going to happen. A no exception error is raised. No. So if the code we're trying to run runs, this obviously is not going to run. But if we had valid code in here that has no logical errors or anything, then the except block is never going to happen at all. Boom. Nice. Okay, next question. If an exception is raised outside of a try block, the program crashes and prints the exception, or the exception is automatically caught and handled. It's going to be this first one, right? If we're not handling the exception, if we're not doing anything to try to catch an exception, then it's just going to crash our program. Just like I showed in that first code where we weren't doing anything with the errors, the program's just gonna crash, right? So it's gonna be this one. Nice. All right, moving on to the next section. So in coding, there is a difference between errors and bugs. Normally when we're referring to errors, we're talking about flaws in our code which we can expect, anticipate, and actually handle ourselves. Now when we're talking about bugs, we're talking about flaws in the logic of our code that we don't anticipate and which we usually don't catch until after we've already shipped the code or it's already in production. Usually these bugs show up and they're harder to find because we don't know what's causing them, and we have to do a lot more debugging and searching through the code to find them. So a good example of an error versus a bug. In our game Fantasy Quest, a good error example or exception example would be if we have a player who's trying to shoot their bow, they're trying to shoot arrows with their bow at a target, right? But they've run out of arrows in their inventory. That would be, if they tried to shoot an arrow and didn't have any, that would be an error, and we could catch that, we could anticipate it, and basically handle that error by telling the player, hey, you don't have any arrows in your inventory, you can't shoot anymore. Now a bug would be something like, if somebody is playing the game and they notice that when they have 0 arrows in their inventory, they're still able to shoot at an enemy. We didn't mean to code it that way. We don't know that that's doing that, but it's a bug that the player finds later in which we're going to have to debug and figure out. So I have some code to show you the difference between the two. Let's go down here. Now in this code, I have player inventory, which we've been working with for the last couple of chapters. And you can see right here in the second index, or index 1, we have this little dictionary where we have an arrow count key that is pointing to the value 5. So pretend this is our Fantasy Quest game and we've got this function where we're going to allow the player to shoot an arrow. So we call this function shoot arrow. We create a variable, player arrows, which is player inventory at the index 1, and then total arrows, which is the value of that dictionary, which is player arrows bracket arrow count, which is going to be how many arrows they have. Now we're going to print shooting arrow, and we're doing a check here. If total arrows is greater than 0, then we'll decrement arrows by 1 after they've shot the arrow at an enemy, right? Now here is where we can handle, or this is one way to handle our exception or our error that we're expecting. If the total arrows is less than or equal to 0, we're going to have this else block, which is going to fire off, and we're going to raise our own custom exception. So this is basically like creating our own error and raising it so that Python will print it to the output. Now, this is going to cause our code to crash because we're raising an error, right? And because we're raising that error, the code is going to crash. But we will see in the output that when it crashes, we'll have our own custom string here printed along with the error. So let me show you how that's going to look. I'm going to say python3 error.py. Now, when we have, so right now, while we have 5 arrows and we shoot 1, we're not going to get a crash, right? But if I set this to 0, so the player has no arrows in their inventory, and now we run it. Whoops. I was going to clear first. Here we go. You can see that an error happens. Our program crashes, and down here you can see our custom output. Not enough arrows, right? So by raising an exception, we've basically triggered our own error, and we're causing the program to crash based on the error that it triggers. All right, so now that we kind of understand how to raise an exception, let's go do the assignment on boot dev. So for this assignment, we're going to fix this get player record function, which takes a player ID parameter. And right now, if we run this, let me pull this out, we'll run it. We can see that for some of the test cases we're passing, but some we're failing, right? That's because right now the code is only handling when a player ID is either 1, 2, or 3. If player ID is 1, we do this. If it's 2, we do this. And if it's 3, we do this. But right here, you can see that the player ID is 4, which we're not handling at all. Now, this is the type of case that we want to handle with a raise exception. So what we're going to do is instead of having this pass here, we're going to put an else, which is basically, if you remember from our chapter on if-else stuff, we put this else here. We're going to be able to raise an exception for every other case where the player ID is not 1, 2, or 3, right? So we just say raise exception. Oops, I gotta spell it right. Boom. And we're going to give it the string, the custom string that we want printed to the output when this raise exception executes. So we're gonna say player ID not found. All right, let's run this and make sure that it's working. Cool, so we're passing. Here's our player ID of 4, which we didn't handle in the code. So we're catching that in the else block. You can see this is our custom exception, I guess, string descriptor thing. And yeah, this is looking good. So let's try to submit it and see if we got it. Nice, good job. All right, so we're gonna do the next 3 questions. And it's just going to be a little review. So, which keyword triggers an exception in Python? Is it throw, raise, exception, or error? It's going to be raise. You might want to say exception down here, but this is not actually the trigger word. Exception is just a type of object in Python, which we'll talk about a little bit later. All right, let's go next. Good code doesn't need to handle errors. It should be error-free. Is this true or false? This is going to be false. All code is going to have errors because we can never predict, or sometimes we can predict what errors we're going to be able to catch and handle, and other errors we're not going to be able to predict, and those would be bugs, right? But it's almost impossible to write code that has no errors at all. So this is false. All right, cool. Now we're moving on to the next section. Like we talked about in the beginning of this chapter, exceptions in Python have different types, and Python is able to do that by using things called classes and objects, which we're not going to learn about in this course, but which you'll learn about in the next upcoming course after this one, which is all about object-oriented programming. So because exceptions can come in different types, we can check for specific types and handle them how we want. So let me show you an example of what I mean. We're going to go back to our code, and this is how we left it before, right? This is the shoot arrow code where our player in the Fantasy Quest game is trying to shoot an arrow at an enemy, and we're handling whether or not they have enough arrows in their inventory. So I'm actually going to change this to a none instead of 0, and that's going to tell us that there are no arrows in their inventory, right? So we were handling this with an if-else statement and raising an exception if there were no arrows. But now let's try to use a try and accept block. This is a better way of handling our errors. I'm going to show you how that looks. I'm basically just going to get rid of this. So where we had that first if statement, we're going to put our try here. So, right, we want to surround the code that we're trying with this try block. So if we're not able to decrement the arrows by 1, then instead of having this else statement, we're going to catch any exceptions. So I'm going to say except, and here I'm going to put something specific. I'm going to catch a specific type of exception, and that's going to be a type error. All right, let's put a print statement in here. We're going to say error. There are not enough arrows in the inventory. All right, now, before we run this, let me just explain what we just did. So we have our try and accept block, right? But this time we're going to be accepting a specific type of error. So when we try this code, if an exception is raised, but it is not a type error, then this is not going to run. If we run this code and no exception is raised, then the code is just going to run and that'll be it, right? Now, if a type error is raised, that's when this is going to fire off. So whatever exception is thrown by our code in the try block, it has to be a type error type exception in order for this to run, this print statement. So let's try to run this and see what happens. All right, cool. So you can see here that we got our error type, or our string, and we know for sure that this is a type error because this would only have happened if there was a type error that was thrown. Now, why is it a type error? That's because we've set the value to this arrow count key to none. And when you try to decrement none by 1, well, you can't because it is a none type, and none types you are not able to decrement. So that's what it looks like to catch a specific exception, or to catch an exception by its specific type. But just because we can do that doesn't mean that we should ignore catching every type of exception. You always want to have an accept block that catches the exception type in general, because like we talked about at the beginning, the exception type in Python is basically the parent or root type of exception. So all exception types adopt the exception type, if that makes sense. This is the base type. So every exception that branches off of this into its own specific type of error adopts this exception type. So this block will catch every type of exception, if that makes sense. So we're going to say as E, and we're going to print E here. Now, there's a reason that I've put this accept block after our specific one, right? Because if I were to have put this above the other accept block, then the type error that gets thrown up here would be caught by this first, because, right, this one catches every type of exception. So if this one catches the type error before this one, then this one's not going to run at all. And I'll show you that right now. Oh, I knew I messed something up. Hang on. I put this, we'll do right here. Whoops. Okay, let's get rid of this line and we'll be good. So when I run this code, the type error is still going to happen, but this block is going to catch it. So we're just going to see this E and we're not going to see this string here. All right, let me clear and we'll run it. Boom. So see this shooting arrow, and now unsupported operand type minus equals none type and int. So that's our type error. We're not getting this printed to the output because this never runs, because the error gets caught by this accept block. Okay, so now that we've seen how to handle specific types of errors, let's try to do our assignment up here. So for this assignment, we have this handle get player record function, and it's actually going to call this get player record function down here, this other function. Now this function, if you look at it, is going to raise its own exception if the player ID is less than 0. So because this one is raising an exception, this exception is basically going to be a return sort of, but only when you raise an exception out of a function, a try can catch that. A try except block can catch that. It's not technically a return, but it kind of gets treated like one in the code. So let me show you what I mean. So what we're going to do is we're going to wrap the call to this other function in a try block, because since this is going to raise an exception, we want it to be able to be caught over here with this try block. So we're going to say get player record, and we're going to give it the player ID that we have as a parameter in this function. We're calling it, but we're also going to be returning it. So let's add a return right here. Let me make sure my white space makes sense. So we're going to say that. Boom. Now, if anything happens, we want our accept block to catch that. So we're going to add this accept block, and there are two errors that we want to catch. One is going to be the index error, and the other is just every other error, right? So let's say I just catch every error right here. We do exception as E, colon, and then we say print E. If I were to run this code right now, actually, let's do it this way. Let's try to catch the specific error first. So we're going to say except index error. And then let me get rid of, whoops. We get rid of this line. If there is an index error returned or thrown by the function that we're calling in the try block, then we're going to return the string index is too high. Okay, now if I were to run this, which I'm going to, you're going to see that it's not going to pass all of our test cases. In fact, it's going to crash because our test cases are actually going to be throwing multiple errors. This down here, in the case that this player ID is less than 0, this is raising a regular type exception with this description string, right? So likely what's happening in these run test cases is that one of the player IDs in the test cases is less than 0, but we're not catching the exception that's being thrown by this function when that happens. We're only catching an index error right now. So to fix this, we need to add our accept exception block so we catch everything else, right? There. Now we're just going to return E. Okay, let's try to run it now and we'll see what happens. Cool. So let's see if we can find our two different errors that we're handling. Here's our index error. Index is too high, right? That's the string that we're returning in case of an index error. And then right here, negative ID is not allowed. So you might think, well, hey, we don't actually do that here. We just return E, right? But check it out. Down here, this is the exception that's being raised by this function. Negative IDs are not allowed. So that's E. That's what we're returning here. That's why we're getting it in the output down here. Cool. So we're passing all of these. Let's submit it and see what happens. Nice job. Cool. Moving on to some review. Okay, we're at the end of chapter 12. We're just going to do a couple of review questions and then you're finished with this course. So let's get started. Okay, for this question, we're going to look at this little code snippet over here. The question is, in the code sample, what will happen? The program will crash with an uncaught exception or it will print 0. Now, this is where I'm going to point out that this little description that's attached to exceptions and which we see printed in the output is not the same as the actual exception type itself. So this code, if you look at it, we have a try except block, right? In the try part, we're raising an exception and the description we're giving it, the custom string that we're giving it is 0 division. Then we have an accept block that accepts a 0 division error. But it's kind of misleading, right? This is not necessarily going to, this is not going to be a 0 division error. Right here, we're raising a regular exception. We're not raising a specific exception. Just because we've given it the 0 division string description doesn't make it a 0 division type error. So the program's going to crash with an uncaught exception because we're raising this exception, but nothing is catching it. Because this is a regular exception type. Like we talked about at the beginning, exception is like the parent class for all exceptions in Python. So every type of exception, including 0 division errors, every type of error adopts the exception class. So because we're not catching that exception, because we don't have our last except block that catches exception, the entire class of errors, this is not being caught at all. because it's not a zero division error. It is a regular exception type error. So the answer is that the program's going to crash. All right, next. In this code sample, what's going to happen? The program will crash with an uncaught exception. It will print 0, or it's going to print other. So this is very similar. It's the same code, except now we're adding the except block that's going to catch every other type of exception that is not a zero division error. So now this one that we're raising in the try block is going to be caught by this except block. So because it's getting caught, this code is going to run, and we will see that the output is other. Cool. Okay, we got one more question. All right. In the code sample, what's going to happen? The program will crash with an uncaught exception, or will print other. So in this try block, we're dividing by 0, and a zero division error is a type of exception, but we're not catching that specifically. Instead, we're using this except block where we're going to catch every type of exception. So this, basically in the try block, Python's going to try to divide by 0. This is going to throw a zero division error, which will be caught by this except block because the exception class, the parent class exception, is adopted by all exception types. So it basically umbrellas all of the types, which means this zero division error is going to be caught here. So we're going to see other printed, right? Nice. Cool. So other than the challenges, you've finished the Learn Python course. Congrats. I think next after this is the object-oriented Python class. You're going to love it. But besides that, congratulations. You've done the hardest part about learning how to code, and that is just getting started learning how to code. So you should feel proud of yourself. And, until next time.